is how to use our mouse. So when using AutoCAD, it is important that your mouse has not only a left and right click, but also a center scroll wheel. So with the left click, we select objects. With the right click, we will bring up a shortcut menu, and we'll use escape to close that down. With the scroll wheel, when we scroll it out and in, this is how we zoom. So using the scroll wheel on the mouse, we're able to zoom in and zoom out. Also with the scroll wheel, this is how we pan. So if we click and hold the wheel in, we'll see our hand symbol, and this is how we pan. And just let go to finish. So click the wheel in, we can go left, right, up, down. This is how we pan our drawing, and scroll in and out to zoom. Now that we understand how to use the mouse, we're now going to look at how we can select certain objects. To do this, I need you to open up a file which is attached to this video. Once downloaded, you can open it from your download folder. It'll be in the Files to Share folder if you've downloaded the entire folder. The name of the file is Object Selection, so we'll open that. So here we have a series of circles which I've drawn. So I'm going to show you how we can use our mouse to select the objects and different ways in which we can select the objects. So the first is called window selection. So I'll come down to the bottom right hand corner of those circles, click once, and then extend my mouse to the top right, and we'll see we have a blue window. The blue window is our window selection. So I click once, let go, and move my mouse to the top right hand corner. If I click again for the second time, all of my circles will be selected. I'll press escape to cancel that. So again, I'll come down to the bottom left hand corner, click once to turn on my window selection. And you'll notice when I hover over the circle, it becomes highlighted once it is entirely inside that blue window. So if a small section of that circle comes outside the window, it will not be active. So I'm going to zoom in to show you that. I'm going to use my scroll wheel to zoom in. And when I move my mouse over the circle, you see once the entire circle is inside the window, it becomes highlighted. Once it's highlighted, I will then click once, it then becomes selected. So escape, click once, drag my window to the top right, and once the whole circle is inside, it becomes highlighted, and I can then select it by clicking once again on the screen. I'm going to press escape, and then zoom back out with my scroll wheel, click and hold in to pan just to center these circles. So next we'll look at another type of selection window. This one is called the crossing selection. So I'll come to the bottom right hand corner this time, click once and go to the top left hand corner. You'll see that the window is now green. So our crossing selection is green. The difference between the blue window and the green window, if I zoom into the bottom right hand corner, all I have to do is touch the circle and it then becomes highlighted. So once it's highlighted, I'll then click and it is now selected. So the blue window, the entire circle has to be inside that window, but for the green crossing window, I simply have to touch the object. So again, blue window, all the circles have to be inside, and the green window I simply have to touch. The next type is called a window polygon. For the window polygon, I'll click once down the bottom left-hand corner, which gives me my blue window. Next, I'll type in WP, so WP, and to enter that command into the command line, I'll press the Enter. What that does now, it converts that window into a polyline. I'll cover what a polyline is in the upcoming video. What this allows me to do is to just click and place, and again, all those circles must be inside the window in order to be selected. So you can see that the window polygon wants to continue on. As long as I continue to press the left mouse button, I can continue on. So to complete the action, I press Enter. Now I've only selected those 3 circles. I'll press Escape. We can also do the same for the green window, so the crossing polygon. So come down to the bottom right hand corner, activate the green window. And this time I'll type in CP, Enter. Again, it will convert into a polyline, which in turn creates a polygon. And for this one, the window again just has to touch the circle to be active. And Enter. So the reason we use these object selection is just to speed up the selection process. Instead of just clicking on each circle, which can take some time, we can use those window selections to speed up the process. And finally, there's one last object selection tool where we'll click and hold on the mouse and we can create what's called a lasso. Again, as it's blue, all the circle has to be inside the lasso, and I let go of the mouse for it to become selected. Same applies for the bottom right hand corner. We get the green window and we can use the lasso that way as well. If there are scenarios, if we can't use those object selection methods and we have to select each one individually, which can take time, there will be times when you've incorrectly selected a circle which you didn't want to select, and instead of having to press Escape and doing everything again, what we can do is we can deselect certain objects. The way in which we deselect an object will be hold the Shift key, and when I hover over the circle, you'll see there's a negative symbol now attached to the cursor. If I let go of the Shift key, the negative symbol disappears. So I'll click and hold the Shift key again. You'll see that the negative symbol appears on the cursor. So I'll select, which in turn deselects those objects. Now that we know how to use our mouse, we're going to be looking at how to activate the first tool. The first tool which we're going to be using is the line tool, and it's how we're going to be able to draw our straight lines. The way in which we activate and deactivate tools applies to all tools in AutoCAD. First thing we'll do is we'll select the tool, which is in our Home tab, in our Draw panel, and it's the first tool, it's our line tool. So what we do is we first select it with one left click of the mouse, come into the drawing, and referring to the command line, if we're ever unclear about what is the first step, just simply come down to the command line and it'll tell you what to do. There is also a command response attached to the cursor. You can see in the center of the screen, it's now telling me to specify the first point. So with one left click of the mouse, we'll place our first point, Once the first point has been placed, we'll then move our mouse in the direction which we want to go. So I'm going to the right-hand side. So I'm going to stretch it out to the right. And then once I'm happy with the position, again, to place the second point, there'll be one left click with the mouse. And we'll see we've placed our second point. The tool will continue to be activated until we either click on the next point or deactivate the tool. So we can continue left clicking with the mouse to create our lines. Within AutoCAD, there are many ways to carry out the same action. So to deactivate this line tool, we can either press the escape key, we can press enter, or we can right click and cancel. So you can click on escape, enter, or right click and cancel. So using the pan feature, by clicking on the scroll wheel, I'm going to pan up to give us some more space. And we'll repeat the process. So we'll go to our line tool, one click, come into the drawing area, one click with the left side of the mouse, move the line in the direction I want to go, and one click with the left side of the mouse again. And we can continue on until we either click on the escape key, enter, or right click and cancel. Within AutoCAD, when you're drawing, you're going to be drawing lines at a very quick pace as you progress. So to be able to deactivate and activate a tool very quickly is key to the speed at which you draw. So in order to continue using the line tool, instead of having to return back and selecting the line from the draw panel, because the line tool was the last activated tool, I can press the enter key and it will turn the line tool back on. So now I can click, draw my lines, press enter to turn it off, and enter to turn it back on. Enter to turn it off, enter to turn it back on. And enter again. Again, we can do this multiple ways. So you could as well use the spacebar. So spacebar to turn it on, spacebar to turn it off. We're now going to be looking at how we can use our object snap or OSnap. For this task, I need you to open up the file attached to this video. And once downloaded, go to your download folder and open the file. So the file name is called Object Snap. We'll open that. So I'm going to give you an introduction now to our first drawing aid, which is our Object Snap. Coming down to the status bar, our Object Snap symbol is a square, and in the top left-hand corner is a small circle. When it's blue, it means that it's on, and when it's gray, it is off. Also, if we hover over the feature, it'll display in the little info box above. So we want it to be blue, so we can use the Object Snap. To the right of that is an arrow. When we click that, it opens up all of the different snaps which are currently active. So we're now going to go over each one of these object snaps. But first I'm going to show you why they are important. What I'm going to do is turn off endpoint. So we have a small tick to show that endpoint is currently active. If we turn one click of the mouse, we'll deactivate the endpoint. We'll then come back into our drawing. What we want to do now is we want to activate our line tool and draw a line. First we'll come to the draw panel in the home tab. One click will activate our line. What we want to do is snap to the end of this line. What that means is we want to connect our new line to that existing line. And with AutoCAD, we want to be 100% accurate with everything we do. So using those snap tools allows us to snap directly to the end of that line. As I have the object snap turned off, what I'm going to do is draw my new line at the end of this line. So without the tool, I'm going to click where I believe it to be the end of the line and draw out, enter to finish. So it looks like those two lines are connected. If I hover my mouse over where they connect and scroll with the wheel, which allows me to zoom in, you see they aren't connected. So I'll zoom back out with the scroll wheel. Come down and turn on my end point. Come back into the drawing. Select my line tool. Hover over the end of the line and we see that we get this green square. So the green square means that is our end point. If you refer to the notes, all of these icons are displayed within the notes on page 8. So the end point is a green square, and once that green square appears, the software is telling me that if I click, the new line will be attached to the existing line. So the software is helping us out by doing so. So having this aid turned on gives us that accuracy which we're trying to achieve. Once the green square appears, one click of the mouse, move my line in the direction I want to draw, click again to complete, enter to finish. Now if I zoom back over on our previous line again, we'll see that they're not connected. We zoom in on our new line and we see that the lines are connected. So this is what we want to achieve. Next on the list is called midpoint. The midpoint snap will look for the midpoint of the line. If I turn that on, select my line tool. Instead of me trying to work out where's the center point of that line, if I go roughly where I believe it to be, I will get a green triangle. Not only will I get the green triangle, but the little info box will appear and tell me that that is the midpoint. So I hover over where I believe the midpoint to be. The green triangle appears. Once that green triangle appears, one click of the mouse will start my line at the midpoint of that line. So again, I'll select my line. We'll go on this left-hand side line here. I'll look for where I believe the midpoint to be. The green triangle appears. One click of the mouse, enter to finish. So that line now is at the midpoint of that line. Again, we'll come back to our OSnap drop-down menu. The next is the center point. It's currently turned on, so that's great. Again, we'll select our line, move over to the circle here to the right-hand side, and we want to find the center point of that line. Again, instead of us trying to calculate that ourselves by drawing the cross-section over the circle, we can use this drawing aid to help us find that very quickly. So I'll move into the center of the circle. If it doesn't appear first, hover over the edge of the circle and you'll see the center point appears. And once the green circle with the white crosshair in the middle appears, we'll move back in and select it. The reason it didn't appear the first time is because when you're drawing a project, there'll be thousands of lines on your screen. So you don't want AutoCAD to be pulling up the midpoint, center point of everything around you. So if it doesn't appear like that, you'll just hover over the edge of the circle. That green circle will appear and we'll move back and click on it. So again, we'll select our line, hover over the edge of the circle. The green circle in the center point appears, click, and we've drawn our line. Next is the geometric center. So the geometric center will snap to the center point of what will be the geometric center of that object. This will only occur if the line is a polyline, not just a simple line. In the upcoming video, I'll explain in more detail what a polyline is. So we'll turn on the geometric center. We'll choose our line tool. We'll come here to our square. I'll zoom in with the scroll wheel. What we're doing is we're looking for the center point of this square. Again, it's not appearing. So I'll hover over the edge of the square. And once I do, the geometric center is now appearing in that square. So I'll come back, hover over. Once it becomes green, click, and enter. So that line is now snapped to the geometric center point of that square. Next is a node. So we'll turn that on. So a node is a single point. So instead of a line, it's a single point in AutoCAD. And if we zoom into the square above, I have drawn a node previously. So that is just one point in AutoCAD. And for us to snap to that, the node snap must be turned on. So we'll now go to our line tool, go straight in, and the node symbol is a circle with a green X in the middle. And once that appears, we'll click once, and there's our line. What I'll do is I'll turn the node off, the geometric center, just so they're not getting in our way through this demonstration. Next we have the quadrant, which will activate. So we'll zoom into this circle here. So this snap will be looking for the quadrant points of this circle. To find them quickly, I can show you we can just click on the circle and we'll get the blue grips. So the location of these blue grips are the quadrants. So we have, let's say, 0 degrees, 90, 180, 270. And to snap to those quadrant points, we have quadrant turned on. We'll come back to our line tool. When we hover over those points, it is in a diamond shape. So we'll click on the top once, twice, 3 times, 4, and come back to the top to complete. Enter to finish. So there are our 4 quadrants of this circle. And we'll zoom out again. So I'll turn that off. And next we're looking for intersection, which is currently turned on, which is great. So the intersection snap is looking for the point of intersection of any object. So that could be a line, arc, circle, polyline. So any point of intersection. So again, we'll click on our line tool, and any point of intersection there will show up as an X. So where the line and the circle meet, it's an X. Where the 2 lines meet will be an X. 2 circles meet is an X. So we can click where any of those X's appear. And that is our intersection. And enter to finish. And next is the extension. For this, we'll pan over to the right-hand side. And in this scenario, we have one solid line and one broken line. What we want to do is extend this shorter line to meet the longer line. So we have extension turned on. What we'll do is we'll zoom in to make it clearer. We'll then select our line tool. And we're then going to click once at the end of the line and then move in the direction of the line. And you'll see that the line is extending and it's locked into the same angle as the starting line. And we can continue on till we meet the intersection. Once we meet the point of intersection of that line, we'll click, and that's our extension line drawn. We can also select the line and extend it out. So we'll click on the end of that grip, and we can do the same thing. We can drag that line in the same direction and pull it into the middle. Where we see the snap point, we can click. And we'll zoom out to the next. So this here we have a chair in block form. So we will be covering blocks later on in the course, but just for a demonstration of all of our snaps, we'll show you here. So this series of lines have basically been joined in what is called a block. So all of the lines are now joined together as one single object, which we can create a chair. And when we do that, we put it into a library. So if we open up a new file, a new project, and we want that chair from that library, we will insert it in, but instead of that chair just being placed into the drawing at a random point, we use what is called an insertion point, which is this blue grip here. We will come down now and turn on the insertion. And again, we'll use our line tool. When we hover over the insertion point, the symbol itself is two squares joined together at the bottom right-hand corner and on the top left-hand corner. Again, once that symbol appears, we will click, and there's our line. So that line is now attached to the insertion point of that chair. The insertion of this chair and everything will make more sense later on in the course. And we'll pan over to the next section. And here we have our perpendicular. So I'll turn off insertion, turn off extension. So we'll also turn off intersection and midpoint. The reason I'm doing that is so they don't interfere when I'm showing you the perpendicular snap. So we'll select our line tool, snap to the end of the line using the end point, which is the green square. Move the cursor down, and when we reach the lower line, we will get our perpendicular symbol, which is an L shape. So once we see the perpendicular snap, one click of the mouse, and we've drawn our line straight down. We've connected to the lower line, and we are certain that it is perpendicular. We'll next move over to the next object, our circle. And what we're going to do is draw a line in tangent to this circle. So we'll go to our object snap, turn tangent on. So we'll select our line tool and come down to, say, the bottom left-hand corner here. One click of the mouse. Then we hover over the edge of the circle, and we'll see that tangent symbol will appear, which is a circle with the line on top. So when it appears, one click of the mouse, and we can send our line out. Pressing enter, we know that that line is now tangent to the circle. We'll now scroll over to the next section. For this one, we need to turn off all other snaps as they'll interfere with this one. It's one that generally I don't use personally because too much interference with the other snaps, but I'll obviously demonstrate what it is. So what it's looking for is the nearest point. So we'll turn nearest on, select our line, and we'll see there, it's attaching to the line, but it's not giving us any definition, like is it the end point, is it the midpoint, is it perpendicular? It's unclear. But all it will do is it will snap, and we know that the line is attached to the second line, but we don't know at which point. So we'll turn that one off. So next is apparent intersection. This snap is used in 3D, and what it is where two lines apparently intersect in that 3D model. So it's not something we're going to cover in this course. And the last one we're going to look at now is parallel. So we'll click our line. What we'll do is we'll just click anywhere to start. And what we want to do is draw a line parallel to the line above it. So to do that and to tell the software that we want to draw this line parallel to the line above, we need to hover over the line first. We get that parallel symbol. Then we come back. And once they become parallel, it snaps and we get this dotted green line. From that, we can now just extend our line out, and we are certain that our new line is parallel to the existing line. and one click of the mouse to draw our line. And lastly, we'll just come back to our object snaps. Down the bottom, we have object snap settings. So we've just been using essentially what is like a quick access to these drafting settings. And if you're ever unclear of a particular snap, you can come in and hover over that point and it'll give you a quick description of what it does. So to continue on with the course, and generally the object snaps which I find the most helpful is what we're going to turn on now. So first I'm going to turn off parallel, and the snaps which we're going to be using time and time again will be endpoint, midpoint, center, and intersection. All the other snaps we can come back and turn them on and turn them off when we're drafting our drawing. But the current snaps which I've selected are ones that we're going to use time and time again. So we'll select OK. We can now close down this file, and it's best that you don't save, so when you come back the drawing will be fresh and then you can repeat the process in the future. So don't save it, and we'll come back to our main project file. Now that we're comfortable with the line tool, we're now going to move on to polylines. So in the Home tab, our Draw panel, next to the line tool, we have our polyline tool. A polyline is a connected sequence of line segments created as a single object. You can create straight line segments, arc segments, or a combination of the two. So when we draw with our line tool, each one of those lines, they are individual line segments. When we use the polyline tool, those line segments are joined together as one complete object. And what I'm going to do is I'm going to use a couple of tools which we haven't covered yet, but I'm just going to demonstrate how we can use them with the polyline and how they can benefit us when modeling. So I'm going to draw a line. I'm going to draw a polyline. I'm also going to draw a rectangle using the line and a rectangle using the polyline. There's no need to follow what I'm doing. I'm simply going to demonstrate the use of different tools and how they can benefit us while using it for a polyline over a line. So first on the left we have our line, and on the right we have our polyline. So if I wanted to move this rectangle using the move tool, I have to select each of the lines to move it. If not, I'll just be able to pick up one individual line. It doesn't move together as one object. But when you draw it as a polyline, and I use the move tool, it'll select it as one single object. The lines are individual and the polyline are joined together. If I wanted to offset, if I offset this rectangle, again we see that the lines aren't joined. And if we wanted to join them together, we'd have to use our extend tool to join these lines, which will take time. So if we were to draw that rectangle using the polyline, we can offset the entire object at once. Also, when using the line tool, when we select it, we get 3 grips. We have the endpoints, which we can click and drag and reposition the line. and the middle grip will pick it up and move it. So one click will attach it to your cursor and click again to place it back. With the polyline, we have the endpoints where we can adjust the position, the start point and the finishing point. And in the middle as well, we can click to move. So click attaches to the cursor and we can move it. As it's a polyline, we can also hover over that center grip. And a little options bar appears where we can stretch. We can add a vertex, which is the blue grip. So we can now make that into 2 lines. And again, going back to the center grip, hovering over, bringing up the options, we can convert that to an arc. So this is only possible with a polyline. So hover over, bring up the small menu, convert to arc. And using the endpoint grip, we can extend that out and change the radius. In our drawing space, we have quite a lot of lines which we don't need. So what we're now going to do is learn how to delete these lines from our drawing. Again, there are many methods which we can do this. There are long ways and there are quick ways. First things first, we'll zoom into any particular line. We'll then go to the Home tab, and we're in the Modify panel. And here we have the Erase tool. What we'll do is we'll select the Erase tool, and you'll see on our cursor there's a little white square, and it's telling us to select the object. When we hover the cursor over the line, we see it becomes grayed out, and there's a small red X. So that's showing what will be deleted. And to select that, we'll click once with the left click of the mouse. And you now see it's grayed out and the red X has disappeared. So that is now selected. The reason it hasn't been deleted is because we can continue on and delete other lines. So I can select each one of these lines. To then complete the process, I will click Enter on the keyboard. And now the lines have been deleted. So that process was click on the Erase tool, select the line, and enter to complete the action. We'll then pan over to where we have more lines, and we can select any one of the lines, and we'll then click the Delete key on the keyboard. Most keyboards will have a backspace and a delete key. We want to hit the Delete key. Once you select the line, just one click of the Delete key will delete the object. We can also use our hotkeys, so E on the keyboard. When we select E in the command line, we'll see a list of commands will appear. So the hotkey for the Erase tool is E, so we'll click on E, and then to enter that command, we'll press Enter. And now we'll select our object and enter to complete. You can also select the line, right click and erase. To keep it simple, the delete key on the keyboard is the quickest way of erasing our objects. So what we'll do now is we'll utilize our green crossing window, select those lines, and one click on the delete key will erase all of those lines. Now we have cleaned up our drawing. We're now going to look at the options settings for the interface. We can access that in 2 ways. We can either go to the application menu, come down to the bottom and select options, or we can type in OP and enter. So the options is where all the settings for the interface are located. On the top left, we see we have current profile. It currently says unnamed profile. We'll get to that at the end. And on the right hand side, it shows what drawing is currently open. And the options is organized using all of the tabs at the top here. First one is our files. So what this section is referring to are the file paths and file locations for certain things like our printer settings, our template files, or data sources, that kind of thing. So basically it's the file path for AutoCAD to use to search for certain information on our computer. So there's quite a lot of information to dive into all of this. So what I'll do is I'll give an example which you can follow for each of the headings. So what we've done already is we've already covered a template. So we understand what a template is. And what we can do is we can change and alter the file path for AutoCAD so that it goes to a particular folder. So if we scroll down, we have template settings. We can hit the plus symbol, which will expand it. So in here we have our drawing template file location. So if I click on the plus symbol to expand that out, there is our file path for our template. So there on my computer within this folder is the location of my template file. So if I change the template file location on my computer, I must change the file path, otherwise AutoCAD will not find it. Next we'll come down to default template file name for QNew. So when we create a new template file, what we can do is we can actually specify exactly what template file we want AutoCAD to use. So when we press the plus symbol, it says none. So what we can do to add in a template file is we could go to Browse, and that will go into our template file location, and there are our templates. So when we click on New, we can open up a particular template file. So choose Open. Every time I want to open up a new template file, the AutoCAD ISO.dwt will be chosen. So for each one of those headings, it's all the same step for what we've just done. So I won't cover all of the other headings, as the format for what we've just done is all the same. Next over we have our display, so our current display of our interface. So what I'm going to do is just cover certain topics within the options, just so you can understand what is here, and then in the future you can come back and you can be pretty familiar with all of these settings, and if you want to change something, you'll know what to do. So what I've got here is my color theme. It's currently on dark. I have an option to change it over to light. If I press apply, you'll see that all the interface will change and our colors will be light. We'll go back to dark, press apply. I'm going to then come down to the next option, which shows display scroll bar in drawing window. So if I turn that on, press apply, we'll see we have our scroll bar within the drawing window. I'm going to turn that off. So you get the general idea of each one of these. Depending on what you'd like on, you can do that here. What we're going to come down to next are the colors. So if we select colors, so we have three steps. On the left, we have context. So we have 2D model space, which is our current view. We have our sheet layout space. So later on, when we go to our sheet layouts, here is where we can change all that information. Then we have the different 3D parameters, our block editor, which we'll cover later on in the course, our command line, which is down the bottom here, and our plot preview, how we want to show when we're in a plot, which is a print. So we'll come back to 2D model space. When we come over to the next section, which is our interface element, we have all the different parameters which we can change. So we have uniform background, our crosshair, the viewport controls, our grid major and minor lines we can change, and as well the grid access lines. So for the demonstration, what I want to show is the uniform background. It's currently on a color of 33, 40, 48. What I want you to do is change over to black, press apply, and we'll see that the background is now black. So coming back into the colors, you have the option of changing to any color you wish. Again, for me, for my personal preference, I prefer black, as I find drawing with the white line, it just makes my models more clear. But as you begin to use the software yourself, you will know which color will be best for you. So we'll click applying and close. Coming down, we have layout elements. So just to briefly cover that, we have a display layout and model tab, so we can turn them on and off here on the bottom left. Coming up, we have our display resolution. So how we want to display our arc circles, the segments and the polylines, our rendered object smoothness, contour lines per surface. We can change those points here. We have our display performance, and our crosshair size. So it's currently set to 5. What that is referring to is when we're modeling, we have our crosshair, which is our cursor. If I come back pressing OP for options, if I increase that to 100, press apply, come back into the drawing, we see that it comes right across the screen. I personally find this the best because I'm able to line certain objects up very quickly. And if I'm on one side of the screen, I can use the crosshair to see how it matches up to something on the other side of the screen. OP for options, come back. So quickly going over to the next tab, we have open and save. So we have the first one, which is file save. So this particular drawing, we can save it as, we're able to back save it from 2018, 2013, 2010. Like we spoke about this before, this depends on if your client doesn't have your current version and you have to back save it. This is where you do that. Then coming down, we have file safety precaution. There is an automatic save feature within AutoCAD that does save every 10 minutes. It is there as a safety precaution, but do not rely on it to save your drawings. Get into the habit of saving your drawings every 15 minutes yourself. And next tab over, we have plot and publish. So we can set our default printer. Where do we want our plot file to print to? So again, that's our file path where we want it to be. And the other settings we won't touch on just at the moment, as it's a little bit too much for the beginning of the course. We can then come over to the system. Here we can check our graphics performance. Over on the right, we have our info center. So the balloon notifications that you've been seeing popping up, we're able to turn them on and off. Come over to user preferences. So little things like double click editing, we're able to have an option to have that on and off. It's currently set to on. And when we right click on something, we can fully customize what we want to do with that. And coming up to the drafting tab. So things like the auto snap marker size. So when we're looking for our snapping points, we can make them bigger or smaller if necessary. And the aperture size attached to our cursor as well, we can change the size of that. So once you've finished the course, it would be best to come back to all of this because you'll understand everything in more detail and you'll understand if you want them on or off, or do you want these to be smaller or bigger. So we'll come over to the selection tab and things like our pick box size. You can have that bigger or smaller, grip size as well. And once you've made all of these changes, you can come down to the last tab, which is our profiles tab. So what you're able to do is we can make all of these changes to the settings and then we can create a profile. If you have multiple people using the same software, each person can create their own profile. So then when you come on to use it yourself, all you have to do is change over the profile to yours. All settings will be updated and you can then continue with your drawing. So everything that we've just changed right now, what we can do is we can add to the list. And I'm going to call mine Steve. We can add a description if we want, apply and close. And once done, we can then set to current. We'll see then the current profile at the top has now been changed to my name. If we were to ever change computers, what we can do is we can actually export all of our settings as well. We'll then press OK and come back to the drawing. We're now going to move on to the next drawing aid, and the one we'll be looking at is called ortho mode. When we're using a line or polyline, we can use the ortho mode, which will constrain the cursor movement to the horizontal or vertical direction. When we're drawing a line, we want to make sure that that is straight and at 0 degrees. We don't want it to be off at an angle. We want to make sure that that is at 0 or 90 degrees. So we'll come down to the status bar, and here we have an L shape, which is our ortho mode. So one click of the mouse will turn that on. It's now blue, meaning that it's active. Also in the info box, it's also telling me that it's on. So now that that is on, we'll come back to our line, and we'll see when I move my line across at 0 degrees, we see that the line is fixed at 0 degrees. Regardless of where I move my mouse, the line is fixed at 0 degrees. If I want to go to 90 degrees, I'll come back to my start point and move the cursor up. We now see that it's fixed at 90 degrees, same below the x-axis. So I got 0, 90, 180, 270. So this means that we can quickly draw straight lines knowing that they are locked in and completely straight. Enter to finish. Now that we know how to accurately draw a line which is straight, we now want to be able to draw that line straight and enter in a distance. And what we're going to do is we're going to use another drawing aid called dynamic input. So down the bottom here, the dynamic input isn't being displayed. So what we're going to do is go to the customization on the right hand side, click once, and in here we'll see all of the different drawing aids which are currently turned on or turned off. And here we have dynamic input. So we want to turn dynamic input on. And there it is there. So when I'm drawing, all of the information which is around the cursor is the dynamic input. So the information which the dynamic input will provide will be the distance, the angle, as well as which drawing aid is active. So you can see here on my screen, it says that I'm currently drawing this line at 49.4846 millimeters at 0 degrees using the ortho mode. So when I'm going to draw my line and I want to specify a particular distance, I can either select my line tool or I can hit the L key. The L is the hotkey for line, or the short key for line. So that's being typed into my command line. Press enter, and it's now asking for my first point. So I'll enter my first point. And through the dynamic input, I'm now going to give a distance. So I'll give my first distance of 100 and press enter. So this line here is 100 millimeters and it's at 0 degrees. And just to confirm that, I'll use my distance tool, which is confirming that it's at 100. If you draw a line at 100 and it's either too big or too small, you can't find it. The reason for this is you're either zoomed in too much or zoomed out too much. I'll give you an example. If I zoom in quite a lot, draw a line at 100, I can see my line there, but I cannot find the end. So I can either scroll my wheel out, or if you double click on the wheel, it'll zoom everything we've just drawn into the center of the sheet. So again, I'll delete everything, draw my line at 100, and if we double tap the wheel, it'll bring it into the center of the screen. So I'll draw another line 100, but up 90 degrees. So there we have two lines at 100 millimeters and 0 degrees and 90 degrees. So when we are drawing a line continuously, what we'll do is we'll first draw our first line at 100. Then remaining in the line tool, I'll move my cursor up in the direction I want my next line, enter in the distance of 100, then move in the new direction, 100, and again back down. So I'm moving the cursor in the direction at which I want my line to go, and then entering in the distance. And for the last section, I can just click on the start point to complete the object. So this is how we can draw continuously without stopping. And all lines, as it was done within the same action, are all joined together. So we're now going to be looking at our first practical exercise. And within this exercise, we will practice what we've just learned. So we're going to be using the line tool. We're going to have it locked in on ortho mode, and we're also going to enter in a distance. For the first practical, I'll take you step by step through the process. But for the remaining practicals, what I'll do is I'll leave the practical on the screen. I want you to try it first, and then after you've completed it, You can then go to the next video where I will complete that task and you can see how well you did. So the practicals in question are part of the notes to follow, which you can find at the beginning of the course in the download section. And we are currently on practical 1. And this is what our practical will look like. So what we're going to do is we're going to use the line tool. We're going to make sure that the ortho mode is turned on. And this is our starting position. So our first line that we're going to draw is to the right at 0 degrees and a distance at 700 millimeters. So what I'll do first is just zoom out, give myself plenty of space, and we can begin the first practical. So we can either go back to our draw panel, select the line tool, or we can type L in the command line and press enter. So the dynamic input is telling us to specify the first point. So one click of the mouse will move the cursor to the right hand side and just ensuring that ortho mode is turned on and active, so we can see our line is locked in at 0 degrees. And the first distance was 700 millimeters. So remaining within the line tool, we can see it's ready to go to draw the next line. So we're at this point here. What we want to do is go up by 200 millimeters. So I'm going to move my cursor up and enter in 200. We've now done our second line. So our next line is we're going to the left hand side, again at 0 degrees and 300 millimeters. So we're going to the left hand side, distance 300, and enter. So same again, we're remaining within the line tool the whole time, so we can draw this in a continuous manner. Our next line here is 100 millimeters up. So move the cursor. Again, I'm zooming in using the scroll wheel. So just moving my cursor up 90 degrees. And the distance is 100. We're then going to the right hand side and the distance is 300 again. Cross to the right hand side, 300, enter. From this point, we're going to go up by 100. So move the cursor up and distance 100. So for the next point, we have an angle, and we know that having the ortho mode turned on won't allow us to draw at an angle. It'll only allow us to draw at 90 and 0 degrees. So what we're going to do from this point is we're going to draw one line up at 200 and then to the left at 200. So from our starting point, we're going to move the cursor up, distance 200, and to the left, distance 200. At this point, we have each of these points here. So then with my cursor, I can scroll back and I'm looking for the end point. So that green square. If I get the green triangle, I'm in the midpoint of that line. So I want the green square, which is the end point. And you can see the ortho mode is fighting me. It's going back and forth. It's going straight line back to the angled line. But I can override the ortho mode by selecting the end point, and it will draw the line between the 2 points. So there we have that line drawn. So the ortho mode was overridden by me clicking on the end point. So enter to finish the line command. The reason being is we now want to select those 2 lines and delete them. Then pan our object over to the right. So now we have our angled line. We'll come back to our practical image, and we're now going to start the new line connecting to the end point, going to the left hand side at a distance of 1000. So I'm going to select my line tool, come back to the drawing space, attach to the end point, move the cursor to the left. The distance is 1000, pressing enter. So that is my new point. It's my new end point. And same scenario here. To get this angled line, we need to draw a line at 400 to the left and then down by 300. So just to ensure that we're at the end point and not over to the right hand side, we want to draw the line to the left. So move the cursor out to the left, distance 400, down by 300. And we're going to come back. We're going to look for the end point. So there I'm at the midpoint. There's my end point, the green square. Click of the mouse overrides the ortho mode. Enter to complete the line action. We're then going to select those two lines and delete. So we're now at this point here. So we'll draw our line straight down at 300. Back to our line tool. Connect to the endpoint. Move down, distance 300. Enter. So we now want to draw this triangle. And to do so, we'll draw these dashed red lines. So at the bottom we have 300, 400, and up 200. So that's 300, 400, come back to the end points, and up by 200. So first line is across to the right by 300, then across again by 400, enter to finish, enter to turn the line back on, and we're going to look for that endpoint. Once we find the endpoint, we'll click once to activate the line tool, enter our height of 200, and enter to finish. So we now have these three lines drawn. We just need to draw on the angled lines here and complete the final section. So L for line, connect to the endpoint, connect to the endpoint, and connect to the endpoint. Enter to finish, and we can now delete those three lines and delete using the delete key. So the last section here we have up by 200 and across by 200 and finish by connecting to the start point. So we'll go back to our line tool, connect to the endpoint, up by 200, enter, to the right by 200, enter, and connect to the start point, enter. So there we have our first shape. We're now going to move on to coordinates and drawing by coordinates. The first type of coordinates that we're going to be looking at are called absolute coordinates. And the first thing I need you to do is open up the file attached to this video. It's in the resources section. And once downloaded, the file is called absolute coordinates. So I'm sure by now you've noticed the grid on our screen, ignoring what I have drawn here, but in the background we have this grid here. So this grid actually means something. It is referring back to our XY. So where our X and Y meet, our coordinate is 0, 0. And each one of these heavy lines is 500 millimeters, and the lighter lines are 100 millimeters. So that's why I've drawn out this grid here, just to make it a bit clearer so we can understand it. And down in our status bar, what we need to show here are our coordinates. So when you first install the software, this isn't visible. So we need to turn that on. To do so, go to the customization on the right hand side. And at the top we have coordinates. And here we have our X and Y coordinate will appear in this section here. So down here with our coordinates, we have our X first. X is always first. And then second is Y. Third, we have Z. So from this point here, Z will go up. If you're using 3D CAD, you would have a Z figure. But as we're using 2D only, this will always be 0. So you can see as I move along the X axis, our X figure is increasing. And is displaying the X coordinate. And as we move up the Y axis, you see the Y figure moving, and it is displaying our Y figure. One drawing method within AutoCAD is when we're using our line tool, we can specify our start point with XY coordinate, and we can specify our end point with XY coordinate. And the way in which we do that is we'll select our line tool. We'll come back into our drawing. Previously, we used our cursor to click and specify our XY coordinate, and then we'll click again to specify our endpoint. So what we want to do now is we want to accurately specify our X and Y position. And to do that, we will click on the hashtag or pound symbol. And you'll notice on my dynamic input, when I click on the pound symbol, you'll see that that is now locked in gray. And then to the right of that, we have numbers in blue. So when the numbers are in blue, it means that they are editable, so we can change them. And when they're grayed out, they are fixed and locked and we can't change them. So as the X is in blue, the software is looking for the first point, so our X point. So the first point that I want to mark on our drawing is 100. And how I now jump over to the Y coordinate is I'll press the comma key. So now you can see on the dynamic input, the pound symbol is locked in. My X coordinate is now locked in at 100, and it's now waiting for me to give the Y coordinate. So for my Y coordinate, I will give a figure of 200, and to complete the action, I'll press enter. And you can see now my cursor has jumped to X 100, Y 200. That is how we draw using absolute coordinates. So within the notes, in the short explanation about absolute coordinates, there we have an example of a shape. And we're going to quickly draw that as a bit of practice. So our first point there is X 200, Y 300. So first thing we need to do is we need to activate our line tool, as this is the tool we want to use. So we'll select line tool. We now want to instruct the line tool that we want to draw in absolute coordinates, and we do that by hitting the hashtag or pound key. And our X is always first, and our X is 200. Our Y is 300, and we jump over to the Y by hitting the comma key. 300, enter, and there's our first position. When drawing in absolute coordinates, we don't actually need to use the mouse, so we can just ignore the mouse and just focus on the keyboard and the screen. What we're going to do is we're going to work our way around that object clockwise. Our next point is X 300, Y 700. So as we're still within the line tool, we just have to hit the hashtag to tell the line tool that we're going to enter in the coordinates using absolute coordinate, then type in the X, comma, Y, enter. And again for our third point, pound key, 700, comma, 600, enter. And pound key, 800, comma, 200, enter. And to return back, we'll re-enter the first position. So hashtag 200, comma, 300, enter. And enter to complete. So now we can double check on this grid how we've drawn that. So our first one is 200 on the X, 300 on the Y, that's correct. 300 on the X, 700 on the Y, that's correct. 700 on the X, 600 on the Y, correct. 800 on the X, 200 on the Y, correct, and back to the start. So examples of where we would use the absolute coordinates would be on site plans, where we have our easting and northing. So our X and Y would then become our easting and northing. And this is how we can create our site plans. Okay, now we've finished with this drawing. So my advice again is to close it down and don't save it, so you can come back to it in the future and it's a fresh drawing ready for you to practice again. But we'll go back to our main project file. So we'll X to close it down and don't save it. So we're now going to move on to the next practical and practice what we've just learned. So within the notes, we have practical 2.1, And what we're going to do is we're going to draw that. What I want you to do in a few moments is to pause the video on the screen, try it out for yourself, and then once you've completed it, and then I will draw this shape and you can see how well you did. First thing we'll do is we'll go back to the drawing sheet. As the first coordinate is 100 on the X, 100 on the Y, it's going to be roughly around this position, so we'll just make sure that we have a nice clear space. And I will come back to the practical.
So if you could please pause the video now and attempt it yourself.
Okay, so I hope you did quite well with that. So now what I'm going to do is I will draw this shape. You can follow along and see how well you did. So I'm going to go back to my drawing. Before you start this practical, just come back to your drawing aids, and what I want you to do is to turn off the ortho mode, as this will get in the way of your drawing. So we're going to turn off the ortho mode, which will then allow you to draw at an angle. Okay, so to get started, our first thing I'm going to do is delete this object out of my way. So this is where my object will be when I draw it. And my first point is 100, 100. So I'm going to go to my line tool, hit the hashtag or pound key, and enter 100, 100, enter. There's my first point. So remaining in the line tool, I go to my second point of 400, 400. So as we're still in the line tool, I'll just hit the pound key, 400, 500, enter. And my next point is 900, 600. So pound key, 900, 600, enter. So I'll zoom in to make it a bit clearer. And our next point is 800, 200. Pound key, 800, 200, enter. And we can either enter in the first point, or we can just come back and attach to endpoint. Enter to finish, and there's our object. The next method of how we can draw with AutoCAD will be relative coordinates. So previously we just looked at absolute coordinates, which when we are drawing a line, we connect to the true XY position on the UCS. With relative coordinates, the relative coordinates are based on the last point entered. So how I can show that to you is we'll open up the file relative coordinates, which is attached to this video. What I have drawn here is simply to demonstrate the x-axis and the y-axis. So in all of our drawings, if I come back to our main project, we will have our x-axis here, which is in red, and our y-axis, which is in green. And where they connect, the coordinate is 0, 0. Coming back to the relative coordinate drawing, so here's where those 2 points meet, where our x-axis is in red and y in green, and where they meet is 0, 0. So along the x-axis, when we're going to the right, we're going in a positive direction, and it's going up 100, 200, 300 units. And above the x-axis going up the y, again is positive, which is 100, 200, 300. On the x-axis, when we go to the left, so we're going to the opposite side of the y-axis, continue along the x at 0. So we're now going to the left of the y-axis, which in turn becomes a negative figure. So we're now at negative 100, negative 200, negative 300. And the same for the y-axis. Once we go below the x-axis, the y figure becomes a negative. So it's negative 100, negative 200. So when using the relative coordinate system to draw a line, our starting point will always be 0, 0. And our finishing point, we will enter in our x and y to tell the line which direction and the distance we want our line to go. So with the absolute coordinate, we hit the hashtag or pound symbol to instruct the software that we are going to be drawing in absolute coordinates. For the relative coordinates, we don't need to enter anything. We'll just simply type in the x, y. The UCS and grid I have in front of me is purely just to show you how this will work. When we're going to draw our shapes, obviously this will not be there. If you refer back to the notes, I have another diagram here which you can refer to, which will help you when creating the next task. So you can refer back to this, which is in our notes. Select our line tool, so we'll either go back to our draw panel, click line, or L and enter. So first thing we'll do is we'll click on 0, 0 to start our line. And now referring to the dynamic input, we can see it's in blue, so it's waiting for me to enter in that XY coordinate. So referring back to the PDF, what we'll do is we'll start off with the first one here, which is 300, 200. So 300 on the X, so it's plus 300. And plus 200 on the Y, so it's up 200. So we want to start our line here. This is the direction which we want to draw our line, which will finish here at 300, 200. So just to show how the line will lock in at that, I'll move my cursor outside of the grid, and I'll enter in the first 300, comma, and you'll see now my dynamic input. The X has been locked in with 300, and as I press the comma, it jumps to the Y and is waiting for the Y coordinate. So type 200 and enter to finish. So there's my line, which was started at 0, 0, and I instructed the line to move across the X-axis 300 and up 200 on the Y. Now with a relative coordinate, if we were to continue on and to draw a shape, this end position now becomes a 0, 0. So you can imagine that this grid now shifts over, and that is now our point 0, 0. Referring back to the PDF, if you use this PDF as a guideline on which direction and angle you want to draw your line, this is a great example. So for us to draw our line in, say, a northeasterly direction, so both positive x, y, if we wanted to draw in a northwesterly direction, our x becomes a negative. So starting at point 0, 0, it's coming across the x-axis to negative 300 and then plus 400. So our line now goes from our center point at 0, 0 in a northwesterly direction to negative 300 plus 400. And in a southwest direction, again, we'll start at 0, 0, come down, both are negative, so negative x, negative y. And a southeasterly, we have a plus or positive x and a negative y. We'll try this now, our northwesterly line. So again, L for line, start at 0, 0. As we're using relative coordinates, at this point, it doesn't matter where we put the cursor. I'll just put it down to the bottom right just to show that. What we want to do is go in a northwesterly direction. So my x becomes negative, so negative 300, comma. Again, referring to the dynamic input, we see that the line has disappeared. My negative 300 for x has been locked in, and it's now waiting for the y coordinate. And the y is positive 400. And enter to finish. So there's my line, started at 0, 0, going in a northwesterly direction, negative 300 plus 400. So we'll continue around and we'll do the southwesterly direction where both the x and the y are negative. So again, L for line, attached to 0, 0, move my cursor out of the way. and I'll type in negative 400, comma, negative 500. Enter. Enter to finish. So we've instructed that line that started at 0, 0 to go across the x-axis at a negative 400. So it comes across negative 400. And then down the y at negative 500 to connect at this point. And we'll do the same for the southeasterly direction where our x is positive and our y is negative. So we'll select our line attached to 0, 0, enter in our x at 400, comma, negative 300. Again, we've instructed our line, which started at our 0, 0 point, to go in a southeasterly direction. So we can keep this drawing file open for now, and we're going to go back to our project. We're just going to scan up, come over, give us some space from our past project.
So when drawing by coordinates, the relative coordinate input is the default setting, meaning that when I go to draw my line and I type in 500, 500, my second point has been specified using the relative coordinate system. If I wanted to change over to the absolute coordinate system, we would add the prefix of the hashtag or pound symbol, and again 500, 500. So we can see our second point here has been specified on our XY plane. So if I select the line, type in LI for list, it'll show there's my X of 500 and my Y of 500. What we're able to do is we're actually able to flip that. So if you were always using the absolute coordinate system, you could then change over to make that the primary default setting. To access that, we're going to go into what I call the drafting settings. So coming down to the status bar. We have multiple ways that we can access that. Each one of our drawing aids has a small arrow beside them. What we can do is we can click on any one of those. It'll open up the same menu settings, which are our drafting settings. As we progress, we'll cover each one of these headings. So for now, we're going to focus on the dynamic input heading. And what we're going to focus on here is the pointer input. So we'll select the settings. So we have two headings here. We have our format and visibility. So under the format, what we're doing is we're just changing our default settings over for our second or next point. So it's currently on their Cartesian format, meaning we will enter in our X coordinate, comma, and then enter in our Y. What the polar format is will be our distance. So for example, 500. And our second point then is our angle. So that's what a polar format is referring to. And we do that by typing the bracket symbol, which will be on the screen. So once we decide what type of format we want to choose, which we're going to go ahead with the Cartesian format, so that's X, Y, we then choose which coordinate system do we want to be our primary coordinate system. So currently our relative coordinate system is our primary. What that means is that we just don't have to enter in the prefix when we're entering our coordinates. So we've been currently just typing in 500, 500 for our relative coordinate, and for our absolute we have to type in the hashtag or pound symbol. So what we're going to do for this example is just change over to the absolute coordinate, press OK, and come back. So now when I draw my line, specify my first point on the screen. If I type in 500, 500, enter, it's going to use my absolute coordinate system, meaning that it's jumped to the X, Y position. So I'll just click to place, select my line, LI for list, and there we see is our X point of 500 and our Y point of 500. So that means we didn't have to put the hashtag symbol for the absolute coordinate system. So if we wanted to then use the relative coordinate system, what we need to do is we need to put an @ symbol in front of our coordinates. So we'll start our line, specify our start point, then type in the @ key, and again 500, 500, and enter. So there's our relative coordinates. So that's our line drawn by relative coordinates. So if you were drawing survey plans and you were using the absolute coordinate system, what you should do is change this format so you don't have to type in the hashtag, which will speed up your modeling process. But for this course, we want to use the relative coordinate system. So I want you to go back into the drafting settings, go to our dynamic input, come to our settings, change over to relative coordinates. So then here we have our visibility section. So this is referring to the coordinate tooltip visibility. So we have three options. We have as soon as I type the coordinate data, when a command asks for a point, or always, even when not in command. Best way to show you this is if I turn on always, press OK. You'll see attached to the cursor, it's always displaying the XY coordinate. So that's what it's referring to. So no matter where I move my cursor, it's displaying the XY coordinate. So again, if you're using survey drawing or the XY coordinate system is essential for your work, this would be a great feature to turn on so you always know where your XY is. For the purpose of this course, we don't want to have it active all the time as it's going to get in our way, so I'm going to turn that back off. Come back to the settings, dynamic input, pointer input settings. And so for our visibility, I only want that to appear when a command asks for a point. Press OK. So the other points here within our dynamic input tab, we have our dynamic prompts. So we have show command prompting and command input near the crosshair. So that's our prompt beside our crosshair. And we have show additional tips with command prompting. So there, the info bubble that are popping up there are additional tips when prompted. So do we want them to be on or off? Again, that's up to you. Below that, we have our drafting tooltip appearance. So this is just referring to the appearance of our tooltip. So we have full control. Currently, it's set to blue. What we can do is we can change that to any color. It's not necessary to change this at all, but just be aware that it is there if you do need to change it. And up on the right hand side, we have our dimension input where possible. So it's showing our dimensional input on our lines when we want that to be displayed. So for example, when we do our distance command and that kind of thing, how do we want it to be displayed? So if I go to the settings, we have a couple of different visibility options. So we can show only one dimension. Two, we can have full control over exactly what dimensions we want to be shown simultaneously. So this level of customization isn't necessary at this stage, but just be fully aware that those options are there for you to take in the future. So we'll press OK to confirm all of our settings. And I'm just going to select those lines and delete, and we're back to our standard.
And in the notes, we have an object which we're going to draw using the relative coordinates. And what I'll do is I'll get us started. I'll draw the first three lines, and to demonstrate how we're going to construct this image. And then I want you to pause the video and continue on yourself, just for good practice. If you don't feel like you're confident enough, just continue on and follow as I'm doing. So first we're going to go for our start position. So we imagine that that position is 0, 0, and we want to go to the east, so to the right. So if we come back to our little guides template here, this is our start position 0, 0. We want to go east. So what that means is our X and Y will be positive, but our X will be the distance and our Y will remain at 0 because we're not going up the Y axis at all. We're just simply coming straight over in an easterly direction. So our distance here is 200. So we'll come back to our project file, start our line. We'll just click anywhere on the screen. And our first line will be 200, 0. Enter. And there's our first line. I'll just zoom in slightly using the scroll wheel. And for this exercise, we're also going to remain inside the line tool. So we're not going to be deactivating the line tool and then reactivating. We're just simply going to keep it activated the whole time. So coming back to the PDF, we're now at this position here. And what we'll do is we'll take this new position as our 0, 0 point. So this new position is now our 0, 0 point. We want to come across the x-axis and up the y-axis. So across would be a positive 200 and up the y will be positive 400. So again, referring back to our example, we come to the right, which we know is positive, and we'll go up, which is positive. So we have positive 200, positive 400. So I'll type in 200, comma, 400 and enter. So there is our line. We came across the x-axis at 200 and up the y-axis for 400. So again, referring back to the PDF, we're now at this position. So this position we will now refer to as 0, 0. And what we want to do is go in a northerly direction, and we're going up 100 units on the y. So referring back to our guideline, we're now at 0, 0. We want to go up to 100 on the y. So our x will be 0 as we're remaining on the x-axis, and we're going up 100 units on the y. So I'll type in 0, 100 and enter. So at this point, if you feel confident enough, I want you to pause the video and continue on and see how well you do. If not, just continue on and allow the video to play and follow along. Okay, so again, referring back to the PDF, we're now at this position, which we will call 0, 0, and we want to go to the west at a total of 400 units. So we're at this position 0, 0. We want to go to the west along the x-axis at 400. And as we're going to the left, this is now a negative figure. So our figure will be minus 400. And as we're across the x, we're not going above or below, so we're not touching on the y-axis. The y will be 0. So I'll type negative 400, comma, 0, enter. Okay, so again, we're coming back to our PDF, and our point again is now reset to 0, 0. And we're coming up in a northerly direction at 200 units. So we'll come back to my drawing. So our x will be 0 and our y will be 200. And again, we're back on our 0, 0 position. We have another westerly direction line at a total of 400. So again, we're at our point 0, 0. We're going to the left or to the west on our x-axis at a negative 400. So negative 400, and as we don't touch on the y-axis, y is 0. Now in our PDF, so we're now here at 0, 0. We're now going down in a southerly direction. Total units is 200. So our point is 0, 0. We're coming down what is the y-axis at a negative 200. So from 0, 0 down negative 200. And we remain on the x-axis, so that is 0. So x is 0, y is negative 200. Okay, from this position, we're going to the left, to the west, at 100 units. So we're coming across, which is a negative 100 on the x. So negative 100, comma 0 at this position. So we're coming down 100 units, and then we're going to go to the left at 200. So we're going to change the two different axes here. So first will be a 0, negative 100 coming down the y-axis. We're then going to go to the west or to the left at a total of 200 units. So that is a negative x of 200, 0. So at this position, we're going to come up, and we don't have a dimension. So what we'll do is we'll come across to the top. We see that this distance here is 200. And this distance here is 100. So a total of 300 units will be the height of this line. And it's running up the y-axis. So x is 0. And y is 300. We're now going to go to the left at negative 300 on the X. So negative 300, comma 0. So for the next line, it can be quite tricky. So we're starting at our position here of 0, 0. So first thing we want to do is find out what is our X. So if we imagine a line connecting the two, that'll be our point here. So coming to the right will be our X. So our X is a 300 figure, and it's going from the 0, 0 point to the right. So we know that that will be positive 300. So there's our position to the right, positive 300. And as this line also lines up with the bottom, we could also figure out that point from the top as well. So going from point 0, 0 to the right, so it's a positive direction of 300. And for the Y position, so as this is our start point, 0, 0, coming down the Y-axis, we know that from point 0, 0 coming down the Y-axis means that the figure will be negative. And the total distance of this line, if we come over to the right-hand side, we'll just add up these figures here, which comes to 700. So our line will be 300, comma, negative 700. Enter. And there we have our angled line. Now at this position, we'll just finish it off nice and quickly. We have positive 200 on the X, positive 200 on the Y, positive 500 on the X. So we have a positive 200 on the X. So it's 200, comma 0. And then we have a positive 200 on the Y because we want the line to go up. So our X is 0, comma, positive 200. And the remaining line is a positive 500 on the X, comma, 0 for the Y. And we can just come back and attach to our start position. If you notice on my dynamic input, it's telling me that that line distance is currently 200 at an angle of 90 degrees. If we refer back to the drawing, if it is not 200, nor is it at 90 degrees, then you know you have made a mistake somewhere. So you can go back over and just redraw the shape to double check that everything is correct. Enter to finish, and there is our next practical finished. We're now going to be looking at another method at which we're able to draw within AutoCAD. So I'm just going to pan the drawing over to the right hand side to have a nice clear space. You may have noticed in the background we have this grid system. The grid is a rectangular pattern of lines. It can also be dots that cover the entire XY plane of the UCS, or the user coordinate system. So just coming back over to the XY, on the UCS, we can see here we have, for example, the one larger grid with these smaller, lighter toned lines, which is inside it. And what we're going to be doing now is we're going to actually use that grid to help us to draw. If the grid isn't turned on currently in your drawing, we'll come down here to the status bar. And the first drawing aid there is the drawing grid. We see that it's blue, so it's turned on. What I'll do is I'll turn it off so we can get an idea of what the screen looks like without the grid. So what I want you to do is to make sure that the grid is turned on, and we can progress to the next stage. To show you how we can use the grid when modeling, I'll select my line tool. You see when I try to draw my line or select a point, the cursor is ignoring the grid currently. So what I'll do is I'll click on Escape. So what I want is I want the line to be able to snap directly to that grid. And to do so, we'll come just to the right of the grid where we have Snap Mode. So we'll turn Snap Mode on. I'll then come back and select my line. When I come back into the drawing, you see my cursor is snapping to each one of those grid points. Now it's currently set up at 10 units or 10 millimeters, so you can see my dynamic input is going from 40-40 to 50-40, 60-40, 70-40. What we want to be able to do is control the spacing between each one of those grid points. To do so, we'll come back down to the snap mode, and to the right we have the drop down menu, and we'll click on snap settings. So within the snap settings, the first section here is our snap. So if we didn't turn snap on here, we can do so here by turning it on. We can also press the F9 key on the keyboard. So we want to make sure that that is turned on. And our snap spacing is currently set to 10 by 10, as I demonstrated a few moments ago. And we also have the X and Y spaced equally, meaning that each one of those grids is 10 by 10, so they're equal distance and equal spacing. If we wanted to change them, so if we want to say the X to be 10 and the Y to be 20, we can turn that off and we can then change the spacings to be different. So you can see if I change this to 15, come down to the Y, it'll automatically change to 15 because this feature is active. So the snap spacing which I want you to change to now is 100, and just click on the Y and it'll automatically change to 100. We'll then come over to the right hand side where we have grid, so that is our grid in the background. Again, if it's not turned on and active at the bottom here, we can do so here. So we can turn it on and off, and to confirm our changes we'll press OK. For now I'll leave that, so if I turn that off, press OK, the grid will turn off. And the hotkey for the grid is F7. So here I'll make sure my grid is turned on. So as we've changed our snap spacings to 100, our grid is still showing a 10 unit spacing. We want to change the grid spacing to match our snap spacing. So we'll change that to 100. And as they're equally spaced, we'll click on Y and it'll automatically change. Below that we have major line every. So it's currently set to 5. What that is referring to are these thicker lines. So as it's set to 5, every fifth space will be a major line. So here we have 1, 2, 3, 4, 5, major line. And for now, that's what we will cover in the snap and grid. So press OK, and you'll notice in the background that the grid will change as we press OK. So now when I zoom out, each one of these grid spacings is set to 100. So now having my grid turned on and my snap turned on, when I select my line, snap to the first point, move to the right, snaps to the second point, and you'll see it's at 100 spacing. So I'll click on each point, and I'm now confident in knowing that each one of those lines is exactly 100 units. So if we had a scenario where we were drawing something which we knew was spaced exactly 100 units, we could manipulate the grid so we can speed up that process. And with this practical, I'm going to show it on the screen. And what I'd like you to do is to pause it, and I want you to draw it yourself first, and then when you're finished, come back, play the video, and see how well you've done. First, I want you to come up, give yourself some space.
And here's our third practical.
So I want you to just click on any grid, move to the right hand side, and your first spacing is 600. So we'll select our line, click, and our first is 600. So without manually entering in, we can just move across the grids. So now I'd like you to pause the video and continue with the practical. Okay, so now that you've done that, what I'll do is I will draw this out and you can follow along. So we've done our 600 line. We'll go up 200, 200, 500. So I'll go up 200, across 200, up 500. We have across 800 and then a series of 100s. So I'm coming across 800. All the time I'm looking at my dynamic input. Down 100, across, down, across, down, and across. So here we have up 300, 400, 300, 300. So 300, 400, 300, 300. We'll then come down 200, 300, 100, 400. 200, 300, 100, 400. And we have a series of 100s again, and down 200. 100, 1, 1, 1, 1, 100, and finish off with 200. And there we have another practical finished. Okay, so we'll move across to a clear section of the drawing. And we're now going to be looking at the fourth and final way in which we can model in AutoCAD. The method which we'll be using is called polar tracking, and this method is the one which you will be using for the majority of the time, as it has the most amount of drawing aids and it's the quickest way in which we can create our drawings. Down in the status bar we have our polar tracking, which is a circle with a small angle cut out. That is our symbol. We want to make sure that that is currently turned on. After we have that turned on, I want you to turn off the snap mode so it doesn't interfere with the polar tracking. I'm also not going to be using the grid to showcase this drawing aid. So I'm going to turn that off. Now we have a nice clear screen in front of us. So having the polar tracking turned on, just to the right of that is a small drop down arrow, and in there we have a series of different angles. So the first one which is active is the 90 degree, 180, 270 and 360 degrees. What that means is when we go and select our line, come into the drawing, I'm going to just click on the screen to start my first point. I'm now going to move all the way across to the right. Within the dynamic input, first in blue is my distance, so it's waiting for me to enter my distance. We'll then come into the middle where we have the degree and it's locked in at 0 degrees. And then to the right of that we have the title polar. So the dynamic input is telling me that it's using the polar tracking drawing aid. Then the information it's providing is that it's at a distance of 674 at 0 degrees. So what the dotted green line is telling me is that it's snapped at 0 degrees. And the reason it's snapped at 0 degrees is due to our polar tracking setting. It was set to 360 degrees, which is also 0 degrees. So in that polar tracking setting, we had 90 degrees. So if I move my cursor up, you'll notice that the degree is changing. But when I get to 90, and if you watch my cursor, it snaps. And you'll feel that when you're moving your cursor, the line will snap at 90 degrees. And then we have the dotted green line again. So the polar tracking is locking in my line at 90 degrees. So I'm confident that when I draw this line, it is at 90 degrees. So we'll come around again, and at 180, our line will snap again, and there's our dotted green line, and we're at 180 degrees. We'll move around, we have 270, and back to 0. So the way in which I can use the polar tracking when creating a line, if all of my lines are locked at 0, 90, 180 and 270, all I have to do is click from my first point, move the cursor in the direction that I want to draw my line, and then I'll enter in my distance. So I'll select my line, click on my start point, move my line up in the direction I want to go. When I see the dotted green line, I know it's locked in at 90 degrees. I'm then entering in my distance and enter. And same again for 180, I'll click from my start point, move the cursor in the direction I want to draw. Once it's locked in, I see it's at 180, and I'll enter in my length. And again for 270, come down. So it's showing me at 90 degrees. So with the polar tracking, when we come below the x-axis, yes, it's showing me at 90, but we understand that that is 270 degrees. And the distance at which I'm entering, I'm just looking at my dynamic input, and it's currently telling me it's 444. So I'm just going to enter in 500 so it will appear on my screen, and enter. So there I've drawn 4 lines, and I'm confident that this is at 0, 90, 180, and 270. So coming back to the polar tracking settings, we can come down to the 45, 90, 135. So I'll select my line, click to start. I'll come over again to 0 degrees, and when I move my cursor up, when it reaches 45, I can see that the line will snap. I get the dotted green line, and I can then enter in my distance. So it's showing 777, I'll enter in 800, enter to finish. And we can do the same for 135. And again, it will be 135 below the x-axis. But if we were to read the dynamic input, it's showing me at 225. And distance 600. And same again, 45 degrees, which is 315, and 600. So coming back to the tracking settings, you can see we have 30, 60, 90, 20, 23, 45, 68, and so on. And the last one is 5, 10, 15. So we could go up in increments of 5. So 0, 5, 10. But during the modeling process, if we have this active, we're going to have too much choice and it's going to interfere with the quick modeling speed. So just be conscious and aware of what you're drawing, and do you need that many options. So if we come back to the 30, 60, 90, we'll select that. And what we notice that during the modeling process, yes, we have 30, 60, 90, but there's one particular angle which is recurring. So whatever we're currently drawing, if we notice that there is an angle of 35 degrees which is appearing time and time again, we can add that to the 30, 60, 90. So to do so, we'll come down to Tracking Settings. And here we're in the Polar Tracking tab of the Drafting Settings. And again, we have our Polar Tracking turned on, and coming down to Polar Angle Settings. So we're currently in the 30 degrees. If we wanted to change, we could do that here. We'll stick with the 30 degrees. And underneath that, we can go for additional angles. So we'll activate that. So we'll click on Additional Angles. We'll then click New and type in 35 degrees. Press Enter. So that 35 degrees is now added to that increment set. Okay, so what we'll do is we'll click on OK, which will bring us back to the drawing. We'll select our line. And then we have 30, and 35 is also included in that set. We can also see that an additional set has been made, which is 35, 70, 105, which could also be very helpful if we were to continue on using that set. We'll then come back into the tracking settings. If you no longer require the 35 to be included in that increment, instead of selecting it and deleting it, we can simply turn it off. So it still remains there for future use, but we've just turned it off. So we'll come back, press OK, select our line. We have 30, but 35 is no longer active. And it also remains in our selection as well. For a quick modeling speed, what we can do is we can have 45, 90 active. As we now know, we have 0, 45 and 90 are our snapping points. But instead of trying to place our line in the location for the 45 degrees and then adding in our distance, what we can do is we can override the polar tracking. And with this method, this will be the quickest way to draw an angled line. So for the example, I want you to just draw a line so we have an understanding of our drawing scaling right now. So it's currently showing me that I've got about 1050 units within that line. So what that does, it just tells me that when I'm drawing my line for this example, I'm going to place it at around 1000 units so it appears on my screen. And what I want to do is we've clicked for our start point. So we have our first point, but we want to now place our second point. And for the second point, I know the distance and I know the angle of the line. For reference, to understand the angle of the line, you'll always come out to the right for 0 degrees and you'll then go up. And then from there, you'll go up to 45, 90 and all the way around to 180. So if I wanted to draw my line at 120 degrees, I know that my line will kick back and will be at 120. If I come below the x-axis, it doesn't come backwards from 360, it starts from 0 again. So when I put my line below 0, it then goes up from 0 around to 90 and then to 180. So we're not going backwards from 360. An example of this is in the PDF. So in the center is our start point. We come out to the right for our point 0. When we come up, we go positive around to 90 and 180, and we then count backwards to 90 and back to 0. So depending on where we want our line to go, use this as a reference for the beginning just to understand where the angles are. So I'm going to click on my line, click on a start point, and I'm going to draw my line at 1000 for my distance. Now, my current angle is at 30. Yours will be different. Depends on however you've just drawn your line. And what I want to do is I want to change the degree. So how I change the degree is I click on the Tab key. When I select the Tab key, the distance is locked in at 1 meter or 1000 units. It's now asking me to specify the degree. So my degree I'll choose will be 49 degrees and I'll press enter. So we'll try that again. I'll delete it. I'll click the line, click my start point, and this time I'm going to go below the line. So again, I'll type in 1000 for my distance, hit the Tab key, and if I type 49 this time, the line will go down because I first moved my cursor below the x-axis. So if I put my cursor above the x-axis, hit 1000, Tab 49, my line goes above. So these lines are at 49 degrees from the x-axis. So this line here is currently set to 0. So to quickly check my angle, we're sticking to the Home tab. We'll come down to the end, we have the Utilities panel, and there we have our Measurement tool. Hit the drop-down menu, and we have the various different measurements. We'll cover this in greater detail as we continue on within the course, but for now I want to check the angle, so we'll select the angle. We'll click on the top line, and then we'll click on the second line. And there that's showing that it's 49 degrees from the lower line to the top line. If we hit enter, we'll reactivate the measurement tool and we'll do the top line and the bottom line again, and it's showing that it's at 49 degrees. We can also click on the distance and we'll click on the start point, the end point, and it's showing there that it's set to 1 meter, and it's also giving me the angle at 49 degrees. We can do the same again for the bottom. There we have 1 meter, 49 degrees.
The angle is always referring back to this line, which is our x-axis, which is set to 0. So we'll do the same again, but we want our lines to go up to the top left-hand corner. So we'll hit our line tool, our start point. So now we'll do 1000, tab, and we'll go 145, enter. We'll do the same for the bottom, 1000, tab, and it's 145 again. Okay, so I'll draw my baseline again. I'm drawing this baseline just to illustrate where the angles are coming from. So with the baseline drawn, I'll again come back to the angle. I'll select the line and the baseline, and there we have the 145 and the baseline to our newly drawn line, and there we have 145. So next we have another drawing aid which we will use that will help us to speed up our drawing process. And in conjunction with the polar tracking, we'll be using what is called object snap tracking. If we come down to the status bar, this is our object snap tracking. It's an angle image with a circle on the top line. So we'll have it turned on. We know it's on because it's blue. And also within the info pop-up box, it's telling me that it's on. So to give an example of what this object snap tracking does, I'll select my line. And what I'll do is I'll first click to start my first start point. And I'm going to draw a square. And I'm going to draw a square, and each line will be 1000 units. And instead of coming across at 0 degrees, typing in 1000, up 1000, across 1000, and connecting to the start point to finish off. A way in which we can draw that a little bit quicker is using these snap tracking points. So again, I hit my line tool, my first point, come across 1000, up 1000, and for the third line, instead of drawing another line 1000 across, as the third line is the same as the first line, and I know that I then want to draw straight down, what I can do is I can hover over this point. Once I hover over the point and move away, you'll notice there's a little green crosshair. That is our snap tracking point. And what that does is when we move our line across, the object snap tracking point will automatically stop the line when it is directly above it. So I know that when I click, that this point is directly above that. So when I draw my line straight down, it'll snap and it's at 90 degrees for me to continue and complete the square. So what I'm able to do is I'm able to leave multiple points by simply hovering over the endpoints of any of those lines. I leave that little green crosshair. If I think I made a mistake and I don't want them to be there anymore, just one small click of the scroll wheel, it'll zoom out slightly and the crosshairs will disappear. So hover over. If I think I've made a mistake, just zoom in or zoom out and the crosshairs will disappear and we can begin again. So that will bring us into our next practical. So I'm going to delete that information. We're going to come over to the right hand side of the practical number 3 and we can have a look at the next practical. So here we have our start point, and for this I want you to only use the polar tracking. You see we have two common angles here, which is the 45. So what we'll do is we'll set our increments to 45, and when we're drawing our line, what we're going to do is simply click our start point, lock it in 0 degrees, enter our distance. So every single one of these lines will be locked in at 0 degrees or 90 degrees.
Once we come to the 124 degrees figure, we'll have our start point, move the cursor in the direction, we'll enter in our distance, then we'll enter in our angle and continue around. So I want you to now pause the video and to try this yourself. And then after that, I will draw this practical and you can see how you've done. Okay, so now I'm going to draw this practical if you'd like to follow along. So our first point, we have our start point and we have 250 in a straight line. So I'll select my line tool, just make sure I have plenty of space. Click. So I'm going to move in the direction and make sure that I'm locked in at 0 degrees. I've got my dashed green line, enter my distance of 250 and enter. For the next line, it's up 90 degrees and my distance is 100. Then move to the left, my distance is 100. And move the cursor up to 90 degrees, again 100. And for the remainder, I'm going to use the object snap tracking. Leave the little green crosshair, and as I move across, I get the dashed green line, one click of the mouse, and I know that that line is directly above that point. The next line is up 90 degrees at 100, so just enter in 100 for my distance. As I know that my line is locked in at 90, press enter. Then we're going over to the left, 200, enter. And we now come to the angled line. So as long as my cursor is above the x-axis, as the direction is going above the x-axis, if it was going the opposite direction, I would put my cursor below. So I now put it in the rough area. Visually, it just helps when modeling to place the line roughly where it will be. So the distance is 500. Then I hit the tab key to change the angle, and the angle is 124. And we'll press enter. And our next point is down from the last point at a distance of 100. We'll then go to the left by 300. Up 200. And we're now at another angled line. So here's our start point. Our distance is 500 and it's currently showing at 34. But that angle is showing from this line. And we know that the angle always refers back to the line which is on the x-axis at 0 degrees. So here we have our angled line down 90 and our start point of 0. So there we have our start point of 0, our 90, and our angled line. So our entire angle includes this. So we need to add that 90 degrees which isn't shown. So what we need to do is add this 34 degrees plus the 90. Which comes to 124. So we'll come below the x-axis. So our line goes below the x-axis. Our distance is 500. Tab 124 and enter. Then our next line is directly down at 400. Enter. And we have the next figure of 254.63. So come to the right, it's 254.63. Enter. Now you can either lock the line in at 45 degrees and then type in 180, or we can do as we've just been doing by typing in 180, tab, 45, enter. Our next line is 300, enter. And for the final line, we can just snap back to the start point, enter. And that is the practical. Now that we've learned the methods at which we can draw in AutoCAD, what we'll move on to now is how we can actually modify what we've drawn. So I'm going to just come over to a clear section of the drawing. The first modification tool I'm going to look at is called the Explode tool. So the Explode tool will break up compound objects into component objects. In simpler terms, if we have multiple joined lines, for an example, we can break those up into being singular segments. To do that in practice, if we choose the polyline, and we know that the polyline creates joint line segments. So if I just quickly draw a polyline. So when I select the polyline, we can see that all of these line segments are joined together. So there are many different ways, again, that we can use all of the tools in AutoCAD. The method at which I want you to begin using, just so we can get into the habit of using the tools, is we'll select the tool first. The reason being is when we select the tool, the command line will help us with the next stage. So until you're more familiar with how the tools operate, this is the process at which we'll use. So after I select the Explode tool, the command line is telling me to select the object, which is my polyline. And with one click of the mouse, my polyline is selected. It's highlighted in blue. The command line is still telling me to select objects. The reason for this is we can select multiple objects. Once we are happy with our selection, what we do then is press Enter for the tool to take action. So now we have applied the Explode command on the polyline, and what that has done is change it from a joint segment to singular segments. This is one application we can use the Explode tool for. There's obviously many more. We'll be using the Explode tool throughout the course, so you will see where else we can use the Explode tool, but this is the general basics of what the tool can do. So now that we have exploded this polyline, we want to also have the option, if these were lines as they are, to be able to join them together to then be polylines. So we're just kind of reversing what we've just done. And of course we can do that using the Join tool. So in the Modify panel, we have a drop-down menu, and you'll see most panels have an additional drop-down menu. So within the additional drop-down menu, here are the tools which aren't as frequently used as the ones which are in the panel above. If we do find ourselves using these tools more frequently, what we can do is actually pin that so it is always open. So if you wanted, you could always have the Modify panel pinned open. I'm going to keep it off. Reason being is we can also just simply click it to drop it down. And the tool that we want to use now to join everything together is the Join tool. And it's this one here. So we have two lines pointing at each other. And again, the process that we want to get into the habit of doing is first selecting the Modify tool. And again, the reason I want you to do this is so we can follow the next steps using the command prompt. So it's telling us to select the source object or multiple objects to join at once. So we can either select them individually, or we can do our green crossing selection.
Once we're happy with our selection, we'll just then press enter to complete the action. And there our line has been converted into a polyline, and they're all joint line segments. Okay, so I'll delete everything off our sheet. So now we're going to move on to the next tool, which will be our offset tool. So what I'm going to do is just draw a line. So the offset tool will create a parallel line or a parallel curve at a specified distance from our original object. So for example, I have my line here. I want to create an equal length line at a parallel distance from the original. So if I come to the Modify panel, at the end there we have our Offset tool. I'll select the offset. And the first command prompt is I must specify the distance that I want my offset to be. So just for scaling purposes, I have drawn this line at 1000 units. And I want my offset from that line to be 200. So I'll enter 200. I've now specified my offset to be 200. So the next step is to select the object, which is my original line. And there we can see the line will offset above by 200 if I move my cursor up above the line, or if I go below the line, I will then create an offset below that line. I'm still in the tool, so I have a choice of going above or below. And to finalize the position, for this example, I'll go above the line, I will just one left click of the mouse will place the line. And you'll notice from the command line that I'm still within the tool. The reason for this is I can continue to offset that line. I can as well go below. And I can continue to offset that line as much as is necessary. Once finished, I then press enter to complete the action, and we're finished. We're out of the offset tool. So now we've taken our original line and we've offset it above and below by 200. So if I go to my distance tool, I can just double check the distance between those lines is exactly 200. So instead of drawing a line above and by 200 at the same distance, I've saved myself time by just simply using the offset tool. Now with the offset tool, if I was to draw some continuous lines using the line tool, and again, I'll use my offset. So when I go into the offset tool itself, the last distance that I entered in will be the distance that is current. So you can see in blue, the last distance was 200. If I wanted to continue using that distance, I'd simply press enter. If I wanted to change to a different distance, it's now is when I would enter in that new distance. For this example, I'm going to continue with 200, so I'm going to press enter. Now, as this is a line, when I offset it above or below, you can see we have a small issue where our line was originally joined together, but now when I offset it, it's now broken. So the reason for this is we originally used the line tool. If we then redraw that as a polyline, we won't have that issue. So I'll draw my polyline. And we'll go offset 200. And there we'll see the difference is when I offset a polyline as it's a joint line segment, the whole polyline is offset together. What I'll do is I'll select and delete that lower line. And I'll give you an example of if we first draw by line, how we can join it back together to create a polyline to save ourselves time redrawing that. So what I'll first do is, as we see it's a polyline, I'll go to the explode tool, select the tool, select the object, press enter. Now those polylines are now singular segments, they're all lines. So when I use my offset tool, pressing enter to use the 200 distance, we can see those lines aren't joined. So I'll select delete and delete. So the aim here is to join all of those lines back together to be polyline. So when I offset it, they are still one complete polyline. So I'll come down to the modify, join, select the object, press enter. Now we have a joined polyline. So when I go to my offset, pressing enter to accept that distance, selecting the polyline and placing above. So instead of deleting all of the lines, here we use the join tool to create a polyline for us to then offset, saving us some time tidying up, joining the lines together.
The next modification tool we're going to be looking at is called Trim. So back here in the Modify panel, so the third tool in, we have Trim. So to demonstrate this tool, what I would like you to do is to open up our folder. And I'd like you to open up the Trim file. So the purpose of the trim tool is to trim away or remove excess pieces which we no longer require. To activate the trim tool, we'll come to our modify panel and we'll select the trim. So it's the third over. One click of the mouse will activate our trim. Now I'd like to zoom in to the top object. So there are two options of how we can trim. And depending on the version of AutoCAD you've downloaded, some will be set to one and another to the other. So to make sure that we're all on the same option, I'd like you to come down to the command line where we have the option trim. And here we have mode. So yours might look different if you have the other mode selected, but essentially all we're looking for is the mode option. So we'll select mode. And what I'd like you to do is to select the quick option. So we'll select quick. So the purpose of the trimming tool is to trim away excess pieces. So for example, here we have two lines with an additional piece which casts beyond it. So if we wanted this line here to remain and this line, but to tidy up this corner, the trim tool would just simply trim away that additional piece. So one click of the mouse and that piece will be trimmed away. One important thing to know is that the lines must intersect. So if the lines do not intersect, you cannot trim them away. And the excess piece that will be trimmed away, for example, coming down here, if I wanted to remove this excess piece, it will only trim back until it meets or intersects with another line or object. So I'll select this additional piece and you'll notice it's not casting past this line here and trimming beyond it. So it's only going as far as this line. So again, we'll just click on the additional piece. And coming into the center here, we can also trim away this small segment here. As when we hover over it, we have those two vertical lines. So there will trim back to that line where it intersects this line here. So we can select that line, it will be trimmed away. And within the quick mode, we can also trim away additional pieces like this, which we could also use the delete key afterwards. But within the quick mode, we can also remove that section. So essentially, as long as there's a point of intersection across that line, we're able to trim that back to that point and enter to finish. So another feature within the quick trim, if I select trim again, is we can click and hold down the mouse button and I can drag my cursor around
very similar to the lasso when we're creating our window selection. So we're able to just click and drag. So we're able to carry out multiple trims all at once. And when I let go of the button, all those additional pieces will be trimmed away, and we just press enter to finish. Okay, so we'll use our undo button to bring back our original shape. And zoom back in. So now that we have our object back, we're now going to select our trim, come down to the command line, select mode, and change over to standard. Then once we select standard, we'll just press enter to confirm that. So now our trim is set to standard. So again, we'll select our trim tool. So you'll notice this time when I hover over the excess pieces, I'm not being displayed that preview of it being deleted, as the steps for the standard are different. So when we use the standard mode, what we need to do is first select the lines which we want to be trimmed. So for example, if I wanted to remove these excess pieces from this line here, I will select those lines, pressing enter. And now I can remove those excess pieces and enter to confirm. So there is an additional step to this, but I'm going to demonstrate why there is more benefits with this one than the quick mode. So again, I'll select my trim. So I want to remove this excess piece here coming down to this line. So I wanted to ignore this line. If I was to use the quick mode, all I would do is remove this section here, as once it reaches this line of intersection, that is the only piece which will be trimmed away. So I want from here to here to be trimmed away. So what I do is I will select my line to be trimmed. I will select the intersecting line where I want my trim to come down to. So now that I have my two lines highlighted in blue, you'll see everything else remains in white as it's not included in my selection. I'll now press enter to confirm that selection, and when I hover over the line, you see the display ignores this horizontal line and moves straight down my blue selected line. So this is one benefit of the standard over the quick. You have a more precise trim. If you wanted, you could select trim, highlight everything, pressing enter, and you can then select all of the trim pieces. And enter to finish. So you could either select all of the objects and trim, or if you wanted to do a specific lines, just select those and enter them into your selection and then trim away. So now I'm going to move down to the bottom left hand corner to see the shape here, and we'll now work on this. So what I want to be left with is this X in the middle. And what we'll do first is we'll use our trim, our quick trim. So we'll select trim, come down to mode, select trim, we'll just press enter, and then we'll come back and activate our trim again. So to show confirmation of which trim type we have, if you come into the command line, you'll see there we have mode quick. So what I can do is I can click and drag my trim around those additional pieces on the outside and letting go to remove the trim. And I can then repeat the process to remove those additional pieces and letting go, pressing enter, and then I can simply select and delete. Trimming away those pieces on the outer side and on the inner part of the shape. So there we're left with our shape of an X. So we'll move over to the right hand side, and for this one we're going to change over to the standard trim. So we'll select trim, come down to mode, select standard, we'll just press enter to confirm that, and then select trim again, So we'll just come down, we'll confirm that our mode is now set to standard. So in here I have an capital A, so we need to trim this up. And what I'm going to do is I'm not going to select all and trim, I'm going to choose particular lines to carry out my trim so I'm not left with additional pieces. So first of all, I'm going to tidy up the outside. So I'm just going to select my outer lines. And now there, trim. And now I can select my inner lines and select top bit. I can delete, TR for trim, and then I can remove those sections down the bottom. And I now just need to open up this section here for the A. So again, TR for trim. There are my two lines. And again, once they intersect with another line, I can carry out the trim and enter the finish. So I prefer to use the standard trim over the quick trim as I have more control over what I'd like to trim. If you want to continue with the quick trim, please do. Just know that I'll be using the standard trim for the remainder of the projects. So we'll close that down and do not save. And we're back to our main drawing. Now that we know how to trim an object, we're now going to look at how we can also extend an object. So for this demonstration, again, I'd like you to open up the extend file in the download folder. So we'll go to open. We'll look for the extend file and select open. So just like our trim tool, we have two options for the extend tool. If you are using AutoCAD prior to 2021, the quick feature won't be available to you. So this is only available to 2021 and above. So the extend tool actually lives with the trim tool within the modify panel. So we'll come to our modify panel, and in the drop down arrow we have extend. So we'll click on that. And just like with the trim tool, we have to select our mode. So we'll come down to our command line and select mode. And the first one we'll look at is quick. So what the extend tool will do is it will extend an object to meet another object. The one thing to keep in mind is there must be something for it to attach to. So for a quick example, if I draw two lines, and what I want to do is extend this line up to meet the other, but if this line is not on a path to intersect the second line, it will not extend. So you see I'm getting a warning symbol there to show that it will not extend. So I'll select my extend tool again, double checking the command line that I am in the quick mode. And now I can demonstrate the extend tool. So what I want to do is extend out the steps of this ladder to meet the left and right side. And to do that, I just hover over the end where I want to extend. So if I want to extend the left side, I hover over the left side. If I want to extend the right side, I hover over the right side. So once I get the preview, I just click. And with the quick extend command, I'm able to quickly extend those lines out. Same for the right side. And enter. As with the trim tool, we also have the drag freehand. So when we're selecting our extend tool, we can just click the left side of the mouse, holding it, and we can drag and we can quickly extend those lines out. and enter to finish. If I wanted to then further extend those lines out to the outer side of this ladder, I can continue on coming back into the quick extend tool, and I can quickly extend them out. As well with the freehand, like so. So what I want to do is I want to undo that to bring it back to the start. And we'll transfer over to the extend standard. So we'll click on extend, come down to mode, change over to standard, pressing enter. So when I re-engage my extend tool, we'll see the mode is now select as standard. So the difference between the quick and the standard is, with the standard I have to first select the line that I want to extend to, which is the inner side of the ladder. Once that is selected, I then press enter to confirm that selection. I then need to select the objects that I want to extend, being the steps in the ladder. So I can either do one at a time, or I can click, let go of the mouse, and select all, click again, and enter to confirm. So the difference between the quick and the standard is there is no room for error in the standard. It will not extend out past that to the outer side of the ladder. So within the quick, there were some mistakes where it extended out by itself, but with the standard, we know for certain that it will not do that. So just like the trim, we can also ignore lines and extend directly out to the outer line. So we'll do that again. So we'll select extend, select the outer line of the ladder, enter to confirm that selection, and then we can do the quick selection and enter, and you see that it ignores the inner side of the right side of that ladder and extends directly out to the outer right side. So again, if you feel more comfortable with the quick extend, please feel free to use that. Again, personally, I rather use the standard as I have more control over what I want to extend to. So what we'll do is we'll close this down. We won't save it, and we'll come back to our main drawing. So we'll now just delete out those lines, and same with these here. And we'll move on to the next practical, and we'll draw it in this position here. So we'll zoom in, give ourselves plenty of space. And referring to the PDF, we're on practical number 5. So with this practical, we want to use the tools which we've just learned. So in it, we'll be using the offset tool, the trim and extend, and the join tool. So again, I want you to pause the video. I want you to try this out for yourself first. And then once finished, you can continue the video and watch how I do it. Okay, so what I'm going to do is first start on the outside, and I'm going to use a polyline. The reason I will use a polyline is so this line will be a joint segment, allowing me to then offset it inside. So we'll go to the polyline, click for my start point, and the outer section is 600. Top line is 900. Using the snapping point, bring it over to the next position. Then we'll go across 250, up 50, 50, 50, across 300, down 50, 50, 50, and back to the start. And enter. So now we have our joint polyline for the outer ring, and we can move on to the next stage. So now what we can do is we can offset the outer line in, and that distance is 50 millimeters. And that saves us time by drawing the inner section. So I'll go to my offset tool. I'll enter my distance of 50. I'll now select the object. and I'll move inside and click and enter to finish. I now have my inner line offset. So next thing we can focus on will be this section here. What we need to do is break the inner line in order to extend this line up. So I'll use my explode tool, select the object and enter. Now the inner lines are singular. And what I'll now do is I will use my extend tool to extend this line straight up. So go to trim, select the arrow down to extend. I'll then select the line. And once I get the preview of where I want it to go, I'll then click. Same on the other side. So now that we have this outer line, we can offset it inward by 50. So we'll choose our offset. We have 50 as our distance already, so I'll press enter. Select the line and bring it inside. Select the line and bring it inside. Enter to finish. Next, I'm going to use the trim tool and just trim up these excess pieces. So come back to extend, drop down arrow, change over to trim, and we'll then select the excess piece. Enter to finish. We also have to trim out this inner piece. So we'll come back to trim and trim out the inner piece. Enter to finish. Now we'll come back to our PDF. And here we need to draw the inner rectangle. And what I'm going to do is I'm going to take this line and I'm going to offset it up by 50 and then up by 200. So this line here is the one I'm going to offset. First I'll offset by 50. Now that I've finished with the 50, I press enter. And if I click enter again, it'll re-engage the offset command. I just have to change the distance from 50 to 200 and press enter. Select the line, move up and click. Enter to finish. Next I need to trim this inner piece. So I'll come back to trim and remove. Next we're going to work on this outer section. And from this line it's over 100. So we're going to offset that out by 100. So we'll click on our offset, change our distance to 100, select the line, move in the direction we want it to offset and click. Select the line, move in the direction and click. Enter to complete. And finally just extend to create this line here. So we want to extend this line out and this line as well. So we'll change trim over to extend. So first we'll select this line to extend out here. And then we can extend it out again. So extend it out once and come back and extend it out twice. Enter to complete. Now we'll just do some tidying up by using the trimming tool. So removing the excess pieces and the inner piece and the remaining inner pieces. And enter to finish. There's many ways in which we can tackle this. There's no right or wrong way, whichever way you're comfortable with for now. As you're progressing through the course, you can redo these and you'll see the difference and the speed at which you'll be able to undertake these practicals. We're now going to be looking at certain tools which you'll be using quite a lot. For example, the Move tool, the Rotate tool, and the Copy tool. So I'm going to move over to a clear space. and I'm going to go to my polyline tool, and we're just going to draw a quick square. 500 units by 500. The reason I've used the polyline is so we have an object instead of singular line segments. It'll just help us when we're trying to move the object itself. So in the Modify panel, here we have the Move tool. So to activate the Move tool, we'll just one click of the mouse, and our dynamic input is asking us to select the object. So I'm going to click on my square. So the Move tool is still asking to select the object because we can, in fact, select multiple objects and move them all together. So what we need to do is press Enter to confirm our selection. Next, it's asking to specify the base point. If we imagine the base point as where we want to pick that object up. So if I wanted to pick my object up from the top left, top right, that's what I'll do is I'll hover over, look for the endpoint, and one click of the mouse will attach my cursor to the square. So now my cursor is attached to the object and I'm able to move it freely. And to complete the action, one click of the mouse will reposition and move my object. So again, that was select the Move tool, select our object, press Enter to confirm, and our base point is our pickup point. So we'll select the corner of the square. I can move it to the new location and click to place. So within AutoCAD, we always want to be accurate in our moves, whether it's the location we want to put our object, or a particular distance or angle which we want to move that object. So what I will do now is I'll go to my line tool. I'm just going to draw a line off to the right hand side, no particular distance. And what I want to do is I want to pick up this square and I'm going to move it using the midpoint and I'm going to place it on top of the line. So I'm going to go to my Move tool, select my square, press Enter to confirm, come down to my midpoint, one click of the mouse, and it's now attached to my cursor. I'll then move it to the top of that line. Once I see the endpoint, one click of the mouse again, and I've now placed my square on top of that line. And due to the object snapping point, I know that that line is directly in the center of that line. So I'm going to go up and undo that so we can do it one more time. So this time I want to pick up my square and I want to pick it up from the bottom left hand corner and place it on top of the line. So I'll go to our Move tool, select the square, Enter to confirm, look for my endpoint, one click of the mouse, it's now attached to my cursor, I move it on top of the line, one click of the mouse, and we've now moved our square to the top of that line. Now undo and bring our square back. I'm going to delete the line. Next, I'm just going to draw two lines and just make sure using my snap reference points, just making sure that they're both in line. So the key part is the top here. So what I want to do now is I want to move this square, but I want it to be the same direction and distance between these 2 points. So I want my square to move the same distance between these 2 points. So I'll go to my Move tool, we'll select the square, press Enter. It's now looking for the base point. So before we were using it at the bottom left hand corner of the square, so we could pick it up and move it to the particular location. But I'm going to put my base point at the top of this left hand line. And when I do so, you see the square moves using that base point at the top of the line. So now I'm going to come over to the right hand side, attaching to the top of this second line, and we've now moved our square at that exact distance. And finally, I'll show you how to kind of nudge an object instead of moving it accurately. When you're creating, for example, house plans, you're not going to be using this particular method for accurate positioning of walls or other constructional components. Where you could use this would be, for example, internal furniture, moving the internal furniture around, or garden furniture, accurate within their placement. So for this one, we'll click on the square, and on the keyboard, I'm going to hold the control key and then use the arrow keys as well. So holding the control key, you can go right and left, up and down. And this particular feature, what we're doing is we're just nudging the object into position. So if you had a bedroom, you're trying to relocate your bed, you could just nudge it into position like so. That's using the control key and arrow keys. The next way in which we're going to use the move tool is we're going to specify the direction, the distance, and the angle. So first we're going to specify a distance and the direction. So we'll come to our move tool, select the object, enter to confirm our selection. I'm going to use the bottom left-hand corner as my base point. Click to attach. Now it's attached to the cursor. So I want to move it to the right-hand side. So I'll move the cursor to the right-hand side. We're showing the direction at which we want to move that square. And now just have to enter in a distance. So just judging by my dynamic input, it's telling me I've moved it about 700 roughly. So I'm going to enter in 1000 just for the example. So I'm going to move my square to the right-hand side by 1000 units. And we can move it back. This time I'll move it back by 500, so move the cursor in the direction. Again, we're looking for that dotted green line to ensure we're at 0 degrees. Enter in my distance of 500 and enter. So now we want to look at how we can move that square in a particular direction and also include an angle. So we'll use our move tool. We'll select the square. Enter to confirm the selection. We now want to place our base point. I'll attach it to the corner of the square, bottom left-hand corner. One click of the mouse. So we're going to use our polar tracking this time. So we can either continue around and wait until we have our increments of 45-degree angle. So we can use that if we wish. We can also manually enter in that information as well, just like we had done with the line tool. So I'm going to enter in my distance first, which is 1000. And you can see in my dynamic input, there's my 1000 units. And the angle is grayed out. So I want to jump over now to the angle to change it. So I'll hit my tab key. And there we have our distance of 1000 locked in, and it's now just waiting for the angle. So for the example, I'll type in 59 degrees, press enter. And there my square has moved up 1000 units at 59 degrees. As well as using the distance and angle to move our rectangle by displacement, we can also use a distance and distance by the XY axis. So first thing we'll do as a reference point, we'll come back to our line tool. We'll draw a line at 500 units. Straight across and 500 units down. Then what we'll do is we'll select our move tool, select our object, pressing enter to confirm. And I want to move my rectangle from this bottom left-hand corner to the top right-hand corner of our lines. So I'll place my base point in the bottom left-hand corner, one click of the mouse, and then I'll move it and connect it to the lines which we've just drawn. So the reason I'm doing this is just as a reference point. So in a few moments, you'll be able to judge the distance from our reference. We now want to move our rectangle using the displacement, but entering two distances. So we're going to enter in the X distance first, come on the X axis, and then the Y distance going up the Y axis. So we'll select our move tool. We'll select our rectangle, pressing enter to confirm our selection. And our base point is the bottom left-hand corner, so one click of the mouse. And we see that the rectangle is attached to our mouse. Now what I want to do is enter in my X distance, and I'm going to move my rectangle 500 units along the X axis. So I'll type in 500. To then enter in the Y axis, I'll press the comma key. And I'm now being prompted for the Y axis, so I'll type in 500 again and press enter. So we see now our rectangle has moved 500 units across the X axis and then up 500 units on the Y. So I'll do a quick distance check. So there we have 500 units on the X axis and 500 units on the Y. And what I'm going to do now is just move my rectangle back to the original position by going to the undo command. So up to the quick axis, click on undo until it returns to its position. So when we moved our rectangle a few moments ago, we placed our base point in the bottom left-hand corner of the rectangle. What I'm going to show you now is how we can move our rectangle by displacement using the relative coordinates. So same steps as before, we'll choose our move tool, select our object, pressing enter to confirm our selection, and we're now being prompted for our base point. So instead of placing our base point in the bottom left-hand corner, what I'm going to do is just press the enter key, and what that does is it just places our base point where the X and Y axis join, which is our 0, 0 coordinate. What that allows us to do now is we can now enter in our relative coordinates, so our X and Y. As well, we can also enter in our distance and our angle. So this way is just a quicker way of moving an object without placing a base point directly on the object. You may find this way of doing it a little bit quicker. Once we're at this step and we're being asked to specify our displacement, again, I'll just use 500 on the X, 500 on the Y. So 500, comma key to enter the Y, and 500 and enter. So again, I'll press DI for my distance to check that I've moved my rectangle 500 on the X, 500 on the Y. I'm now going to show you how we can move our rectangle to an absolute coordinate. So previously we used our displacement to move the rectangle a particular distance and an angle, and we also used our relative coordinates for the displacement in the same way. So by using the absolute coordinate, what I'm able to do is move my rectangle, choose a base point, and move it to an absolute coordinate within our drawing, meaning that to a particular XY coordinate. So first thing I'm going to do is just select those lines and delete them. I'm going to come down to my UCS in the bottom left-hand corner where my X and Y axis meet. And I'm going to draw a line and connect it to the XY coordinate at 0, 0, just to create a reference point so you can visually understand what we're doing. So I'll go to my line command. Here I'm being asked to specify the first point. So I'll type in 0, 0 and enter. And you see my line has jumped to where the X and Y axis intersect. And what I'm going to do is I'm going to mark the coordinate of 1000 on the X and 1000 on the Y. So I'll type in 1000, 1000. So again, I can use my DI distance just to double check that I've come across 1000 on the X and up 1000 on the Y.
So this point here is 1000 on the x-axis, 1000 on the y-axis. So this is the point we're going to use for our reference. In order to do the next steps, we have to change a couple of settings. So we'll come down to our dynamic input, down the bottom right-hand corner. If the dynamic input isn't available, come over to the right-hand side, click on Customization, and turn dynamic input on. Once it's on, we'll come back to it and right-click, go to Dynamic Input Settings. Here we'll go to the pointer input and down to our settings and open that. And we're now going to format it. So for our second or next point, so when we first place our first point, what do we want to happen for our second point? So we have two types of formats. We have polar format and the Cartesian format. Then below that we have the two types of coordinate systems which we're using. So we've been using the relative coordinate system all this time. We now want to use the absolute coordinate system. So we'll change over to the Cartesian format and the absolute coordinates and press OK. We'll now press OK. So what this has allowed us to do is when we go to move our rectangle, previously we were asked for the relative displacement coordinate. Now we've changed our settings, and when we're in the relative coordinate setting, when we type in, for example, 500 for the x, 500 for the y, from that start point, the rectangle will move 500 along the x and up 500 on the y, and that can be anywhere within the model. Now that we've changed over to the absolute coordinate, when we type in 500 on the x, 500 on the y, the rectangle will move to that position in our drawing. So we just carry out the same steps. We'll go to Move, select our object, pressing Enter. We now specify our base point. So what I want to do is connect to our point here, which is 1000 on the x, 1000 on the y. So same as before, we'll just type in 1000, 1000 and press Enter. So when we change over to the absolute coordinate setting, you'll see that the rectangle jumps down to that position there, which is 1000, 1000. If we left it in the relative coordinate position, the rectangle would have moved across 1000 units and up 1000 units. And before we continue on, we just go back to change our settings back to the relative coordinate settings, as these are the ones which we want to be using for the course. So we'll go back to our dynamic input, right-click, dynamic input settings, go back to our settings, change back to polar format and relative coordinates format. Press OK and press OK. So now we know that this point here is 1000 on the x, 1000 on the y. Now that we've changed back to relative coordinates, what I'm going to do is move that again, and I'll type in the same information like we've just done before. You'll see the difference in how the rectangle will move. So we'll go back to our Move command. Select the object, Enter to confirm, specify our base point, and if I now type in 1000, 1000, we see our rectangle has moved up along the x and y by 1000. So DI for my distance. There we go, across the x-axis by 1000 and up the y-axis by 1000. And I'll just delete our line to continue on. Next, we're going to look at the Rotate tool. So the Rotate tool is just to the right of the Move tool. First thing we'll do is select it to activate it. Then referring to the dynamic input, it's asking again to select the object. One click of the square. And as we can continue and select multiple objects,
This is the reason that it's currently still active. So we need to press Enter to confirm our selection. And again, it's looking for a base point. Before we were using the base point as our pickup point, we're now using the base point as the center point of our rotation. So you need to imagine how you want to rotate your object and use this base point as your center point for that rotation. So for this example, we're first going to go to the bottom left-hand corner of the square, one click of the mouse, and just for ease of illustration, just come out to the right-hand side, and we'll use that 0 degrees, the dotted green line. And what I'm going to do is I'm going to slowly move it upwards, and we'll see our angle changing. So we're now able to rotate that square around that center point. So we're up at 90, and there's our 45 degrees. If you wanted to use the polar tracking increments, change them before rotating, and you could use a 30, 60, 90 or add in your particular angle. What we can also do is our dynamic input there is waiting for us to manually type in the angle of rotation. So to activate that, if our cursor is on the 0 degree line, what we need to do is move it first in the direction we want it to go, i.e. above the x-axis or below the x-axis. And once we do that, then we'll just manually type it in. So for this example, I'm going to hit 23 degrees and enter. And there our square has now rotated 23 degrees on this point of rotation. I'll click our undo just to bring the square back. So we can also rotate the square from that midpoint, and we'll see the square rotates by the midpoint of the lower line. So the rotation is quite different from being at the far left-hand corner. So again, if I go 23 degrees, and I'll come back to undo that. And next we'll come down to the object snap, and I want you to turn on geometric center, just so we can find the center point of the square. And we'll then come up to rotate, select the object, enter to confirm. We'll then look for the center, the geometric center of the square. If it doesn't appear, hover over the edge, then it will appear. Come back, once we see the green circle, one click of the mouse. Again, come out to the right-hand side, see the dashed green line, and now we can rotate the cursor. And we can see now we're rotating our square at the center point of that square. And again, this is where we'll enter in our angle manually. So for this example, again, I'm going to use 23 degrees. And there we have our square rotated at 23 degrees at the center point of the square. And I'll just use my undo again to bring it back. And again, we'll hit our rotate tool. We'll now select our object, pressing enter to confirm. Next, for the next example, I'm just going to click on the bottom left-hand corner as my base point. And what I want you to do now is refer down to the bottom here in the command line. The tools which we have used already also have features down here. So I'm going to first introduce you to this using the rotate tool. And then later on in the course, I will revisit those earlier tools and I'll show you what else we can do from the command line. So the information that the command line is telling me right now, the first part, it says rotate and it's in bold. So we know that we're currently on the rotate tool. Next, it says specify rotation angle, which is what we've been doing. So this is the default action. So the default action will always be the first set of information. We then move on to the second note of information where it says specify rotation angle or. What we have here is the copy command. So what you'll notice about the wording of copy is the C is capital and it's in blue. What that means is if we were to type C, the command knows that you now want to copy. So whatever the blue letter is what the hotkey is for that command. So if I type C, or I can just click copy, it'll bring me into the copy command.
And when I do so, you'll notice the original square, which is currently grayed out, will then become white. The reason for that is the original object will then be copied, and we will then rotate the newly copied object. So I'll type C and enter, and there we see the original object is now white. So the original object will stay, and we've now created a new copy. So we have two squares. So I can do the same again, select the object, enter, specify the base point. I can rotate the square, typing C, enter. I've copied the second object. And again, I can just click to place, and I can continue doing the same, like so. So if you know that you're about to copy an object and then rotate it, this is a faster way in which you can copy and rotate. So just want to delete these squares. Next, I'll show you how we can rotate that square to a particular angle to match another line or object. So what I'll do first is I'll select my line. And if we draw it out from that bottom left-hand corner, to give you an example of where this would be, if this was your wall, your internal wall, and you've drawn a new object, and it's obviously easier to draw it in this way and then rotate it around. So what we would do is, after we have completed our object, we can then rotate it from this position to meet that wall. So I'll select my rotate, select the object, enter to confirm, again specify my base point, and what I can do is just continue moving my cursor up until the square is on that line, and I want to always ensure that I'm selecting a snapping point, so either the midpoint or the end point, and click. So now I know that my square is sitting exactly on that line. I'll just undo that and delete the line. So if the square is sitting on the line, that's perfect, but there could be some scenarios where we'll have, for example, if this was your wall, but our object wasn't sitting on the wall, but we still wanted to rotate it to match that angle. So we'll select rotate, select our object, enter to confirm, specify our base point, and we'll then come down to our command line again. So we've already used the copy command. We now want to use the reference. So we'll select reference, and it's asking to specify the reference angle. So we want to get to the next stage of this without using that 25 degrees because we want to match this line here. So we must enter 0. When we press enter, we come to the next stage of the command where it's asking to specify the new angle. So we could either enter in the angle again, or we'll choose the points command. So we'll either type P, or we will click points. So now it's asking me to specify the first point. So anywhere along that line, whether it's the end point or the midpoint, will be my first point. So one click of the mouse, and it's now asking for the second point. So I'll either use the midpoint or the end point, one click of the mouse, and there our square has matched the angle of our line. So there we have very different ways in which we can use the rotate tool. We can either simply just rotate the object at different points, we can rotate and copy, or we can rotate to a reference. I'll delete this line, and the next tool that we're going to look at is the copy tool. So the steps and actions of the copy tool are the same as the move tool, so we can treat them very similar. But obviously when we move an object, we create a copy.
So the copy tool is below the move tool. One click of the mouse will activate it. And again, we'll select our object. There's our square. And this is the only thing we want selected currently, so we'll press enter to confirm the selection. Again, it's asking me for my base point. So I'll go to the bottom of the square, one click of the mouse, and it's asking for the second point. Specify the second point. So one click of the mouse will copy my square. Every time I click, I'll create a copy. And enter to finish. So there's our original square, and we've used our copy tool to copy the square around. So I'll come back to my copy tool, and I'll copy it out to the right hand side. So for the next example, I just want to have two squares. So I'll come to my copy tool, select the square on the left, enter to confirm. I'm just using the base point at the bottom just to show that we can pick up the square and we can place it with more accuracy of where we want it to be. So by using the base point, we know that by placing it from one endpoint to another, that they will meet, and the position of that square is 100% accurate. So again, I'm going to copy out one square, and I'm going to create three squares like so. 1, 2, 3. And what I want to do is I want to copy this top square in the same direction and distance as the two lower squares. So what I'll do is select my copy tool, select the square, enter to confirm. And instead of putting my base point on the square that I want to move, as I want to move it with the same distance and direction as the two lower squares, I'll use the end point of the top of the square from one across to the other, enter to confirm, and our new square, I know that it is exactly in the same distance and direction as the two lower. So zooming in on one of the squares, using our copy tool, this time I'm going to move it in a direction, distance, and angle, just like we'd use the move tool. So select our copy, select our square, enter to confirm. I'm going to put my base point at the bottom. So I'm going to move the square in the direction I want to go, and which side of the x-axis I want it to be. So I want to be above the x-axis. If I don't do that, I'm not able to change the angle. So I must go a little bit above the x-axis to show which side of the x-axis I want the square to be. So my dynamic input is telling me that my distance is 1492. So I'm going to type in something similar so it'll appear on my screen. So I'm going to type in 1500, tab key for my angle, and 38 degrees for this example. Press enter. And there we have copied our square up 1500 at an angle of 38. So the mirror tool will create a mirrored copy of whatever object we select across a specified line. So I'm going to select my line. Anywhere to the right of this square, I'm going to draw a line straight down at 90 degrees or straight up at 90 degrees, whichever you've chosen. Enter to confirm. And to the right of the copy tool, we have our mirror tool. So I'm going to use the mirror tool to mirror this square over the line to the right hand side. So it's going to mirror the square over this line to the right hand side. So I select the mirror tool, I select the object, enter to confirm. It's now asking me to specify the first point of the mirror line. I'll go to the top, and as I move down, I'm looking for the endpoint, and we'll see that the square mirrors across to the right hand side. Here we must refer back to the command line. It's asking, do I want to erase the source object? So the source object is the square on the left hand side. If I click no, both will remain. If I click yes, the square on the left will disappear and the square on the right will remain. So I'll choose no, and both are here. So I drew that line just to give you an idea of how we mirror across using the mirror line, but it's not necessary. Using the mirror tool, select the object, and we'll just draw our line. Again, taking full advantage of the polar tracking, looking for that dotted green line to ensure that my line is straight. And this time I will choose yes. So you can either click yes or type Y, enter. And using the mirror tool again, instead of doing a straight line, we can also do, say, 45 degrees. And N for no. So now we've just mirrored our square across a mirror line at 45 degrees. And what we'll do is we'll mirror both of these across the mirror line. So you see, if I go straight down, we have our line at 270, and as I rotate it, you'll see the angle changes. So it'll always mirror across our mirror line. Okay, so what I would like you to do is we'll remove those squares so we can have a clear space for our next practical. So we're now on practical 6, and our main objective here is to use the mirror tool to mirror our left-hand side of the table to the right-hand side. So what I'd like you to do is to try this yourself first, and then afterwards I will take you through the process. So please pause the video. And first thing we'll do is use the line tool at the top. First line is 400. And if your line is either too far zoomed in or zoomed out, just use the scroll wheel to center that line on our drawing space. Then come down, we have 50, 400 again. Next we have the leg. So you have a couple ways in which you can do this. We want our leg to start over by 50 mil. So you could either draw a line of 50 mil and draw straight down, and then afterwards delete that line. There's nothing wrong with that method, but within AutoCAD you want to refrain from drawing lines over lines, as the drawing can get quite sloppy and messy, and when you go to print you might have some larger lines where you need thinner lines. So what we will do is we'll use our snap reference, but we'll do it in a different way. So with my line tool, I'm going to zoom in for this. So I know that my line will start 50 mil to the right hand side. So I will hover over like we've done before, and we'll use our snap reference. So there we have our little green crosshair. Once that appears, what I'll do is I'll move my cursor in the direction I want my line to start. So the snap reference is now my starting point, and I want my line to start over to the right hand side. I will then enter in the distance. So the distance is 50 mil, and enter. So there my line has jumped from our snap reference over to our new position 50 mils over. So by doing this, we just save ourselves time coming back and deleting that line, or perhaps we might forget to delete that line and it will interfere with the drawing later on. So this is a good tip on how to speed up the drawing process again. We're now going to draw our leg, which
the total height is 450 mil. The depth of the tabletop is 50, so our leg is 400. Enter. The thickness is 50. Enter. We'll then come up 200. Enter. Then our inner leg piece is 300. Enter. And enter to finish. So at this point, I can either copy my line up by 20. I can also offset it if I wish. I could also use the snapping reference to move up by 20 mil. There's no right or wrong. It's whichever way you feel more comfortable at first. So what I'm going to do is use the copy tool. I'll select our object, press enter. My base point is the end of the line. I'm then going to move in the direction I want that to go and enter the distance of 20. Enter. Enter to complete. And then just draw in the line to finish off. So there we have the left-hand side of the table. We'll then come to our mirror tool. And we need to highlight the entire table. So we can either use the window selection or the crossing window. I'm then going to press enter. So it's asking me for my first point of the mirror line. As we want the table to mirror over on itself, we must draw our mirror line at the end of the table. If I was to draw the mirror line away from the table, you can see the distance between the table and the mirror line is mirrored on the opposite side. So that's why we're having such a huge gap. So that's why I'm going to mirror my table exactly at the end point. So we have no gap. The table is mirrored across and matches itself. Do we want to erase the source object? No, we don't. And now we have our complete table. And the next drawing tool which we're going to look at are circles. Back in the drawing panel, we have our circle. If we hit the drop down arrow, you'll see all the different types of circles which we can create. Obviously a circle is a circle, but it's the way in which we draw that circle. The first one is center radius. So we'll come back into the drawing area, and our command line is telling us to specify the center point. So one click of the mouse will do that. And there we have our circle, which is our center radius circle. Named so because the first point is our center, and second we enter our radius. So we either have the option of just using our second click just to randomly position our circle, or do we want to be more accurate and we want to enter in a particular radius. So on my drawing, you can see I've got about 188 units. Yours will obviously be different to mine, but I want to use that again as a reference for what radius to enter. So because I'm close to the 200 mark, I'm going to enter in 200, and you should do the same for yours. So you can enter in what is the closest figure you have for your current radius. So I'll type in 200 and enter. So there's our first circle, drawn first with the center point, and we'll then enter in the radius. As the last circle we drew was the center radius, it'll always be the one at the top. So there's no need to always go back to the drop-down menu and select center radius. As we drew center radius, we just have to click on the circle icon, and then we can begin drawing the next center radius circle. When I look at the center diameter, so we'll go down to the next one, we have center diameter. Same process, click for our center point, but instead of the radius, we'll enter in the full diameter. So the diameter I'll be entering is 300 and enter. So there we can see our diameter is 300. And again, as I just used the center diameter circle, you can see it's the one at the top now. So if I wanted to continue using the center diameter, I would then just select the top icon. Next, we'll look at 2-point. So the 2-point circle will draw a circle based on the 2 end points of the diameter. So when I first click, we're at one endpoint of the diameter, and then I'll move in the direction. I can also add an angle, and using the dynamic input, we can also add in a distance, hit the tab key, and then add in an angle. But the 2-point circle, we're looking at the 2 endpoints of the diameter to create the circle. So one click will be the first point, second click is the second endpoint. So there's our first point and our second point. Next we have 3-point. So with the 3-point, we'll draw a circle based on 3 points on the circumference. We'll click for our first, click for our second. So instead of being the 2 endpoints of the diameter, we're just adding 3 points on the circle. And we'll click again for our third point. Next, we have our tangent radius. For this one, we'll come between 2 of the circles, and we're looking for the tangent of 2 of the circles, and we'll then finally enter in the radius. So hover over the first circle, look for the tangent symbol. Hover over the second circle, look for the tangent symbol. So when I select the tangent of the first circle and tangent of the second circle, I'm shown the lowest radius that is possible for this particular circle. So the lowest possible radius I can have is 297. Anything below that and the circle would not be tangent to the original 2 circles. So that is the lowest radius that I can achieve. So if I press enter, there we have our circle, which is tangent to the original 2. If I went lower than the 297, it wouldn't touch those 2 circles. I can, of course, go higher than that. If we go for the first, second, and 500, there we have the tangent points and a larger radius of 500. And the last circle is tangent, tangent, tangent. So for this particular circle, you do obviously need 3 circles as we have 3 tangents. So here is the points which I'll use. So we have tangent, 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 and there's our circle which will be generated. So we have no way of controlling the radius or diameter as we're choosing the 3 tangential points
of the original 3 circles. Okay, so I'll just go to my circle and I'll put it back to center radius. And the next drawing tool we're going to be using is called a polygon. So we come to the rectangle tool in the top right hand corner, which we'll cover in a few moments. Below that is the polygon. So a polygon is an equilateral closed polyline, and we have 2 different ways in which we can create it. So there are many steps to creating this, but again, we'll just refer to our command line and it'll guide us through the process. So first it's asking how many sides do we want on our polygon. So for the example, I'm going to type in 6, enter. Then asking for the center point of the polygon, give yourself a nice bit of clear space and 1 click of the mouse. It's then asking, do you want it to be inscribed in the circle or circumscribed about the circle? What I'll do is I'll draw both so you have an idea of what they're referring to. So we'll first go for inscribed, and then I'll move my cursor up. If we go to the right hand side at 0 degrees, there we'll have our polygon. We can of course draw that at an angle, or up 90 degrees will also change the shape. So I'll first draw this one. 1 click of the mouse will complete the process. We can also type in a radius. So the dynamic input is telling me that the current radius there is 575. So if I type in my radius of 600, enter, there's our polygon. And what I'm going to do is I'm going to draw a circle so you can understand what they mean by inscribed and circumscribed. So I'm going to come back to my circle, select, and now I need to find the center point of this polygon. So if I turn the geometric center off, you can see it's already giving that information to me. I can show you another way in which we can find the center point. Choose our circle. We're going to use the snapping reference point. So I'm going to leave a little snap reference at the bottom. Come over to the right. Now that I have 2 of those snap reference points, when I come to the center point, when the 2 dotted green lines meet, 1 click of the mouse, and I know that I'm now at the center point of that polygon. I'm just going to attach the circle to the end point or use that radius of 600 and click. And there's our polygon, which we originally drew it as an inscribed polygon. So you can see it's on the inner face of the circle. Now when I come back and choose my polygon again, so I'll enter the number of sides as 6. I now need to choose the same center point as this polygon. So we'll use the snap reference point, come into the center, click, and we're now going to choose the circumscribed about the circle. And if I come out to the right hand side, or I can just click enter for the 600 radius. Here we'll see the polygon is on the outer side of the circle. We can see the shape is slightly different. If you wanted the shape to match, instead of coming out at 0 degrees, you'd go to 90 degrees. So if I come up 90 degrees, I'll get the same rotation of the shape. So there we have our inscribed polygon and our circumscribed about the circle.
Next, we're going to look at the fillet command. So the fillet command will either round or fillet the edges of two objects. So again, I'll come over to the right-hand side, give myself some space. So for the fillet command, we'll use our line tool, and I want you to draw one line up at 1000, enter, and to the right at 1000. Then we'll come to our fillet command, which is here in the Modify panel. We'll select Fillet, come into the drawing. So the process we've been following for the commands has been to watch what the command line is suggesting. Now for the fillet command, the first thing it's saying to do is to select the first object. Unfortunately, that's not what we need to do with the fillet, because if we come down to our command line, if we come to our radius, it's telling us that our current radius is 0. So if I do as the command line is suggesting, nothing happens because our radius is set to 0. So that's why it's always important to just refer down to the command line to ensure what we want to do is possible. So when I select my fillet, what we want to do is we want to change that radius. So we have two ways in which we can do it. We can either come down and just click on radius, but it's also suggesting that if we just type in R, and I know that because the R is capital in radius and it's also blue. So if we type R, then we can then change the radius quickly. So I'm going to select radius, and we then refer to our command line. So it's asking what radius do we want our fillet to be. I'll type in 250 for this example, press enter. So we'll select our first line. And once we do, I want you to hover over the second line. And when we do, we get a preview of what is about to happen. So the solid blue line is what we're going to be left with, and the grayed out lines at the top are what are going to be removed. So we can click and the action will take care. So we've now just filleted that corner. We've given it a nice round edge at a radius of 250. I want you to undo that so we can do it one more time. We'll go to fillet. We'll go down to our radius, enter 250, and we'll choose our two lines. So we come over to the right hand side, and again I want you to draw another two lines at 1000 units. We'll choose our fillet. And when we choose our fillet, if we notice down here, our radius is set to 250. And that's because the radius we just previously entered was 250. So if we're doing the same action again and again, we don't have to manually type in the radius. We can just simply click enter at this point. We can simply just select our objects and continue. And this will speed up our process. So we can select a line and select our second line. And I'm going to draw the same lines again, but this time I'm going to use the polyline. So using the polyline tool, we'll go up 1000 and to the right by 1000, enter. So now I'm going to go to our fillet command. Come down to our command line, and there we have a polyline feature. So if I select the polyline, so once I select the polyline, I come into the command line, and it's asking to select the 2D polyline, and what it will do is it will use the previous radius we've just entered, which was 250. If we wanted to change that, we'd have to do that now. So we'd either click on radius or click on the R key to change it. So what we'll do is we'll select the radius. There's our 250. So if we change it to 150, enter. Now it's asking to select the polyline. So
We'll hover over one, and as it's joined to line segments, we just have to select the polyline and it will do both at the same time. And click. And again, if we'll choose our polyline and if we draw a square, enter. So doing the same method, we'll go fillet, polyline, we'll change our radius again to 200, enter, and select the polyline, and you'll see all edges will change at the same time. So this is another benefit of using the polyline when we know that what we're drawing requires this method. One click of the mouse does all four corners at the same time. So again, I want you to use the line tool and draw 1000 by 1000. And this time we're going to use the trimming tool. So we'll select trim. And we have trim or no trim. So it's currently set to trim. What this means is when the fillet command will create that nice edge piece, that those two excess pieces which are left, do we want them to be trimmed or not trimmed? So for the example, we'll choose no trim. And we'll continue to use the same radius of 200. So we'll select the bottom line and the top line. When I hover over, you now see that all pieces are in blue, meaning that those excess pieces will not be trimmed. So click. So there we have our nice fillet piece, and those remaining pieces are not trimmed. So again, it's quite helpful and useful if we know that we don't want those pieces to be trimmed. So we need to come back and we need to turn that off. So we'll go trim and turn trim back on and enter. So again, I want you to draw a square, but this time just using the line tool. So we'll do 1000. And the last tool we're going to use will be the multiple. So we can click on multiple. Our radius there is set to 200. If we wanted to change our radius, we'll again just come down to radius. And we'll select the first line, second line. And when we select multiple, what this means is when we carry out the first action, the tool is still active. So we can continue selecting multiple fillets. And the very last command, which is in the fillet, is undo. Okay, so we'll draw one last square. And again, fillet. Again, we'll use multiple, keeping the radius. And remaining in the tool, the last thing that we're going to look at is the undo option. So we can undo the last action, like so. So as long as you're still within the tool, you can use the undo option to undo your last action and enter to finish. As I said, the fillet command will round the edges of two objects. So a line isn't the only thing which is an object. We can also apply fillet to circles. So we'll come back over to our circles. We can select our fillet. Yeah, our radius is fine of 200, and we can then select the two circles, which will create a nice fillet between the circles. When doing so, if we want it to be on the left-hand side, so just ensure that the cursor is on the side which we want the fillet. So for the right, I'll do here on the right-hand side, and then for the left, do on the left-hand side. So again, I want the fillet to be on the top here and on the bottom. So for practical number 7, we're going to be using our circles, our polygons, and our fillet command. Now at first it might look a bit daunting, but don't let that set you back. What we've just covered is in front of you, so best thing to do is to start with what information that you have. So at this point, I'd like you to pause and try it yourself. Okay, so how I'm going to start this is on the right hand side, we have our two circles here with a radius of 250 and 130. Come over, give myself some clear space. And I'm on center radius circle. If you're not on center radius circle, we'll just hit the drop down arrow, choose center radius. So our first circle was 130. As my last command was the circle, if I hit the enter key, it'll bring me back into the circle tool. And both of my circles have the same center point. So I want my second circle to be the same center point. So I'll hover into the center. If the center point doesn't appear, hover over the edge of the circle and come back in. Our radius is 250 and enter. So now we have these two circles drawn. We know that the distance between the center points is 1000. So we want to copy both of those circles to the left by 1000 and down to the bottom again by 1000. So I'm going to select my copy tool, select my two circles, and enter to confirm my selection. So my base point. As I know the direction and the distance, the base point isn't that important right now. If you feel more comfortable putting the center point, do so. But just to demonstrate that the base point right now isn't that important, as I know the direction and as I know the distance, and I'm not connecting to any particular point, I can place the base point anywhere on the screen. So one click of the mouse. So I'll move the circles in the direction I want it to go and enter in the distance. Press enter. Enter to confirm. Now use the copy tool again, selecting all the circles, enter to confirm. We're now going to move them down by 1000 and enter to finish. Now that we have all the circles in the corner, I'm now going to tackle the inner segment. So here we have a 6-sided polygon which is inscribed in a circle, and the radius of that is 380. So coming back to the drawing, first thing I need to do is to draw a line from one center point of the circle right across. The reason I'm doing that is so I can find the center point of all of these circles. So going from the center point of the bottom left to the bottom right. You can also do bottom right to the top left. And we see there's the center point between everything. We'll now select our polygon, enter in our 6 sides, specify our center point. The polygon itself is inscribed in the circle. Move out to the right hand side, and our radius is 380. I can then delete those 2 lines as we no longer need them.
And the outer circle, we see touches off the edges of each of the polygon corners. So we just need to draw a circle and attaching to the endpoint. So we'll go to our circle, look for the center point, and attach to the end of the polygon. Now we have our intersection done. We just need to do the outer fillets. So this outer fillet has a radius of 650. So we'll come to our fillet command, come down to our radius, change our radius to 650, press enter, and we want to do that multiple times. So we'll select multiple. And also our fillets are on the outer section. So we ensure that we click on the outer section of each of the circles so that the fillet is on the outer side. Again, if I draw the fillet on the inner side, we get it on the inside, which is what we don't want. So now there's one last thing remaining, as we need to trim away these pieces here. So we'll select our trim tool. If your trim tool isn't at the top, just hit the drop down arrow and bring it up to the top. There's our trim, and we'll trim away at the excess pieces. And enter to finish. So there is our practical number 7. Moving on to the next command, what we'll be looking at now is called a polar array. So we'll come to our modify panel, and here we have array. If we hit the drop down arrow, you see we have 3 different types. We have rectangular, path, and polar. So we'll now move across and give us some space. So just selecting the escape key, so we have nothing selected. And what we want to do now is to draw a square and a circle. So we'll hit our polyline tool and we'll draw a square 1000 equal sides. I did that using my polyline. And next I'm going to place a center radius circle at the midpoint of the top line to create a shape like this. What the array tool does, and in particular the polar array, its main objective is to evenly distribute object copies in a circular pattern around a center point or an axis of rotation. What that means is we will take this shape which we've just drawn, and with a center point of our choosing, our object will copy around that center point, and we also have full control over how many items we want copied around that center point. So what I'll do is I'll select my polar array, one click of the mouse. And the next step is to select our object, so I'll select the square and the circle. Once we've made our selection, pressing enter to confirm that. The next step is to specify the center point. Wherever I will click with the mouse, that will then be our center point, and our object will copy around that point in a circular pattern. So one click of the mouse. So there's our polar array, and after we've created the polar array, you'll notice that a new ribbon has appeared at the top. So you see our tab now says Array Creation, and here is our polar array ribbon. So the first panel there just describes what type we have, so it's showing that it's polar. And we can see that by our center point and the items rotating around in a circular pattern. All of these figures will be determined simply by default, so when we first create the polar array,
we'll have 6 items. It'll also specify the angle between them as 60. And we have our fill, which is 360 degrees. So it's showing that our fill of 6 items is rotating around that center point at 360 degrees. Now, sticking with the first items panel, what we can do is we can select that 6 and we can up that to say 8. Press enter, and we've now increased our number of items to 8. You'll also notice that the angle between has changed to 45. So this is all automatically generated. If I reduce that down to 4, we have 4 items, and the angle between is 90. So what I'll do is I'll change the number of items to 6. So all of these changes will not come into effect until we hit the Enter key. Okay, so for the example, I'm going to change the number of items to 8. So next we'll come down to the angle between. You'll see we have an angle of 45. If I try to change that to 60, I can't, because we're restricted by the number of items and also restricted by the total fill angle. What we're able to do is change the total fill. So being that it's 360 means that it will rotate around that center point at 360 degrees. If we reduce that down to 180, we'll see there's our object rotated around that center point at 180 degrees. Okay, so we'll put it back to 360. Next, we'll move over to the rows. By default, our row number will be 1, so we have 1 row of items. We can increase that up to 2, so we now have the first inner row and the second outer row. What we can do is we can change the distance between the first and second row. So if you imagine here, point A to point B, so we can change that. If we up the number of rows to say 5, the total distance will be from point A to point B. So there we can change that as a distance as well. The next panel is referring to levels, which is 3D AutoCAD, so we're not going to be touching on that. And then we'll move down to the next panel, which is the properties. So first we have associative. What associative is referring to is all of the items would be joined together as one unit, meaning that if we were to now close down the array, and we're back in the drawing, if I was to hover over and select the polar array, we can see all of the items still remain joined. And what that also allows us to do is to come back and we can still alter the array itself. So the associative option is only when we originally create the array as associative, allows us to come back and alter these settings. Next is the base point. So if we select base point, what we can do is we can redefine the base point and location of grips on the array. So this allows us to change the position of the base point. Where we would utilize this feature would be if we had other items on display and we wanted to match a particular base point to the items on the screen, we could then pick up the grip and attach it to that. Next is rotate items. So we know that this is our original item, and we can see that the new items which have been copied are actually rotated around that point. So they're not in the original orientation of the item. So if we were to turn off rotate items, we see that the orientation of all of the items refer back to the original.
And lastly is the direction of the array. So when we changed the fill from 360 to 180, what this is referring to is the direction of which the array was created. So here's our original item. When we created the array, you can see the direction was going in a anti-clockwise direction. If we switch it off, we'll see that the array goes in a clockwise direction. We'll also see here in the center we have our center grip. With that we can pick up and move the array. The next grip will stretch the radius, so we can increase the radius or decrease the radius. The next grip over to the right, what that will do is it will change the angle between the items. So the angle between the items, which in the ribbon is set here. And then the last grip is the total fill. So there's our total fill of 252. I click and drag. We've then reduced it back to 200. So it's just a different way in which we can alter the figures within the panel here. Also, if I increase the number of rows, we have another grip, and this grip here, this grip will increase the number of rows. And then in the center here, we'll increase the distance between the rows. So again, you have two options of how you can change the array. So what I'll do is I'll click Escape. And what I want you to do is to just explode out the array using the Explode tool. Reason is, when we select the array, everything is joined together because when we initially created the array, we had the associative turned on. So we want to select Explode, click on the array, press Enter. Now our array has been converted into singular objects. Reason being is we're going to recreate the polar array. Same method, we'll select polar array, select the object, press Enter, specify our center point, but this time I'm going to turn associative off, and I'm then going to close the array. So once I've closed the array, I come back to select the array. You'll notice that everything is a singular object, and we no longer have the capabilities of altering the array itself. So just be mindful of that. So at the beginning, it is best to keep the associative turned on, so you can come back and alter the figures. And if you require the array to be singular items, the easiest thing to do is to just explode out the array. Next, we're going to open up practical number 8 from the PDF. Before you begin, just to give you a little guidance, all the information that you require is there. What you'll be doing is you'll be drawing a circle, you'll be using your polygons, and take it step by step. My advice is to start in the center here, and then work your way out. So if you'd like to now pause the video and attempt it yourself. Okay, so now we're going to look at this together. And the first thing I'm going to do is to draw the 700 line from the center point, 700. So just moving over to the right, give myself some space. Using my line tool, click once, 700, enter. Enter to finish. So I'm just going to zoom in, give myself some space, just so it's clearer on the drawing. Next, I want to draw the outer circle and the inner dashed red circle. So the outer circle is 800 and the inner dashed red is 550. So using my center radius, there's my center point. First outer circle is 800. Enter to close the command, enter to re-engage the command, and 550 for the inner dashed red. So there I have my 700 line, using that as my center point. I have my outer black circle and my inner dashed red circle. Where the dashed red circle intersects our 700 line, that is the center point of this circle here, which has a radius of 150. So circle, specify my center point, radius 150, enter. At the end of the 700 line is the center point for this, we'll call it a nut. So this item here, so there the inner circle is 50, we'll draw that first. So I'm using the hotkey C for circle. Next we have our polygon, so it's an 8-sided polygon. It's inscribed in the circle and it has a radius of 100. So I'll come over to my polygon, which is below the rectangle. First thing I'm asked is the number of sides, which is 8. Specify my center point. The polygon is inscribed in the circle. And this time I'm going to specify the radius. So radius of 100, enter. So now we have this line, the dashed red circle, this nut, the outer black circle. Next thing we need to do is to figure out each of these nuts. So the long way to do that would be to draw each of the lines. We can understand, as this is 90 degrees, this is more than likely 45 degrees. Rotate a copy, or a faster way is to use the array tool, which we've just covered. So we're going to use the polar array, select this nut around the center point, and we'll create all of those nuts. So I'll come to the modify panel, select polar array. It's asking me to select the object. So I want to select the nut, and I also want to select what is the dashed red circle. So I have 3 items selected. Press enter. It's now asking for the center point, and as I want the nuts to array around the circle using the center point here, one click of the mouse. So by default we're given 6 items, but you'll notice on the screen we have, in the PDF we have 8. So we'll come up to our item list, change that to 8, pressing enter. And we have associative turned off. Now at this point, I know that I have done what I need to do with the polar array. I no longer want to come back and make any changes. And I want all of these items to be individual. So I'll turn the associative off. If you create the array using the associative, not a problem. Again, we'll just use the explode tool to make them singular again. So keeping this off, close the array, and we're back in the drawing. So now referring to the PDF. So we have the outer circle, the inner circle, we have all of these dashed red circles and the nuts. So what we want to do is create this inner shape. And this inner shape is made up of this outer red circle at these points here. Once they're drawn, what we'll do is use our fillet command to create this nice curve between the two. And the radius is 100. So the fillet command is just below the trim. And it's asking me to first select the object. But we know with the fillet command, if I select the first object, it's going to use the previous radius, which was 650. So we don't want to do that. We want to enter in our own radius. So we'll come down to the command line, click on radius, and enter our new radius of 100. And from here, we're going to use our fillet command. So we want our fillet to be on the inner edge of that circle. For example, if I do it on the outer edge, we'll get it in the wrong position. So we want to ensure that we're on the inner side of that circle. Come back to my fillet. So my radius is set to 100, and I want to do it multiple times. So I'll select multiple, and I'll just work my way around, selecting each of the circles. Enter to complete. Okay, so in comparison to what we've drawn and what's on the screen, what we want to be left with is only the black lines. So the red ones there are just to help you to understand how to model it. So we now just want to tidy up the drawing to reflect what we have in the PDF. So first thing to do is we'll delete out that 700 line and the inner dashed red circle. The only thing we now have to do is just remove these outer sections of the circles. So we want to select our trim tool and trim away these outer pieces. At the beginning of the course, when I showed you how to use the trim tool, the steps were to select the trim and then come in and we can remove the excess pieces. I'll just zoom in so you can see this a bit clearer. So the trouble with doing that at this point is when we're using the trim tool, we want to trim from this point and we want it to trim back around to the next point. But we have 1, 2, 3, 4 lines which are intersecting the circle, and when I go to use the trim tool, the line is being trimmed to that point. So there's our first line which is interfering with our trim, and there's our second, third, and fourth. So when I'm using the trim command, I want the circle to ignore that nut. And how I do that is instead of selecting the trim tool first, so what I'll do is I'll press escape and I'll select those two fillets and the circle. I have made my selection for what I want to be trimmed. So when I select my trim tool, the only things which are selected and inclusive of that trim command are what I had previously selected. So you can see they're all in blue and it is ignoring the nut. So now when I go to use my trim, you see it will cast right through that nut, coming back around to the fillet. So I'll click on that, press enter to confirm. So with the trim command, the actions with which I have just taken, we can actually program the trim tool to do that first. So what I mean by that is, I will come to my trim tool. So there are two ways in which we can trim. We can either stick with the first method, which will, the trim tool will just look for any intersecting points and it will remove that piece. But in this scenario, you can see that will actually take us time to run through each of those points to remove it. So I'm going to undo that. So what we can do is we can program the trim tool to act in the method which I just showed you. So we'll come to the trim tool, come down to the command line, and the first option there is cutting edges. So we have a capital T in blue, so if you just type T, you can activate the cutting edges, or we'll just click to select. So now when we go to use our trim command, you can see it's now asking us to select the objects which we want to be trimmed. So now that we're inside the trim tool, we can now select each of those lines. We've made our selection, we press enter, and we can remove that section of the circle. So when I come back into my trim tool, we now have two methods. We have our first method, which is known as the quick trim. So we'll just quickly trim looking for the first points of intersection, or we can select cutting edges, which is where we then select the objects which we want to trim. As every time I select trim, it will come back to the quick method, what is known as the quick method. If we wanted to reverse it and use the second method, which is known as the standard method, we can alter the trimming tool. So we can come down to mode, and we'll see there capital O in blue. So if we press O, enter, we'll come into that, or we can just click on mode. We can then enter a trim mode option. So we can use the quick one, which will just quickly trim away the line segments, where it will quickly trim away any line segment between the intersection. Or we can use the standard method, which is where we first select our line segments and then we enter into the trim command. All depends on which one you feel best working with. For me personally, I prefer the standard method, so I can input what lines exactly I want to be trimmed, and then I can carry out my trim. So we'll change over to standard, press enter. So now when I click on my trim tool, straight away the first command is select objects. It's no longer allowing me to just do what was the quick trim. So what we'll do is we'll select our objects which we want to be trimmed. So we'll start at the top. The top one here, we want, like the others, we want that section of the circle to be removed. So we must include the points which the circle will trim to, or that intersection point. We'll also include the circle. So we'll carry around and include all of our objects. We can also do a quick window selection to select those points. So just ensure that all points are selected. Once they are, we'll press enter, and we'll then work our way around and remove the excess piece. So if we had stuck to the quick trim method, we would have had to spend a lot of time working our way through each one of those nuts to trim away the circle. That's going to take us a lot of time. It might not seem like it now, but during your modeling process, to be stuck trimming tiny pieces, you'll just waste a lot of your time. So I find this the quickest way to tidy up your drawing.
We're now coming to the end of the first module, and what we're going to do now is we're going to do 2 practice exercises. First one is on your screen now. So everything we've just learned have all been incorporated into this practice exercise. So what I'd like you to do is to pause the video, and I want you to attempt it first yourself, and then again after you've done that, you'll come back and we'll do it together. So what I'm going to do is start here in the center. I have the first circle with a radius of 200, and with the same center point, I have the next outer circle, radius 800. So just giving myself some space, moving over to the right hand side, coming up and selecting my circle, click to start, and the radius is 200. Enter to deactivate the tool, enter to reactivate the tool. So same center point, I'll hover over the edge for the center point to appear, come back into the middle, and one click of the mouse. Radius is 800. Now that we have these 2 circles drawn, we're next going to draw this inner polygon. So we have a 3-sided polygon inscribed in the circle. So we'll come up to our polygon. Our number of sides will be 3. Enter. Specify our center point. Again, if the center point doesn't appear, just hover over the edge of the circle. One click of the mouse. And we're inscribed in the circle. So when we have a 3-sided polygon, you'll see I can control the direction by either going up 90 degrees, 0 degrees. So just to match the shape of what we have in the PDF, I need to go up 90 degrees. And once I get to the edge of the circle, one click of the mouse to attach it. And what that does, it now gives us, we have point here at the top, point on the left, and point on the right. This will be the center point for the dashed red circles. So we'll draw each of those, radius 800. So we'll select our circle, center point, radius 800. Now to save us a bit of time, instead of redrawing the other 2, I can use my copy tool. So copy, select the object, pressing enter, clicking the center point, and then placing at the end points of the polygon. Now finally, I just have to draw the larger outer polygon. So the information is here on the left. We have 3-sided polygon circumscribed about the circle. So I'll come back to my polygon. I have number of sides 3, enter, specify the center point. And this one is circumscribed about the circle. So when I come up 90 degrees, you'll notice that the orientation of the polygon is incorrect. So I need to go down. So I'll come down till I reach the point of intersection of the polygons and click. So now we have all of the information drawn. It just now requires us to trim to match the image. So we want to be left with all of the solid black lines, and we want the dashed red lines to be trimmed away. So I'll come to my trim tool. And what we can do is we can individually select the objects and then slowly work our way around our trim, or we can select all, enter, and then we can just work our way around, removing what is necessary. We then have the intersections. And enter to finish. Last remaining thing is the inner polygon, select, delete, and there we have our first practice exercise. So we'll now move on to practice exercise number 2 within the PDF. And with this practice exercise, what we will do is we're going to create this shape on the right hand side, but how we're going to achieve that, instead of drawing the entire shape, we're going to draw 1/4 of the shape, and then once we've done that, we'll utilize the rotate command. If you think you can master the polar array for this one, you can also use that. Okay, so I want you to now pause the video and attempt this one yourself. So with this particular one, you'll notice we only have 3 pieces of information. Everything else we have to work out ourselves. We'll first place all the bits of information which we have on the screen. So we have 3 circles, 200, 600, and 700. So I'll move over to the right hand side, select my circle. First one is 200, next one 600, and then again 700. What we will now do is we'll focus on this center section. We have the dashed red circle here, which we have at radius 200. And to the outer face of that, you'll notice we have a polygon, which is circumscribed about the circle. So it's on the outer side of the circle. And with that, the amount of sides is 8. So we know the number of sides, we know the center point, and we know the radius. So we have all the information we need to create the outer polygon. So I'll zoom in on the inner circle. So we'll select our polygon, change our number of sides to 8. We know the center point, and we know that it is circumscribed about the circle. So we can either attach to the edge of the circle, or we can manually type in the radius of 200. And there we have the intersection. Next, we have this circle on the top line of the polygon. So the endpoints of the diameter of that circle are sitting on the endpoints of the polygon. So we'll come over to our circle. We will change it to a 2-point circle. And we'll select each endpoint of the polygon. There's absolutely nothing wrong with also selecting the center radius and using the midpoint. So both are correct. Now that we have the inner circle, the polygon, and this smaller top circle drawn, we'll then move on to the next section. So what we'll do is we'll draw these 2 lines, which are intersecting the endpoints of that inner polygon. So we have 1 line and 2. So we'll grab our line tool, attach to the endpoint, draw straight up, and same for the right hand side. And next we have this section here. So what you may or may not have noticed is this looks and is a polygon. So this polygon here matches the dimensions of this polygon here. The reason I know this is because a polygon has equal sides. And this line here, they both share the same distance. So we know that this polygon matches this polygon. So what we can do now is we can either use our copy tool. So we can select copy, select the polygon, pick up our endpoint, and place. We can also use the mirror command. So select mirror, select the polygon, and this is our mirror line. Both options are correct. And from this point, we'll then just tidy up and begin to create our image, which we will then mirror across. So first I'm going to work on trimming up and tidying up this area. So we'll select our trim tool. We'll select the outer line, this line here, and the lower line. Enter to confirm, and we can then remove these sections. Enter. And next I want to open up this section here. So again, I'll select trim, select the polygon and the section of the circle, enter, and then trim away. Enter. Next we want to work on this section here. What we're looking to have remaining is the thicker black line. So that's all that we want to be left remaining, so we can then mirror it across. So for that, we just need to trim up this circle here. So we need to trim away the top section of that circle, like so. And then from that point, we can delete the circle and delete the polygon. Last bit there is to trim away this section here. So use our trim tool, enter, and remove. We now just have the remaining quadrant left of our final product. Okay, so at this point we have two options which we can use to create the final image. We can either use the polar array, and we can also use the rotate command. So I'll use the rotate tool first. So I'll select rotate. I'll select our object, enter to confirm. Our base point is the center point of the circle. It's not there, so we'll hover over the edge of the circle, come back into the center point. So now if we simply rotate, we're just going to rotate the item, which we don't want. What we want to do is create a copy at the same time. So we'll rotate, select the object, enter to confirm, hover over the edge of the outer circle, come into the center, come down to the command line, click copy, and we'll then click up 90 degrees to copy it around. We'll then do the same and copy and place. So that's one method. I'm just going to undo to bring it back to my original. And next I'll use the polar array. So I'll select polar array, select the object, enter to confirm, and I'm now looking for the center point. So I'll hover over the edge of the circle, come into the center point, click. So it's a bit of a mess right now, and the reason for that is the default items list is set to 6, so we'll revert that back to 4. And we want that to be joined together as one object, so we'll turn associative on, and we'll then close the array. So there we have our final image, practice exercise number 2. Okay, so we're going to move on to practice exercise number 3 before we move on to the next module. So if you want to now pause the video and have a go at this yourself. Again, just like before, I'll start off with what information I know, just get it onto the screen. And what we'll do first is we'll draw these 3 circles. We've got 650, 560, and 380. Zoom in, give myself some space. So I'm going to draw a circle using hotkey command C for circle. Click to start from my center point. Radius is 380. Enter to turn the circle back on. Hover over the circle for the center point. Click on the center point. Next circle is 560. Enter to re-engage the circle command. Hover over the edge. Come back into the center for my center point. And 650. Next I have a 3-sided polygon. It's inscribed, so we'll do that next. Go for our polygon, 3 sides, specify our center point, inscribed, and it's going to the outer circle. Now we have all our 3 circles and the polygon. We can now crack on with the top section here. So we have the smaller circle, radius 100, the outer 250. And once we have that drawn, we know the other center point, so we can just copy those 2 circles to the other points. So copy is CP, enter. Use my center point as my base point. So the last bit of drawing we need to do is the fillet, but before I do that, I just want to tidy up the drawing so we have a clear space. So I'll delete the outer red circle and the polygon. So the outer red circle is gone and the polygon is gone. So finally we'll just do our fillet, radius 150. So fillet is F. And we need to change our radius. So we can either come down to the command line, click radius, or type R for radius. Enter 150 as our radius. And M for multiple. We'll then select the outer side of the circles. And finally, we just need to trim to complete the image. So we'll go to our trim tool, TR for trim. And we need to select our object. So we don't want to select everything. What we want to do is select the outer circles, our fillet. So just the outer circles and the fillet. There we go, press enter to confirm that. And now we can work our way in and remove what's not needed. So again, by making the selection, we just save ourselves time by trimming away smaller pieces, which will slow down our draw time. And there we have practice exercise number 3. We're going to move on now to our next tool, which is our rectangle. So I'm going to move over to some clear space. And the rectangle is located below the polygon. So top right hand corner of the draw panel, we have our rectangle. So with the rectangle, we can do a quick placement. So we can click once for our start point, click again for our second point, which creates our rectangle. So when we do that, we are not specifying a particular length or width of the rectangle. If this is what you intended on doing, that is the quickest way to create a rectangle. But being that it's AutoCAD, we want to be accurate. We want to accurately place the length, the width, and the rotation. There are different steps we need to take. So we'll select our rectangle and we'll first click our first point. And once it has been activated, we can look down at our command line and we have the first option, which is specify the corner point, which is what we've just done a few moments ago. But next we have dimensions. So we can either click on dimensions or click D, enter. And it's now looking for the length. So it's asking me to specify the length. So in a rectangle, the length is the longest side of the shape. And I'll type in 1000 for the length. And it's now asking for the width. So the width is the shortest side of the rectangle. For the example, I'll type in 800. And the remaining step to placing this rectangle is the orientation. Our first click of the mouse was our first point. If you imagine that as our center point, so if I go to the top right hand corner, our rectangle will be in that top right hand quadrant. If I go to the left of that, it'll go to the left hand quadrant, and if I go below the x-axis, we have bottom left, and over to the right, bottom right. So now we're just looking for the orientation of our rectangle. So I'll go top right, one click of the mouse will place the rectangle. So now we have an accurate placement of length and width. And we'll come back now to our rectangle tool, and I'll click again for my first point. So another way in which we can type in our length and our width is we can just use our dynamic input. So here if I type in my 1000 and hit the tab key, you'll see that my length, which runs along the x-axis, is locked in at 1000. It's now looking for my width, which runs up the y-axis. So type in 800 and enter. So there we have our rectangle drawn using the dynamic input. And we did that by first entering the x, or the length, which was 1000, hit the tab key, that will jump us over to the y, or width. So I'll now type in REC, enter, which is our hotkey for rectangle. I'll click from my start point. So if we wanted to add a rotation to this rectangle, so right now we are coming across the x-axis at 0 degrees, and our rectangle will start at 0 degrees. If we wanted to specify a particular angle of rotation for this rectangle, we'll do that now. So in the command line, we have rotation, or R. So we can type in R, enter, or click rotation. And starting off from the x-axis at 0 degrees, we can see here we can specify our angle. So once we move off that, we can enter in our angle. So just for the example, I'll type in 45. And there we'll see from our start point, our rectangle has begun at 45 degrees. So now we need to enter in our length and our width. So I'll type in 1000 for our length, hit the tab key, and 800 for our width. So now we've drawn our rectangle at an angle of 45 degrees. When I come back into my rectangle, it'll automatically jump back to 45 degrees. So if you wanted to begin drawing a rectangle at 0 degrees, you must come down to rotation and reverse it back to 0. We're also going to look at creating a rectangle using the area. So we'll go into our rectangle tool, REC, specify our first point, and we have area. So the first thing we're prompted is to enter the area of the rectangle. So what is our known area of the rectangle we want to create? So if you know the area and you also know either the length or the width, AutoCAD will then generate that for us. So for the example, I'm going to put my area as 1 million. Enter. AutoCAD also needs to know the length or the width. So if we choose the length, and we'll enter a length of 1000, enter. We've then created our rectangle with an area of 1 million and a length of 1 meter or 1000 units. Okay, so I'm going to move off to the right hand side and I'm going to just create a random rectangle and place a circle on the top. So just like we did for the polar array, we're going to do the same, but this time we're going to look at the rectangular array. So it's the same idea, but instead of being in a circular array, the item will array in a rectangular form. So the array is in the modify panel. If the polar array is at the top, just hit the drop down arrow and we'll select rectangular array. First thing to do then is to select the object, pressing enter. And there by default we'll get 4 columns and 3 rows. Same like before, very similar ribbon, very similar functions. We can change our columns as well as the rows. And we can change the distance between them, or we can change the total distance from first to last. Same with the rows, we can change the distance between first and second, or the total distance from first to last. Levels we'll skip over as we are sticking with 2D AutoCAD. And same again, we have the associative. So having that turned on means that when I close down the array and come back, it's still joined as one object. We can also change the base point as well. And you'll notice we have the same grips like we had before. So first one is our base point. Second, we can extend the distance between the rows, extend the distance between the columns, extend the total distance for the columns and the total distance for the rows. And the top right hand corner will do both. Which will add columns and add rows. And green tick to finish, or you can press the escape key on the keyboard. We'll also look at what is called the path array, which is the remaining array tool. So again, we'll draw a quick rectangle with a circle on top. And what we'll do is then draw a polyline, PL for polyline, attached to the bottom right hand corner, and we'll just draw a random path. Enter to finish. And what we'll do then is come to the modify panel. We have rectangular array at the forefront, so we'll hit the drop down arrow, choose path array. We'll select our object, enter to confirm, select our path, which is the polyline, and click with the mouse. And there we'll see our item, which has been arrayed along that path. So with the path array, there's some slight differences. You don't have control over the number of items. What you do have control over is the distance between them. You can change the rows and you can change the distance between them and the total distance. So if you wanted less items, you would increase the distance between the items. And if you wanted more, you would decrease the distance between the items. No differences with the rows, and again we'll skip off levels, and there we have associative. So within the property section we can align the items to the path. You can see that when the angle of the line changes, the item changes, so we can change that and have the position or the orientation of the object the same throughout. So a good example of where to use the path array would be, say, a garden path where you'd have a slab and you wanted to create a nice path. You draw one, use the path array to continue around in that direction. As well, I had one good example where we used it for the conveyor belt at an airport. Okay, so just press escape to come out of that. We're now going to look at how to draw a spline fit and a CV curve. So two different types of curves, which we can then apply our path array to that as well. So in the draw panel, we have the drop down menu, and it's our first two there. A spline is a curved line. And we have two ways in which we can use them. So first with the spline fit, we'll just specify the points on the curve, and then it will be generated for us, and enter to finish. Next with the spline CV, the spline CV will draw a spline with control vertices. So we have control over changing the curve, and the spline fit will draw with fit points. So there are fit points which we can pick up and drag. And we have our vertices. So combining this spline with the path array, I'll use my spline fit just to draw a nice easy curve. And using my rectangle, attaching to the start position of the spline. And again, just drawing a rectangle with a circle on top. And now going back to my array tool, selecting path array, selecting my rectangle and circle as my object, enter, and then my spline as my path. So within the ribbon, again, we have all the same options we had with the rectangular and polar array. So first we have our type, which is the path, and our items is locked in at 11. So here again, we change our distance between them to change the amount. We can change the number of rows. Level is for 3D. We understand what the associative is. And we can also align the items. Okay, so exit this. And if you wish, you can do a small bit of tidying up if you don't want to have these examples on your screen. So I'm going to remove those arrays off the screen. And same with the rectangles. And we'll move on to our next practical. So in practical number 9, what I want you to do is we're going to use the rectangle command. We're going to use the fillet command. We're going to draw one circle. And what I'd like you to do is use the rectangular array to draw these circles. And at this point, if you'd like to pause the video, have a go at this yourself. And then once you've completed, we can work on it together. Okay, so first thing I'm going to do is draw the larger outer rectangle, which is starting with the x-axis, we have 700 by 800. So in my drawing, I'll come down to the right of our last practical, REC for rectangle, click for our start point. So first thing we'll do is enter in our x, which was 700, tab, 800, enter. And there is the first outer rectangle. So we'll come back in, and the inner rectangle is an offset inwards of 50 mil. So instead of trying to draw the rectangle inside and placing it, all we'll do is we'll just offset the outer rectangle inward. So go to the offset command, or we can type in O and enter. Specify our distance, which is 50 mil, enter, select the object, and then move inside the object, enter. Next, I'm going to place my circle. And to place my circle, we have our start point here. Coming across the x-axis, we have 175, and up the y, 160. So what I'll do is I have two options. We can either draw a line, start point,
Then using the relative coordinate option, we can type 175, comma, 160. And there's our start position for our circle. Or we can draw our first circle down the bottom left-hand corner. So our radius is 25, enter. And then I can use my move command. I can type M, enter for move, or use the move tool from the modify panel. Select my object, enter to confirm. Specify our base point. So our base point is the bottom left-hand corner of the rectangle. And we know we want to move across the x-axis by 175, comma, up the y-axis by 160, enter. So there's our first position for the circle, where we had two different ways in which we could place that circle. And there's many different ways in which you can do the same task in AutoCAD. There's no right or wrong. Whatever is the most comfortable way for you to carry out that task, just stick with that way. So next, instead of copying this circle to create the intersection, we'll use the rectangular array. So we'll come back to our array tool, hit the drop down arrow, select rectangular. First thing we'll do is select the object, enter to confirm. And there we have our default 4 columns, 3 rows. In the PDF, we have 3 columns and 4 rows. So we'll change that to 3 columns, 4 rows. Next, we'll change the spacing between the columns. So the spacing between the columns in the PDF is 175. So we'll change it to 175, enter. And the distance between our rows is 160, enter. And now we've finished with our array, so just enter to finish. And the last thing to do is to just fillet the edge here. So we have a radius of 60. Come to our fillet command, or F in the command line. So the command line is asking us to select the object, but we know with our fillet command, we first must come down and specify the radius. So the radius you can see here is set to 150 from our last time we used the fillet command. So first thing we want to do is click on radius, change to 60, enter. So we have 2 options at this point. We can either select the multiple option and do each 4 corners, all in the one action, or we can just click on polyline, which will do all 4 corners at once. The reason we can use the polyline feature is because a rectangle is a polyline. All those line segments are joined. They are not singular segments. So we'll select polyline. We'll come in and hover over the rectangle. You'll see all 4 corners are done at once. Click, and we've completed practical number 9. So we'll move over to the right of our last practical, and we'll now look at a new tool, which is called the chamfer tool. So underneath the fillets tool, we have our chamfer. With our fillet tool, what we're doing is we're creating a nice curve between 2 objects, and what we'll do with the chamfer tool is we'll create a straight edge. So if we open up the PDF, and in the PDF, I just demonstrate how we can create that chamfer. So what we're trying to create is the third image here. This is our chamfer. So we have a straight edge between the 2 lines. And there are certain steps when we are creating our chamfer tool. So the reason I've drawn it out like this within the PDF is just to give you a little guidance and memory of these steps. So the thing to remember is when we're creating our chamfer, we're asked to specify the line 1 distance and the line 2 distance. And what that is referring to is if you imagine the point where line 1 and 2 meet as 0. So as we can see within our chamfer, we have our first distance to the left is 200, and down we have it by 400 to create this line. So what we would do to achieve this, we would enter in line 1 as distance 200 and line 2 as our distance 400. Referring back to AutoCAD, I want you to we'll draw the top line there at 1000 and the lower line again as 1000. And then we'll just center it on our screen. And once we've done that, we'll then come to our chamfer tool. Again, if it is not being displayed in your modify panel, hit the drop down arrow and select chamfer. So once we enter the chamfer tool, again, just like the fillet command, it's jumping ahead a step and it's asking to select the first line. But we don't want to do that. What we want to do is first enter in the distances. If we come down to the command line, you'll see that our first chamfer distance is 0 and our second distance is 0. So if we were to just jump ahead and continue, no changes would take effect. So what we need to do is to change those distances. And to do that, we'll come to the command line and select distance. So it's now asking for our first distance, and referring back to the PDF, what we'll do is we'll take the top line as line 1, so our distance is 200, and the lower line as line 2 with our distance of 400. So again, we're referring back to this point as 0, 0. So enter our first line distance as 200. The command line is then asking for the second distance. We'll enter 400 and enter. So now we've added in our first line and second line distances. We now just have to select which line we want as line 1 and which line we want as line 2. So there's our first line, the top line, and it's now asking for the second line, which is the lower line. I'm getting a preview of what actions will take place. So just hover over once it becomes blue, click, and we have created our first chamfer. So what I'll do is just undo that and bring back our original shape, and we'll do it again. And select distance. I'll enter in 200 for my first line, 400 for my second. But this time I'm going to reverse them. So my first line was 200, my second line was 400. But instead of selecting the top line and second line, I'm going to reverse them. So I'm going to select the bottom line, which is now 200, and the top line, which is 400. So you can see what is important to remember which was your first line distance and which was your second line distance, as what we were trying to achieve is shown here in the PDF. So with the chamfer command, you can see at the bottom we have similar options which we have with the fillet command. So we're able to undo our last option. If there is a polyline, we can select polyline and it will do all at the same time. We now know that selecting the distance, and we are familiar with the trim tool. So when we did the fillet, when we created the curve between the two lines, the excess pieces were trimmed away. If we choose trim and we want no trim, those lines will remain. So currently trim is active, so we'll keep that active. And if you know you're going to be chamfering multiple times, we would then select the multiple option. And again, we can draw our 1000 line by 1000. And then we'll come back to our chamfer. This time we'll select angle. And it's asking for chamfer length on the first line. So what we're referring to again is our point 0. What distance do we want on the line? So we have 200, so we'll continue on with 200. Enter. Now the difference with the angle is we don't specify the distance for the second line. What we do is we specify the angle of the line. So for our example, we'll use 45 degrees. Press enter. Now we're being asked to specify that first line. So either the first line will be the top or the bottom. So we'll stick with the top line. So again, our first line distance what we entered was 200. So imagine that's our 0. So we're coming across by 200. And now we just have to select our second line and click. So there you can see where the two lines met. It's come across by 200 units, and then it's drawn a line here at an angle of 45 degrees. So it's just a nice quick way to be able to draw angled lines between two lines of intersection. We can also then change the method. So by default, the chamfer will always be distance, which is what we did in the first example. And then in the second example, we chose by angle. If we know that we're always going to be chamfering an edge using the angle, we can change the method to angle. So the default will always be angle. But if you know that you're always going to be doing chamfers by distance, you'll select distance as your main method. So again, that just means that when you open the chamfer tool, either distance will be first or angle will be first. So now open up the PDF again and we'll move on to practical number 10. So again, if you think that you can continue on ahead, just pause the video and have a go yourself. And after you've made an attempt, I will then create the practical with you. So pause the video now. First part we're going to do is draw our 800 and 1650 line. So choose my line tool, L for line. We have 800, 1650. And then come down 600 on the other side. Once we've done that, I'm going to offset the left-hand line inward by 560, the right-hand line inward by 400, and the top line inward by 480. So over offset, first distance is 560, enter, select it inward, enter to complete, enter to reactivate the command, distance 400, select the line, come inwards, enter to finish, enter to reactivate, 480 is the next distance. So now we have the outer lines drawn. What we can now do is move on to drawing the circles. So I'm going to do the bottom left hand corner first. So I'm going to use my 2-point circle. Come to my circle 2-point because I know the endpoints of the diameter. I can then use my center radius because I now have a center point here. Radius 200. Center point, radius 200. And over to the right, we'll do the same 2-point circle, and then we have our center point, 125 for the radius. So 2-point circle. Come back, change to center radius. The radius is 125. So then I'll just tidy up the outer bottom section here. So I can use my trim tool, TR for trim. Select the two outer lines and the circle, enter to continue, and trim the piece. Same for the right hand side. And trim. And the section here too. So we'll trim this. Now what I'll do is draw the intersections here. So we'll draw one side and then mirror to the right hand side because it is the same dimensions. So I got my starting point in the top left hand corner and I need to find the starting point of my rectangle. If we imagine this is a rectangle with no filleted edges. So the start point is across X by 150 and down by 80. So I'll select my line tool, click for my start point. So I got 150, -80, enter. That's my start point for my rectangle. So my rectangle is 580 by 250. So REC for rectangle, enter. There's my start point. So if I move down below the x-axis, I can then enter in 580 on the x and negative 250 on the y. I can delete the little line and come back to my PDF. We now want to create these chamfered edges. Now we need to decide which is our line 1 and which is our line 2. So if we come back to this corner as it looks similar to what we've just drawn, and imagine our point 0. So our first line point will be 70 and our second line point will be 50. So we'll go to chamfer, come down to distance, and our first distance will be 70 and our second distance will be 50. And we'll do it multiple times. And so we'll come to line 1, line 2, and line 1, line 2, line 1, line 2, line 1, line 2, and enter to finish. And next we'll use our mirror command, which is MI. Select the object, use the midpoint, draw our mirror line straight down to 270 degrees, click, and we'll select no. And then lastly, we'll just fill it. So we have radius 120, radius 120, 150, and 50. So come to our chamfer tool, drop down arrow, change to fillet. First thing we'll do is change our radius to 120. Here's our two lines. And same on the other side. And this corner here, our radius is 150. And 50. And that is practical number 10.
Okay, so we're going to move on to the next drawing tool, which is the ellipse. So I'm going to move over to a nice clear space. And below the rectangle tool, we have the ellipse. So drop down arrow reveals 3 different ways which we can draw the ellipse. So we have our center, axis end, or elliptical arc. So we'll first use the center ellipse. So again, just referring to the command line will be our steps for this. We have 3 in total. So first is our center point, 1 click of the mouse. Next is looking for the end point of the axis. So for the example, I want you to come out to the right hand side at 0 degrees. So we'll do the x-axis first and click. And we begin to see the shape of the ellipse. The third step will be the y-axis point. So moving my cursor up 90 degrees, we'll just click again to create our ellipse. So when using the center ellipse method, first we do the center point. We'll then do an end point of the first axis. I just chose the x-axis now as it's easier to show you. And then the third point is the end point of the second axis. I just stuck to the y-axis again just to keep it simple. So we'll go over the center ellipse again. So click for our center point. And now at this point, when I'm moving my cursor out to the right hand side, I'm able to enter in a distance. You'll see the dynamic input there is expecting a distance. So if I type in a distance of 200, I'll get a total end-to-end distance of 400. So that's one thing just to keep in mind. Because our start point is the center point, we're essentially giving a radius to that ellipse. So from the center point to the end point was 200, so the total distance end point to end point is 400. And then same again when we're asked to specify the third point.
When we specify, it'll be the center to end point, so our total distance will be double that. So if I enter 100, our distance from one end to the other is a total of 200. So with the center radius, we can also draw these at an angle. So I'll start one click for our center point, and then at this point we'll then add in our angle. So we can either use just the dynamic input and snapping on the 45 degrees, or we can use the polar tracking method by first entering in our distance of 300, hitting the tab key to then specify the angle. So I'll type in 30, enter. So there's our center point. Our distance from the center to the end point was 300, so the total distance is 600. And our axis has changed. We've changed our axis angle to 30. So the third step remains the same. We're just going from the center point to the end point. I'll type in a distance of 150. So total distance is 300. So there's our center point, first end point, second end point. Okay, so just pull over to the right hand side. And what we'll do is look at the next one, which is axis end. So with the axis end, what we're doing is we are now specifying, instead of the center point, our first point is now the end of the axis. So this is now point 1, point 2, and point 3. So click for our start point. We'll move in the direction which we want to specify our second endpoint. We can then enter in our distance. So now our distance is a total from end to end. So my total for this example, I'll type in 500. And now my cursor jumps to the center point. And for our third point, which is our center point to end point, we'll enter in 150. So the total distance is 300. So the first step is from point 1 to point 2, and for point 3 is referring back to the center point to give this distance. Of course, we can add in an angle, so we'll specify our first point, and then we can add in our distance, tab key, and there we can add in our angle. For the example, I'll type in 15, and for our third point, 100. So there we have our first endpoint, second endpoint at an angle now of 15 degrees, and then our final third point. So there we have the basics of how to draw the ellipse. The remaining one is called an elliptical arc. So what an elliptical arc will do is we're drawing an ellipse again, but what we're doing is we're only drawing a portion of the ellipse. An example of why we would use that is if we wanted only a portion of this ellipse to be drawn, but instead of drawing it and then, for example, drawing our lines to then trim away the centerpiece, to be left with this elliptical arc. So to save us all of that hassle of having to draw the lines and trim it away, we can go straight to the elliptical arc and we can use that feature. So first thing you do is you just draw a normal ellipse, and to draw the ellipse you draw it in an axis end format. So we'll click on our first endpoint, we'll then click on our second endpoint. I'll give a distance of 500 for this one, enter. So we have our total end to end is 500, and the cursor jumps to the center for the third point. So I'll add in 100 for our third point. And now, what we're now asked to do is to specify the start point of our elliptical arc. So to match what I have drawn on the left, my start point will be roughly here. So click, and you'll see my elliptical arc will follow the cursor line, and click. So to do that one more time, select my elliptical arc, endpoint. For the example, I'll just give a distance of 500. For my third endpoint, my distance will be 100. And then I'll click for my start point for the elliptical arc, follows the cursor around, and click to complete. So before we move on to the practical, you can either leave these ellipses here, or we can just select remove, come down to the space, and refer to the PDF for practical number 11. So we'll now move on to something a little bit more advanced, but there's nothing here that you haven't done before. It's just putting all of the new features that you've learned into practice. So if you feel confident enough, you can tackle this by yourself now. So just pause the video and continue with the practical. What I'll do first is draw the three circles, radius 80, 110, and 175. So we got my circle, 80, 110, and 175. Once I've drawn that, I will then draw these three lines here. No particular distance. The end goal is to just have this small section remain. So I'm going to draw one line out to meet the middle circle, and then we'll pitch off the second and third line off at 15 degrees. So go to my line tool, go to the center point, and just draw straight across, attaching to that middle circle. So what I can do now is I can select my line tool, just extend past that circle, hit the tab key, change it to 15 degrees, and then trim away. Or I can come down to the angle increments, change it to 15 degrees, select my line, go to the center point, and once I lock in at 15 degrees and the middle circle, click, and do the same for the bottom. I no longer need the line at 0 degrees. And what I'll do to save myself time redrawing those lines at 90, 180, and 270, I'm going to use my polar array. So select polar array, select my object, enter, specify my center point. We'll then come up, change our item list to 4. And I want the lines to be singular, unjoined, so I'll need to turn associative off. Now that I've completed, I'll just come and close the array. And in the drawing, we'll see all of our lines are singular. If you've not done that, just export the object out to be singular line segments. Now referring to the PDF, all we have to do is just trim away to match the image. So select my trim tool, I'll select everything and enter. And a quick way to do a trim, instead of doing individual lines, I can use my green crossing window and do everything at once. I can then do these small intersections and enter to finish. So now we have this section done and this outer circle done. We'll now move on to this point here. So we'll draw a line using our relative coordinate to find this point. So our x is 225 and our y is 175. So we'll select line, find my center point. So we've got 225, comma, negative 175, enter. And the reason it's a negative 175 is because I'm going below the x-axis, the y becomes a negative. So now that we have this endpoint, we have the center for our circle, so radius 37 and radius 75. Select our circle, radius 37 and radius 75. Enter. We can then delete our, what we'll call a construction line, and I'll come back to my PDF. So now that we have this point, we're now going to come across to the right-hand side by 925 to find the next center point of each of those circles. So we have a radius 25 and radius 50. So we'll draw our line over by 925. And we'll then draw our two circles, one radius 25 and the other radius 50. And I'll delete my construction line. Next thing to tackle will be the ellipse. We can use all three ways to draw this ellipse. So I'll show you all three ways and you can decide which you find the quickest. So first thing I'll do is, using the quadrant of the circle, I'll draw a line connecting the two. What that does is it gives me a midpoint or center point of that line, which will allow me to use the center ellipse. So there's my center point. So now that I have the center point of my ellipse, my x is from this end point to this end point. And as I'm going from the center point of the ellipse, it reduces down to 400. And the y from the top to the bottom is a total of 300. So from the center point is 150. So I'll come across by 400, or I can just attach to the edge of the circle, one click, and then I'll move up 90 degrees on my y-axis. So the total from top to bottom is 300, and as we're going from the center point, it is now 150. Enter. So that's one way we can draw that. I'll select everything and delete it. We can also use our axis end. So we know our endpoints of the circle from one to the next. Just an easier way that we can connect to the quadrant of the circle is we'll come down to our snap tool. We'll turn quadrant on. And then when we come back to draw our axis end, when we hover over the quadrant of that circle, we'll get the small diamond shape. So we know we're accurate on our selection. So now we have our x drawn, which was this point to here. We now just need our y. So again, it was 300 from top to bottom, and as we're at the center point, it's a total of 150. And again, there's our ellipse. We just have to trim away the bottom. And I'll delete. And I'll show you the last, which was the elliptical arc. So again, we'll draw it by axis end to axis end, and then up by 150. Now we just need to select the start of our ellipse. So we'll come up to the right hand side, click to start, and you'll see we'll follow the cursor around and click to place. So all three methods are correct. It just depends on which you feel more comfortable at the method and also the pace. If you have a good grasp of using the elliptical arc, that would be the fastest way of drawing this ellipse. So now we have this curve drawn. What we're now going to do is the next curve, which is part of the ellipse. So you can see this ellipse we've called a half ellipse because we are just showing only a half of the ellipse. You can imagine the other half being below. And this ellipse here we're calling a quarter ellipse because we're at one end point of the ellipse, which is on the x-axis, coming around to the top on the y-axis. So we're only showing a quarter of the ellipse. So we need to be mindful of that when creating this and using the x and y when determining our distances from the x and y. So I'll do all three methods again. So the first one is the center ellipse. So the center of my ellipse will be around here. To find the center point, what I need to do is add a snapping reference to the top quadrant of that circle and the right quadrant of this circle. And when I come back to the center point, we'll see the two will line up. And it's showing me that it's the bottom quadrant of this circle here. So one click of the mouse will enter my center point. Now our x value is 2,400 from end to end, and as we're at the center point, it'll be 1,200. So we can either enter 1,200, but we also know that it will snap to the end point of the smaller circle. So we're snapping to the quadrant of the right-hand circle. So we now just need to complete it with the third point, which is the top of the circle here. So one click of the mouse. We've then added in this quarter ellipse, which we will then use our trim tool to then trim away the excess. Okay, so we'll also use the axis end. So for this one, we will start over on the right hand side, attaching to the right hand quadrant. So that's our first point. And we know that X's total distance is 2,400. So we'll move the cursor in the direction we want to go, enter 2,400. And we just finally have to attach for our third point, which is the top of that circle. And again, we'll use our trim tool to trim away the excess. And lastly, we'll use the elliptical arc. So we'll draw again the same axis end ellipse. And we'll then start our elliptical arc over on the right hand side, dragging our cursor across to the top of that circle to finish off. So again, it's up to you which way you feel more comfortable tackling the ellipse. Finally, we just have to do the filleting here, which is on the left hand side with a radius of 150, and then trimming up to match the image. So go to our fillet command, R for radius, radius is 150, and select the two circles. And then lastly, we'll just trim. And enter to finish. And that's practical number 11. So in the course, we've covered the majority of the drawing and modification tools. And what we'll do now for the next couple of tasks will be just simply doing some practice exercises to try and enhance our drawing speed and drawing ability. And then once we've completed those practical exercises, we'll then move on to different features within AutoCAD. So I'm going to move over to a clear space in the drawing, refer to the PDF, and we'll go to practice exercise number 4. And like we've been doing before, if you feel confident enough, you can now pause the video, and I want you to attempt this yourself. Okay, so for this example, what I'm going to do, as it's quite difficult with certain angles, we're going to make it easier on ourselves, and we're going to draw one of these fingers at 0 degrees, and we'll draw it here on this 700 line. And then once we've done that, we're going to utilize the polar array tool to array the fingers around at equal angles. And then we'll work on from there. So first thing we'll do is we'll draw this finger along this 700 line. So we'll get started. So coming back to the drawing, first thing I'll do is draw a 700 line. And then we also have a couple of circles starting from the end point of the line, which is the center point of our object. First circle is 305. Second circle is 385. So we have these two circles drawn. We'll then move on to the finger. So with the dashed red circle, you'll see where the dashed red circle intersects that line, which we can imagine is also this line. We have our two circles at 32.5 and 80, and same on this side. So the end point of the 700 line is the same here, so that's where we'll draw our circles. So using our circle command, first radius is 32.5, second radius is 80, and I'll use my copy command, as they're the same, to copy them out to the end of this 700 line. Now that I have the circles drawn, I'm just going to connect them by quadrants, just with a line, top and bottom. And now that we have the first finger drawn, we're now going to use our polar array tool. So the number of fingers we have here are 1, 2, 3, 4, 5. So we mustn't forget the finger which we've drawn at 0 degrees, so we'll include that, as well as the finger which we'll need on the opposite side.
So that is a total of 7 items. So go to our polar array, we'll select our object, enter to confirm, specify our center point, change the number of items to 7, and we'll also change our total fill from 360 to 180. I want these items to be singular, so I'll have associative turned off. I want to make no further changes within the array, so I'll close down the array. So now we have fingers on the 700 line here, as well as the fingers we want to keep. So now we'll do just some tidying up to progress with the drawing. Okay, so to tidy it up, what we'll do is remove the 700 line. We will remove the dashed red line, and not forgetting, we'll remove our initial fingers at 0 degrees and 180. And from here we can progress by trimming off this section of the circle, TR for trim. And then we'll refer back to our PDF. So next we need to add in this fillet between the fingers. So that's F for fillet. Our radius is 45. And select the lines. We'll also select M for multiple to do it multiple times. And enter to finish. We can then remove these 3 outer circles. And then we just need to trim to remove these sections of those circles. And enter to finish. That is our practice exercise number 4. So moving on to practice exercise number 5 in the PDF, we'll move over to some clear space. The main objective here is to draw 1/4 of the image, and then use the mirror tool to mirror from the right to the left and then down to the bottom. So again, I'd like you to pause the video and to attempt this yourself. And then of course afterwards we'll work on this together. Okay, so what I'm going to do first is draw in these 2 lines at 170 and 205 to get our center points for the circles. So draw a line 170, then 205. And our next line up is 175. Now we have the center points for each of the circles. So we got 135, 200, 38, 100, 38, 100. 38, 100. And I'm going to copy this one down to save myself some time. And the next one is 135 and 200. So next what I need to do is to select both of the lines and extend them past the circles. Reason being so we can utilize that line so we can trim. First thing I want to do is to add in the fillets. So here we got 2 fillets at radius 50. So F for fillet, R for radius 50. And the same again. And now at this point we'll use our trimming tool to trim everything on the opposite sides of the lines. Like so. Then we'll finally just tidy up the upper section and the lower section. And then to complete the image we'll use our mirror tool, so MI for mirror. So first I'll go to the left, and then second drop below the line, and then delete our construction lines. And that is practical exercise number 5. Okay, so we'll move on to practice exercise number 6. So again, I'd like you to pause the video and try this yourself first, and then afterwards we'll work on it together. Okay, so first thing I'm going to do is draw this line which cuts through our image. Draw a nice big line. Next, we're going to use these construction lines here, offset across 300, 330, 170. And those intersection points will be the center points of our circles and the outer circles here. So I'll draw my first line, no particular distance. And then offset across by 300, 330, 170. And I'm also going to offset my center line up by 190. So then from here we can draw our circles. We have 35, 100, 100, 200, 25 and 60. First is 35, 100, 100 and 200. And then 25 and 60. We're now finished with this top line here, 190, because we've cut across this circle, so we no longer need it. I'm going to delete it out of our way. Next, referring back to the PDF, I'm now going to draw this ellipse. So our x is 520, our y is 220. So the x being 520, we're going to start off from the center point here, which is the center point for our ellipse. So from the center point to the end point will be half the 520, so it's 260. And same goes for the y from our center point to the end point, which is 110. So we'll go for center ellipse. There's our center point, come across to the right hand side. X is 260, y is 110. Once we have the ellipse drawn, we'll then draw this line. So come across the radius 60 circle, attach to the quadrant, and draw straight down until we intersect the ellipse. So we'll then come back to our PDF and refer to the fillet corners here, which have a radius of 25. So we're going to use our fillet command to create this nice curve between the circles. So F for fillet, R for radius, 25. And again the other side. And now at this point we can trim up to tidy that section. So TR for trim. Next we're going to connect the circles. So what I'm going to do first, and what I want you to do, is take note of how this circle curves around, and then the line continues on to attach and curves to the next circle. So if I use my line tool and simply just attach to the quadrants, you see I get the curve of the circle, a sharp point, and then the straight line. So this isn't the effect which we want to go for. We want to create that continued line. We need to attach that line by tangent. So we'll delete the line. What I need to do is come down to my object snap and just turn my tangent on. So now I'll come to my line tool. And when I hover over the circle, you notice that the tangent does not appear. So I'm not seeing the tangent snap appearing. The reason being is that the quadrants and endpoints and everything will overpower that tangent. So it's not going to appear. So what I need to do is select my line. And to get the tangent feature to appear, I hold down the Shift key, right click with my mouse. So holding down the Shift and right click will bring up an additional menu. So this additional menu is the Object Snap Quick menu. So the purpose of this menu is that if I was to select the tangent, only the tangent snap will then be active. So this will temporarily turn off all other snaps, and the tangent will be the only active snap. The purpose for this is so that
It just saves us going to the object snap, turning off all of the other snaps to then only have tangent active. Okay, so what I will do is we'll select tangent, come into the drawing, and you'll see now when I hover over the circle, the tangent appears. You'll also notice that no other object snap appears. So just one click of the mouse will attach to the circle. That action is only valid once. So to come over and do the second circle, we need to hit Shift right click, tangent again, and select the circle. We'll do the same for the other two. Select our line tool, Shift right click for the tangent, and Shift right click for tangent. And then at this point, all you need to do is to tidy up the drawing. First, we'll delete the vertical construction lines. I'm going to extend out the horizontal line so we can then utilize the trim feature to trim away anything below the line. Trim away this section here as well, and this section of the circle. So once you've reached that point, you can then use the mirror tool to mirror the image to the underside. Delete the horizontal line. And that is practice exercise number 6.
Okay, we'll move on to practice exercise number 7, which will be the last practice exercise of this stage of the course. And this practice exercise has been created to not only test the skills you have just learned with all of the different tools, but also how well you can do with working out the best possible way to create this exercise. If you'd like to now pause this video and attempt it yourself, and of course the follow-up video will be the solution. Okay, so how I'm going to tackle this exercise. The first thing I'm going to do is draw my dashed red line down the center. And I'm also going to draw this dashed red line through the larger circle. Just to give an estimate of the size of each line, we can come to the top and we have 110, 80, 80, 110. So with that total, what I'm going to do is draw this line around 500 millimeters. And for the vertical line, I'm going to draw it around 1000. So I'm first going to draw my vertical line at 1000 units. And my horizontal line at 500. And then using the midpoint of the line, I'm just going to drag it over and attach it to the vertical line. So now we have our vertical line and our horizontal line. What I'm going to do now is just build up the construction lines. So if we work with the horizontal line, my first offset line up will be 220, 52, 40, and 54. So using my offset tool, distance of 220, and next one is 52, next one is 40, and 54. Next I'm going to draw my vertical construction line. So from the center line off to the left hand side we have 80, 110, and same on the right hand side. Offset over by 80 and 110, and to the right side by 80 and 110. Now that we have our construction lines drawn in, we can start to build the project. So starting from the main center point here, we have 3 circles. We have 150, 180, and 190. Use my circle tool, find my center point. My first radius is 150. Next is 180. And 190. Next we have 6 circles with the radius of 17.5. So we know we have 6 circles which are equally spaced, but we don't know the angle at which they are set at. So what I'm going to do is draw my first 17.5 circle, and then I'll use my polar array to array it around that center point.
And the center point of the 17.5 is where the dashed red circle meets the vertical line. So we see there's our main construction line. I'm just going to grab the blue grip, drag it beyond the circle, and then here's my center point of the circle, radius of 17.5. And I go to my array tool and choose polar array. I'll select that circle, press enter, specify my center point. I want to array around that center point of the circle. And by default, we'll get 6 items, which is what we want to achieve. I'm going to leave associative off as I want to edit them in the future. So down the bottom here, we have an additional 3 circles, all using the same center point as the 17.5. So we have 25.5. So we'll add those in. My circle, find the center point of that circle, 25.5. So now we have all of our circles drawn on the lower half. I'm going to now move up to the top half of this exercise. And to save time, what I'm going to do is only draw the left-hand side and then mirror across to the right-hand side just to quicken up the process. So what I'm going to do first is just add in these circles. Here I have 17.5. So that line meets here where we have our horizontal line up to 20, 52, and 40. So where the 40 and 52 line meet, where that intersects with the vertical line, that's where our 17.5 is. So that's going to be here. So draw my circle and 17.5. Next, coming across, we have our vertical line offset over by 80, and where that intersects with the 220, 52 line, we have our next circle. And the radius of that is 80. So here we have our 52, 220 line. There's the point of intersection. And the radius is 80. I'm then going to come over to the far left where we have 2 circles. Our radiuses are 17.5 and 40, which is over on the right hand side. It's noted there. So they intersect between the 52 and 40 line and all the way over in the 110 of the vertical. So there's our center point, which is here. So C for circle, 17.5 and 40. Now that we have all of our circles drawn in, we'll now move up to the top. So from the point where the vertical line meets the top of the 54 line, which is here, our total length is 100. So that 100 is our line here. So we'll draw that. And just so I can see that, and I know I no longer need this horizontal line, I'm just going to delete it. So now we can see there's our 100 line. So the end of the 100 line comes and meets this outer 40 radius circle. And we can see it doesn't attach to the top of the circle, but it comes and meets the tangent of the circle. So I'll draw my line. So if I go to the top of the circle, we can see it doesn't continue to curve around as it does in the exercise. So we need to attach that by tangent. And we do that by holding Shift right click, coming down, selecting our tangent and attaching to the circle. And we're now going to draw this line here. So again, it's attached to the tangent of that circle. And it attaches to the 25.5 radius circle, which is that outer circle. And where it attaches is where that 25.5 circle meets the larger 190 circle. So that outer circle, where those 2 circles intersect, is where we will attach our line, which is here. So we'll come back up to that radius 40 circle, and there's my tangent symbol appearing, so I can directly attach to that circle. So now that we have all of this drawn in, what I'm going to do is just tidy it up a little bit so we can see things more clearly. So a lot of the construction information we no longer need. So I'm going to select that inner dashed red circle and delete it. And we know the points of intersection of all the circles, so we can delete that information as well. And I'll do the right hand side as well. And we can also delete our vertical and horizontal line. So next what I'm going to do is I'm going to select everything we've just drawn and mirror it across to the right hand side. MI for mirror. And I'm going to select what we've just drawn. My mirror line will go from the end of this line, which was our point of the main vertical line. And enter. Next, what we have to do is just connect these circles with a fillet. And the radius of that fillet is 40. So we'll choose our fillet radius 40. And we'll do that multiple times. And we'll select our circles. And enter to complete. Lastly, what we need to do is just trim up to match the image. So TR for trim. And we'll just work around the drawing until it matches. So we'll fillet away those circles. For this larger 190 circle, all I want to remain are these sections here. So if I was to use my trim tool and select all, I'd have to go to each individual point, which is something I don't want to do. So again, just be mindful of your selection. So I'll select these two circles here and the 190 circle, and then I can trim it and the inner piece as well. And down at the bottom here as well. Next, I need to trim away these sections of the two 5.5 circles. So again, trim. I'm just going to select the objects which are required to be involved in the trim. And up the top half here, we need to delete this small circle and then just trim away to match the image. So we'll delete that and trim. And that's practice exercise number 7.
There's one very important palette which we're going to be using time and time again. As you're modeling, you'll always have this particular palette open, and it's called the Properties palette. To open the Properties palette, we'll go to the View tab at the top. And in the center here, we have a Palettes panel. And in here, there's various different palettes which we're going to be opening over the next couple of videos. But the one we're going to focus on now is the Properties palette. So one click of the mouse will open that up. So the Properties palette displays and lists the properties of a selected object. When more than one object is selected, only those properties common to all selected objects are displayed. When no object is selected, only the current settings and general properties are displayed, and there are several general properties common to all objects. All other object properties are specified to the type of object. To put all that into practice, what I'd like you to do first is save our current project, In the quick access, you can just click on the save command. And I then want you to open up the file which is attached to this drawing called properties palette. Okay, so once we have that open, first thing I'm going to show you is the palette itself. So here's our properties palette. So first we're going to talk about what a palette is. So the palette will display various different features and tools. So right now we're using the properties. We also have tools palette, blocks, sheet manager. And when we select any of these, it'll open up this object here, which is our palette. So the palette itself has certain features. Top left-hand corner, we can just shut it down, close it down. And I'll come back to my palettes and turn the properties back on. And just below that, we have our auto hide feature. So if we wanted to keep our properties palette open, but we didn't want the information to be displayed, as our drawing space is quite small, we can hide it. And when we hover over the bar, the information will reappear. When we move away from the bar, it'll auto hide for us. So we can turn auto hide off to just keep information on the screen for now. Then below that is the properties of this palette. We can move it, we can change the size, we can close it, we can anchor it to the left, anchor it to the right. We can use our auto hide feature, or we can also make it transparent. So with the docking, what we can do is we can actually dock our palette just like we've done with our command line. And to do that, we'll click and hold on the bar on the left hand side. So this here's our properties bar. If we click that, we can move the palette around the screen. And to dock it, we'll move to the left hand side. We'll see that the palette expands, disappears, and gives us a preview of what it will be once it's docked. So just let go of the mouse and our properties palette has been docked. If you have a large enough screen, you can of course dock your properties palette and continue modeling. If you have quite a small screen, it's best just to keep the properties palette as a floating undocked palette. So you have the option to hide it or close it down quite easily. So to undock our palette, we'll come back up to the bar, which is now horizontal instead of vertical. We will click and hold, drag it back into the center of the screen. Once the image has been reduced in size, we'll let go of the mouse and the palette is now back and it's floating. We can dock our palette to the right hand side as well. So same method, pull over to the right hand side. Once it expands out, gives us that preview, just let go of the mouse. And again, just pull it back into the center of the screen to undock it. Now you'll notice that the properties bar is on the right hand side instead of the left. So to flip that and bring it back to the way it was, click and hold the bar, move it to the left hand side of the screen and pull it back and the bar has been flipped. Now I'm going to move my properties palette over to the left hand side. I'm not going to dock it. I can move it up to the top, and if I come to the bottom right hand corner, you see I have the expansion arrows, so I can expand my properties palette. I can also lengthen it and shorten it. Again, it's all personal preference. As you begin to use the palette, you will know yourself how big or small you want it to be, and if you prefer to be docked or not. There's no right or wrong, it's just however you find it more comfortable on the screen. So now that we've discussed about the palette, we're now going to talk about the information within that. So we're currently using our properties palette. So I'm just going to expand it down. And we have different headings. So when we have nothing selected, at the top we have no selection. And at the top here we have what is called the object type. So we currently have no selection. If I select the line, one click of the mouse, you'll see all the properties information changes. The object type at the top changes to display that it is a line which we have selected. And below that we have our general, 3D and geometry. So under general, the first thing we have is our color. So it's currently on a by layer color. Our layer is set to 0. Our line type is by layer. The information which is being displayed might not make sense right now, but this is something we're going to cover in an upcoming video. What will make more sense to you is we'll come down to the geometry section. We have our start X, start Y, which is the start point on the X axis and the start point on the Y axis. And then we have the end point on the x-axis and the end point on the y-axis. So it's giving us the accurate location of that line, where it starts, where it ends. We also have the delta x, which is displaying the length. We have our length, and we also have the angle, which is 0. So I'll press escape to come out of that, and you'll now see the properties palette refers to no selection in the object type and back to default figures. So next over, we will select our next line, which is a polyline. The information is different now. So at the top here at our object type, it's telling us that we have a polyline. Under general, it's basically the same. Our color is by layer, our layer is 0, our line type is by layer. And then below that, we have our geometry. So our geometry is slightly different from our line, as what we have selected is a polyline. So we have our vertex X, vertex Y, our start segment, our global width and elevation, our area and length. I'll go into more detail about this later on. So escape, and we'll now select our circle. And again, at the top, our object type is telling us that it's a circle. And there's our general information, and our geometry is specific to that circle now. So where it is located, we also have the radius, diameter, the circumference, and area. Then we have our ellipse. So we see ellipse at the top, and there's our general information again, and again our geometry about the ellipse. We can see how the properties palette adjusts to whatever we're selecting and relays that information for us. So we can have our radius, start angle, our major axis, minor axis, and the total area of that ellipse. And then I'm selecting the outer edge, which is our rectangle. And our rectangle is a polyline. And again, we have our geometry, which also includes our area and total length. And some further information, which we haven't covered yet, but again, it will be in an upcoming video. We have a piece of text. So I'll select my text. It tells us what type of text it is, which is an M text. And there's our general information and the text information. So the content of our text is displaying line. So the text is saying line. So there's our content. It's displaying what type of text style it is, and some other basic information like the height, the rotation, and also the geometry. So where it is placed in the drawing. And further over to the right, we have a hatch. So selecting the hatch, come up to the top, displays our hatch. And the information displayed is our pattern, our scaling, the location, and the area of the hatch. And then finally at the top, we have our dimension. So the top displays what type of dimension that is, our general information, the dimension style, and the specific information to that dimension. This again is something we'll cover in upcoming videos. Okay, so we're going to close this down, and my advice is not to save this, so you have the original file, and we'll come back to our project. Now that we have a good understanding of what the properties palette is, we're going to move on to what are called layers. So layers are the primary method for organizing the objects in a drawing by function or purpose. Layers can reduce the visual complexity of a drawing and improve display performance by hiding information that you don't need to see at that moment. You have the ability to change a layer's color, line type, line weight, and its visibility. Before you start drawing, it's great practice to first set out your layers before you start drawing, instead of drawing your project and then going back and setting everything to a layer. This is very bad practice. So the first thing you're going to do at a project is either create the necessary layers, or what you can do is you can create a drawing template with those layers already created that you know that you're going to use over and over. So this is the best possible practice for using AutoCAD. So in the Home tab, we have our Layers panel. And here we have some quick access tools for the layers. And what I want you to do first is open up the Layer Properties. And when we do, we get a similar palette like we have with our properties. And what I want you to do is to come up to the top left-hand corner, and then we'll expand it out so we get a better view of what we're covering. So this here is our layer properties palette. In the sidebar here, we have again our close, auto hide, and our settings. So that is referring to the palette. We have a series of sections to this manager. First, we have our filter section. What I want you to do at this point is just to reduce it down and collapse it to the left-hand side. We won't look at that at this point in the course. We will cover that later on in the course. And when you first open up the manager, the headings might be condensed like this. So what I want you to first do is just expand out the headings so we can see the name of each heading. Okay, so we're going to look over each of the headings. First one is the status. So your status heading will display whether the layer is currently active or not. With the green tick indicates that this layer with the name 0 is currently active. You will see as we create more layers, under the status there will be the layer symbol if it's not active, and then the green tick if it is active. Next we have our name column. So this is where we'll name our layers. Then to the right of that, this is where we now come into the control features for our layers. The first one is on. So we can have our layer turned on or off. So this will turn the layer on or off for the entire drawing. So once you turn a layer off, the layer disappears from the drawing. However, if you refresh the drawing, the layer will reappear. If you wanted to hide certain information from the drawing, you could switch that layer off. Another good example would be if you had a floor plan, and within that floor plan you had all of the furniture laid out within the plan. And again, if you wanted to show the client a more clearer drawing of that floor plan without the furniture, we can simply turn it off to get a better idea of that layout. And then next is to freeze a layer. When we turn a layer off, that information is still active in the drawing. So that means that AutoCAD is still utilizing that information. It still sees that information as being in the drawing, so we can quickly access it again if we refresh it. When we freeze a layer, the layer will turn off. AutoCAD will release it from its memory. So if you refresh a drawing after freezing a layer, that layer won't reappear. If you freeze a layer instead of turning it off, you'll see a boost in performance because the program no longer has to keep track of it. So this is a very useful command. Very helpful at, say, the end of a drawing project where there's quite a lot of information within it, and perhaps your computer can't handle all of the information within the drawing. You can freeze certain information, which will then release it from the AutoCAD memory. We can then boost the performance of that drawing. Next, we have lock. So when we lock a layer, this means that we cannot move it or alter it in any way. So that layer is locked in position. A good example of when we should lock a layer would be a grid line. So when we place our grid lines, we know that throughout the project's life cycle, they won't move, but just in case we accidentally move them, good practice is to lock your grid lines so they're in position and they'll never move.
We're now going to practice these three functions. So if you could please open up the file attached to this video, and the file is called layer functions. So once we have the drawing open, we just open up our layer properties. And what I'm going to do is demonstrate the on, freeze, and lock features. So everything that's been drawn here is set to the correct layer. So first one down, we have our doors. So if I click on the on symbol, which is our light bulb, you'll see the door disappears. So as we've just learned, all we've done is turned that layer off, but that information still remains
within the drawing. If we were to then freeze it, again the layer isn't displayed on the screen, and that information has been temporarily removed from the drawing, freeing up some memory on our computer so AutoCAD's performance can be boosted. So we can see we can turn off our external walls, freeze them. Same with our furniture, grid lines, the inner hatch, the internal wall, and our window. So next over we'll look at the lock. So what we're going to do is we're going to lock our grid line. So we'll come down to grid line, select lock, and I'll zoom in. We'll see that the grid line layer has actually grayed out. So I'll turn it back on. So I'll unlock it. You can see the difference in color. So once it's locked, I will select it. I can try to delete it. I can try to remove it. But as the grid line layer is locked, I cannot carry out any of those functions. As well, when you hover your cursor over the line, you see the small lock symbol. So we can unlock the grid line, and that goes for all other layers. So if we look at our furniture, we can lock that. Again, I can try to delete it or move it. So as it is locked, we're not able to carry out those functions. And I'm now going to close this drawing down, don't save it, and return back to the original drawing.
Next we have plot. So in AutoCAD they refer to printing as plotting. So the term printing and plotting can be used interchangeably for CAD. Historically, printers would generate text only, and plotters would generate vector graphics. As printers became more powerful and could generate high-quality raster images of vector data, the distinction largely disappeared. So what we're able to do with the layer is if there's certain information which we have drawn but we don't want to be plotted, we can actually turn that off. So this is quite useful if you're working on one project, but there could be 2 or 3 people working on the same project. What you could do is you could write down small notes for the other people who are working on the project, but you could turn them off so when the drawing is printed, they won't be visible.
For example, this note left here has been set on the hidden notes layer which I created. So the text is within the model itself, but when I go to actually print my sheet, you can see that the notes will not be displayed when printed. All of this will be covered in upcoming videos.
Another good use for turning it off would be creating certain construction lines to help you to generate a model. But again, they're there purely to help you to construct the model, but you don't want them to be printed. Next, we have the color. So we'll one click of the mouse where we have the white square, we'll bring up the color index. So we have 3 tabs. We have index color, we have true color, and color box. So in the index color, it's noted as AutoCAD color index, ACI. We can come down to the bottom here where we have the most common color index which you'll use within AutoCAD. And if for any reason you required further coloring, you can come up to the index at the top. So you'll notice when I hover over each color, we'll also get what is called the index color. So red is 1, yellow is 2, green is 3, cyan is 4, blue is 5, magenta is 6, and so on. Below that we have our grayscale. So we have a grayscale of 250, 251, 252. So within AutoCAD we can recall those colors. So if I wanted red, I can come down to my color box down below, type 1, and we'll see my color will change to red. Open back up the color index. We can also recall those colors by typing it in manually. So we can actually type in the word itself. So we can type in white, enter to bring it back to white. So open back up the color index. We can also come to our true color section And this is run by RGB, so red, green, and blue. So if there was a particular shade which you wanted to use, you can come to where you want it to be. So if I want it to be a particular gradient of green, I will come to the green area, can select it. And here we have full control over the hue, saturation, and luminance. We can also drag the luminance bar to change that. And on the right, we get the RGB numbers. So first one is red, second green, third blue. If we know the numbers for the RGB, we can also type them in. So an example, 100, 250, 225. Enter, and it will change my color. So we can see that color is slightly turquoise. This is just showing that you have the full range of being able to change the color. But typically you'll stick with your main index colors. And we also have color books, which is very useful. Within our color book, our drop-down menu, we have all various different standards for colors. We have our RAL colors and our Pantone. So if I come to my RAL Classic, and if I know my RAL number, I can select it and bring it into the drawing as well. So now I'll come back to the index color and we'll just ensure that we are on white. So our color is white. Press OK. Next we have our line type. Come below where we have continuous, and again one click of the mouse will open up our line type library. So the first box we have is called the loaded line types. So in here we would load in our most used line types. Reason being is there's quite a lot of different line types and we don't want them all to be loaded into the drawing at once because it can slow us down. So we'll just have our frequently used line types within this library. So to bring a new line type into the library, we will click on Load. And here we have the various different line types. So within your particular field of work, each one of these symbols will correlate back to something. So they're not all just random line types. So a quick example would be the batting, which is used for insulation. And below we also have some fence lines, gas lines. So what I will do now is just cancel this, come back to the loaded line types, and we'll cancel that as well. And we'll move on to the line weight. So just below we'll click on the default to open up the line weights. So it's currently on default. So the default line weight is 0.25. We also have all other different line types from 0 mil to 2.11. So the line weights are the thicknesses of the line, because if we were to draw everything with the same thickness, when we go to print it, it won't be very clear on our sheet of paper. So we want to specify the correct line weight for the particular detail or section so it becomes clear when we print it on our sheet of paper. Okay, so we'll cancel this one. Next we have a transparency and we'll click on the 0.
So our layer transparency when set to 0 means that it is non-transparent. And the highest value we can go to will be 90 because anything above that, the line will be completely invisible. So we're adding a transparency to that line. We'll cancel. Then we have new VP freeze. So VP stands for viewport. We will cover viewports later on in the course. To give you just a brief description of what the new VP freeze does, it will freeze selected layers only in the current layout viewport. Again, it's not going to make much sense to you right now, but when we progress into the viewports, this will become clear. And at the end, we have a description. So we can add in a little description about our layer. So for example, if you had a particular line that you wanted to use for something specific, you can add a description about that layer. This is helpful for you, but also if there's other people using the same model, they can understand what that layer is for. Now with the layers, it is very important to always have our layer 0 as the default setting. The reason we always want to have one layer at all default settings is because when we go to create a new layer, we can use the default layer as the one to copy to create new. So just above here we have our layer symbol, which is 3 sheets of paper stacked on top of each other. And the first one there is new layer. So there's a little yellow sun symbol. We'll use this icon to create a new layer. Next to that is new layer viewport frozen in all viewports. So when we create a new layer, that will immediately be frozen in all viewports. Again, that will make more sense as we progress to the viewport section. Next is to delete the layer. So to delete a layer, we'll highlight it, come to delete, and click of the mouse will delete that layer. And next is set current. So it sets the selected layer as the current layer. So when we want to use that particular layer in our drawing, we must first set it as current. So what we're going to do now is we're going to create a total of 14 layers, and we're going to then use this layer pack to create our drawing. So first thing we're going to do is to create 13 new additional layers. We'll have our layer 0 selected. We'll then come to the new layer icon, and we'll just click that 13 times. So when we come to the bottom, you'll see we have all 14 layers displayed of 14 total layers. So we have in total, including the layer 0, we have 14 layers. So now if we open up the PDF, and we're now going to create this layer pack. What I'd like you to do is just pause the video now and give this an attempt yourself. And then afterwards, I will go through this step by step in the video so you can check how you've done. So first thing we'll do is we'll click on layer 1. It's now highlighted. And then to change the name, we'll just click it one more time. And our first layer is columns. And enter. So in our columns, we have our layers on, frozen on, it's unlocked, our color is white, line type continuous, and our line weight is 0.35. For this point, I want you to ignore the plot style as it may or may not be included in the Layer Properties Manager. This will appear as we go to print it at the end. So within the first layer, our only change we have to make is 0.35. So as we copied layer 0 as our default, you see all of the settings are the same. So all we need to do is change our line weight default to 0.35. Press OK.
I'll just expand out my line weight so we can get a bit more information, and also the color section. So next we have dimensions, and we're also going to change the color. So we'll select layer 2, click again to change the text, type in dimensions, enter, and we'll then change the color to red. Press OK. Our next layer is layer doors. We'll change the color to red. Doors, color red. Then we have external walls, color yellow, line weight 0.35. So we have external walls. Color is yellow. And the line weight is 0.35. Then we have fence. Our color is 40. Press OK. Then we have furniture, color 8. And then grid lines, color 8, line type center. So our center line type isn't loaded in, so we'll come to load, scroll down to center, press OK, and then to choose the center line type, we must then select it, press OK, and we've changed our line type. We next come down to hatch. Below grid lines we have the layer hatch. Then we have internal walls, color red, line weight 0.2. We then have text and title block below. And title block, the color is cyan. And we then have viewport and windows, magenta and green. And the viewport color is magenta. And the Windows color is green. And with the viewport layer, we'll see that our plot is turned off. So we don't want our viewport to be printed, so we'll switch it off. So we've now created our layers, and this is our layer pack. I just want you to reduce the manager down because it's quite large. We don't need it to be this big. So just down the bottom right-hand corner, you're going to wait for those angled arrows, click and drag just to reduce it down in size.
Now that we have a basic understanding of the drawing and modification tools,
ensuring that we have all the layers inclusive.
We're now going to move forward with the next part of the course where we'll create a small house project.
So there's our layer manager.
Project, we will learn how to organize our project.
Attached to this drawing is a file called layers, and in there, if you have struggled to create the layers, within that drawing I have created all of these layers for you. We're now going to begin our practical of drawing a typical house. Now this house that we're going to create is very basic, but it utilizes all of the features which we have learned. At the end of the course, I will give you a little bit more advanced drawings to follow along with, but for now I've kept this as basic as possible so you have a good understanding of what we're doing. So if you open up the PDF, we have our drawing practical number 13, and it's called Draw Grid System. So we're going to draw our grid lines. So in construction for a new build, which would have columns or particular setting out points, we would use a grid system. This is not applicable to all projects, but I have applied it to this practical just for illustration purposes. So what we're going to do is we're going to draw out this grid system, just like we've been doing before. We're going to use our line tool, but we're also going to utilize our layers. So each one of these grid lines is on our grid line layer. And what we're going to do is we're going to build our project with using the correct layers, and then it will become more apparent why we use layers. So I will now draw my first line at 13,500. So in my drawing, over on the left-hand side, we have all of the practicals which we have drawn. For this one, you need to give yourself a bit more space than we have been doing before. So you can come above our practicals or over to the left-hand side. Anywhere is fine as long as it's nice and clear and big enough to facilitate the project. First thing we're going to do is we're going to change our layer from layer 0 to the grid lines. So here is our quick access layer bar. We'll hit the drop down arrow, and there's all of the layers which we have created. There we have our grid lines. So one click will activate the grid line. And just quickly, I'm going to open up the layer properties to show that in the status bar, it now has a green tick. I'll close that down. So we'll draw our first line, which was 13,500. So now I'll select my line tool. One click of the mouse will be my start position. Draw straight up 90 degrees and 13,500. Enter. And enter to complete. What I can do now is I can offset the first line across by 6,000. So use my offset tool, O for offset, distance of 6,000, enter, select my object and the direction. Enter to finish. And I'll come down to the bottom now and I'll draw the lower line, which is 12,000. So L for line, attached to the end point, move the cursor in the direction, and enter the distance of 12,000. I then want to offset the lower line up by 3,000 and then 4,500. O for offset, distance 3,000, and then 4,500. And lastly, we'll just close off the top and side. So L for line. I'll just zoom in slightly. So lastly, we just have this small section here, which is 2000 by 2000. So L for line. As I want my line to start across by 2000, and I don't want to draw a line to get to that point, I'm going to use my snap reference. So hover over the point of intersection, move to the right hand side, enter my distance of 2000, enter, and now my line will start 2000 across from the initial point. And then I move up by 2000 and then connect back to the intersection, ensuring that my lines are straight. So what you'll notice is what we have drawn doesn't exactly match the PDF. The PDF has a series of long dashes and short dashes. And in the drawing, we have a solid line, even though in our layer properties, we have changed our line type to center. So the appearance should be the long dash, short dash, long dash, but it's not. And the reason for this is within AutoCAD, as we can draw on multiple scales within the model area, AutoCAD doesn't know what scale we are drawing to. everything that will be initially placed will be at a line type scale of 1. So if I zoom in, you'll notice that there we have our long dash, short dash, long dash. But when I zoom out, it is solid. So what we need to do is to increase that line type scale. And to do that, I will first highlight all of the lines. So we'll do this all together. Once they are highlighted, I'll refer to my properties palette. If your properties palette isn't open, PR for properties. And in the object type there, you'll see that we have line, and it's also displaying the number of lines which are selected. So we have 9 lines selected. Now you'll see our color is by layer. Our layer type is grid line. Our line type is by layer, which we have set to the dashed. There we have our line type scale, which is set to 1. So if I increase that to, say, 40, press enter, you'll see that the lines will become much larger than originally shown. The only way to find out the most suited line type scale is just to go up in increments of 5 or 10 until you find what scale you prefer. So if we go to 5, you'll see the lines are a little bit bigger. We have 10, 15, and 20. So line type 20 is the scaling at which I want to keep, as I think it looks best. It suits the size of the drawing best, and it also matches our PDF. So we can then press escape, and we have set our grid system with the correct line on the correct layer and the correct line type scale. Now referring back to the PDF, the next stage is to draw a column and then place it on our grid system. So we can see here our column is 300 by 420. X is always first, Y is second, so it's 300X, 420Y. And we'll draw a column by using a rectangle. So we'll come back to our drawing. And the first thing we'll do now is we'll change our layer to columns. So we'll select columns. And we'll now draw our first column. So we'll go either click on rectangle or REC, enter, specify our first point. And our rectangle was 300 by 420, so 300, comma, 420, enter. And there we have our column. And we want to place our column accurately at the center point and then place on the grid. We have a number of ways in which we can place the column. First, I'll choose my move tool. If I just pick up the column, I can place it on the end point. I can then move it to the midpoint of the lower line and then move the midpoint of the side line down. And now that is placed in the center point. So that's one method. I can also use my snap referencing by again choosing my move tool, select the column, hover over to leave a snap reference, hover over to leave a snap reference, and when I move to the middle of the column, both the lines will come to intersect. One click of the mouse. So now my base point is now the center of that column, and I can place it on the grid. And another way would be to come to your object snap, turn the geometric center on, M for move, select the object, base point, and there is our geometric center. So that's up to you how you want to do it, whichever way you feel more comfortable. And from that point on, I'll turn my geometric center off, and we'll just copy our column to each point of intersection on the grid. CP for copy, zoom in, my base point is the point of intersection on the grid line, and I'm looking for the end point snap each time. Each time I'm looking for the end point snap. There we have the midpoint, end point, end point. And what I can do, just to speed it up, I have these 3 columns, which I can then copy down, just so we can speed up that process a bit more. Save ourselves some time, enter the finish. So now we have our grid system and we have placed our columns. Our grid line is on the grid line layer, and our column is on the column layer. If you have accidentally drawn everything on, for example, layer 0, so if I draw a singular line, which is currently on layer 0, we can manipulate that line to transfer it over to a different layer. And to do that, we'll select it, go to the layer select, and there we can change it to a different layer type. So in that scenario, you'll do that if you've only accidentally forgotten to place a line or object on a particular layer, but it's always best practice to first choose your layer, then select your drawing tool. As you progress, you'll notice in your drawing you're going to have hundreds, if not thousands, of different lines, circles, everything. If you had to then go back and to change every single line to a particular layer, it's a very long process. So it is best practice to choose your layer first and then move on to your drawing. Okay, so I'm going to delete that line, come back to my grid. Now we've created our grid system, we're now going to move on to adding the external walls and internal walls to our project. So referring to the PDF, under Practical 13, we'll now move on to Draw House. And the yellow lines are the external walls, and the width of those walls are 300 millimeters. So first we'll draw those, and then we'll work our way in and do the internal walls. So first thing we'll do is change our layer to external walls. And here in the PDF, you'll see that our external walls attach to the column. And then in the upper section, it'll attach to the inner face of the column. And then we'll offset out by 300. Pull it down. Same on this section here. We're attaching to the inner side. Same here, and attaching either side of the column, running around. And then the front of the building will attach to the outer side of the column, offsetting back in by 300. And we'll come to this point here, and then we'll work our way to do the bay area. So starting in the bottom left-hand corner, we'll select our line. And it's attaching from each point of the column. So enter to turn the line off, enter to turn it back on. And I'll then work my way up around the building. If at any point you feel I'm going a little bit too fast, you can pause the video at any point and then catch up to where I am. So again, we'll use our line tool, attaching to the endpoints of the column. So now for the upper wall, we'll see our wall starts on the inner side of the column and we offset out. So using our line tool, attaching to the inner side of the column, then offset over offset, 300 units. Select the line and our direction is up and out of the building. Continue on with the line tool to each outer edge of the column. And then for this section here, again we're on the inner side of the column and offset out by 300. So inner section of the column, offset out by 300. And then continue with our line. And again we're on the inner side of the column, offset out by 300. And on the right hand side of the building, we're just running down, attaching to the end points of the column. Then for the front of the building, we're going to attach to the outer side of the column and offset in by 300. So go to the outer side of the column and offset in by 300. So we'll now move over to the bay window. And in order to create this, we will use our polygon tool to create the bay window. And we're just going from endpoint to endpoint. And we have a total of 6 sides. So I'll go to the drop down arrow for the rectangle, select my polygon. First I'll enter the number of sides and enter. So I'm being asked to specify the center of the polygon. So I don't have a center point right now. So I have 2 options to do this. I can either escape and then draw a line. I would then use the midpoint of that line as my center point, but that obviously takes time. We have to draw an additional line for us to then come back and delete it afterwards. So what I'll do is I'll show you a quicker way in which we can get the center point between those 2 columns. I'll select my polygon, we'll enter the number of sides, which is 6, and enter. And then at this point, what I'll do is hold the Shift key and right click. Hold Shift, right click. So here again we have this is our snap menu. And just third from the top, we have this feature called mid between 2 points. So what this does is we'll specify 2 points, and this tool will bring us to the midpoint of those 2 points. So it will give us the center point for the polygon. So I'll select that. I'll go to the bottom right hand corner of the left hand column and the bottom left hand corner of the right hand column. Once I select the 2 points, you'll see my polygon tool now jumps to the next question, which is it inscribed in the circle or is it circumscribed about the circle? So we are inscribed. And there you can see my center point, which is mid between 2 points. Finally, I'll just pull over to the right hand side and attach to the edge of the column. So just to quickly go over that again, we have select our polygon, select our sides, hold Shift, right click, mid between 2 points, and then I'll select the points between the column. And there we have our midpoint between the 2 columns. So it's a much quicker way than having to draw a line, finding the midpoint. So we'll just escape. So now we have the inner side of our wall. We need to offset this out by 300 to create our full exterior wall. So we'll use our offset tool. So over offset, our distance is 300. Select our object and go to the outer side and click. So if I go over to the left hand side, we'll notice that the polygon is overshooting this column. So what we'll do is we'll just draw a little line to connect the 2. So connecting to the column, draw straight down, connect to the polygon, and same on the other side. And then at this point, we'll use our trim tool to tidy up. So TR for trim, select the inner polygon, and remove those excess lines. Same again, this time I'll just select the small lines which we have created, enter, and remove. So now we've created all of our external walls. What we'll do next is create the openings within that wall. So first I'll come up to the top section, Here we have an opening of 2,400 units. And I know that it is centered because the dimensions either side are 590. So at the midpoint of that line, we can create our opening. So I'll come up to the top. I'll draw a line from the midpoint on the left line to the right line. Then I'll use my offset tool to offset it either side by 1200, which is half of the 2400. So I'll go up and down, enter, and delete the inner line. And then finally TR for trim, and then delete the opening lines. And we'll do the same for the side pieces, so 1200, 1200. And they're both equal because the dimensions are the same either side. So same process again. And I'll do the right-hand line as well. So the top one is 1200, so offset 600 either side. Delete the inner line. And TR for trim. So then referring back to the PDF, we'll come down to the front of the building and we'll create our openings here. So the first opening starts off 200 units off from the edge of the column. So L for line, I'll hover over the corner of the column, leaving the snap reference, so I'm not clicking. Then I'll move my cursor to the right hand side, distance of 200, enter, and now my line starts. So I can look for the perpendicular point, click, and that is our first line. So now I can offset this line to the right hand side by 1200, 1250, 18, and 1250. So O for offset, first distance is 1200. Enter to turn it off, enter to turn it back on, 1250 again. Enter to turn off, enter to turn on, and the last distance is 1800. So we have 200 from the start point, then 1200, 1250, 1800. And then we just use TR trim to tidy up. Next, we'll come down to the bay window. And we have 3 openings. So the openings are a total of 1800 wide. And they are centered. So I'll do the first one at the lower end. So I'll just draw a straight line across. Offset 900 either side. Then delete the line and trim. And then next, on the left-hand side, I'll go to the midpoint. And what I'm looking for now is the perpendicular point. So I'm looking for the perpendicular snap. If it doesn't appear, hold Shift, right-click, look for perpendicular. When it appears, one click of the mouse, and that line is perpendicular between the two. We'll then offset it across by 900 either side. Enter and delete, and trim the opening. To save ourselves a bit of time, what we can do is mirror this opening across to the other side. And to do that, we will select our mirror tool, MI for mirror. And for the draw the mirror line, I'm looking for the midpoint of this line. So I've actually removed that to create the opening. But what we can do is we can use the mid between 2 points. So hold Shift right click, enter my 2 points, and there's my mirror line. So I can either go straight up 90 degrees or come down to 270. Click, and we want to keep both, so we'll select no. TR for trim, and we create the opening.
Now we've completed the external walls, we'll now move into the internal walls. So our smaller red lines, and the internal wall width is 100 millimeters. So come back to the drawing. I'll now change over to the internal wall layer. So running off the grid line, this wall here is centered on the grid, and so is the upper line. So what we can do is we can just directly draw a line from midpoint to midpoint. And the thickness is 100, so we'll offset it either side by 50. We'll then work back and delete the initial line. And then in the PDF, we'll see the lower line is fine, we don't have an opening. The upper line does have an opening, a total of 2 meters. So you could either draw a line across, then offset it down 2 meters, and then trim, or I can select my line, hover over the first point, leaving a snap reference, move my cursor in the down position, enter my distance, and now my line starts 2 meters down. So we can draw it straight across, looking for the perpendicular snap, use the trim tool, and trim the opening. Then next we have another 2 meter opening with equal distance either side. So for this one, I'll look for the midpoint and offset a meter either side. So there we have our internal walls with the openings drawn. Next we will create the fence with a width of 100 mil. So the fence line comes across 7,500, coming directly down to attach to the column in the center. So first thing is we will change over to our fence layer. L for line. And we'll draw that at 7,500. And then leaving a snap reference, I can hover over the bottom right hand corner of that column, pulling across to the right. And when I get the snap, just click. So now that line is lined up with that column. And it now just requires me to offset by 100 mil. And we have a radius here in the corner of 2 meters. And there's a process which I'm going to show you, which will be the correct way. And I'm also going to show you why we do it as opposed to the other way. So first thing first, when we look at the fence, we know that it is 100 mil wide. So we could just draw the outer line as we've done and then fill it both. There is an issue with doing that as our radius is 2000 for the inner line. If we take the 2000 for the outer line, we'll get a different result. So to show that, what I'll do is I'll offset both lines. And then I will fill it by 2000. So we fill the inner line and the outer line. And you'll notice that the thickness of the fence, it becomes wider on the curve. So the thickness of the fence is wider on the curve because we've given a incorrect radius for the outer line. So the inner line is 2000. That doesn't mean that the outer line is also 2000. So what we need to do is we'll first delete the outer line. The process will be to draw the lines, to fillet it,
and then offset everything together. So now that you have filleted that edge, if you offset that edge at 100, the curvature will be correct. So now we'll O for offset, 100. So we'll do first the lines, then the curve. So we can see that the width is the same going around the curve as it is between the straight lines. And then we'll just finish off the entrance to that fence. So we have the fence comes out by 300 mil and the thickness is 100. So we'll just close off the end, attach to the bottom right hand corner of the fence, width 300, the length 300, the width 100. So now we have drawn our grid lines, our external walls, internal walls, fence, and we have created the openings. Now that we have a lot of information on the screen which are attached to our layers, I can demonstrate more features with the layers. So in the layer panel, we have our little quick access to certain features. First one here we have off, and below that we have on. Like I discussed before, we can turn certain layers off so they don't appear on the screen. So if we wanted to hide some information off the screen which we didn't want to be displayed for that particular time, this is the perfect way to do so. So what we'll do is we'll click the layer off button and then we'll select the layer itself, which was the external wall, and you'll see that all of the external walls have turned off. So they're no longer on the screen, and it frees up some space for us to do further work. Now at the point at which we want them to come back on, we'll come back to our layer panel and just switch all layers back on. If we had more than one layer turned off, like our external and internal layers turned off, if we didn't want all of our layers to turn back on when we select all layers on, what we can do, I'll just switch these back off. What we can do at this point is come to our drop-down menu, and there's our little light bulb, so we can individually turn them back on. And next one over is called isolate, and then below that is unisolate. So in an opposite way in which we turn our layers off, what we can do is we can isolate one particular layer. So if you can imagine there a drawing with a lot of information on the screen, and we wanted to just isolate one particular area so we can work on that, we can select our isolate layer, and again I'll choose the external wall for the example, press enter. Now only the external wall layer is now active, and then to bring everything back we'll go to unisolate, which is just below it. Next over we have the freeze layer, so we'll select our freeze, select the external wall and enter. So just a reminder that the freeze is the same as the layer on off. So at this point AutoCAD then releases it from its memory. If your drawing is quite slow, you'll see a boost in performance. So same like the on off, if you had multiple layers frozen, you could come to the layer select and you could manually switch each one on and off. Or we could go down to thaw all layers. So we'll thaw all layers, everything will come back. Next one over is lock. So if we select the lock, and if we select our external wall again, you'll see that it goes from that nice bright yellow, it becomes grayed out and looks like it is kind of sunken into the background. So if I zoom in, and for example, if I highlight all lines and click delete, only the grid line is deleted and the external wall remains because it is locked in place. I'm going to undo that to bring everything back. And I can still select my line, but I can't delete it. I can still select it, but I can't move it. And if I wanted to draw a new line, I can still connect to it. So it's still an active line in that sense, but we can no longer manipulate it by moving it or deleting it. So it's a good fail-safe for particular layers which we want to remain in position. So next I'll choose unlock the layer, and we'll unlock our external wall layer. And what I want you to do is to lock the grid line layer. So we can either use the quick access toolbar here. We can also go to the drop down menu, go to the grid lines, and there's our locking symbol again. Or in the properties section, here we have our lock symbol as well. So I'll select my lock, select my grid line, and we want to keep that locked in position. Next one, top right, we have make current. So currently, fence layer is our current layer. If I wanted to start using the external wall type, instead of coming to the drop down menu, changing over to the external wall and then continuing, what I can do, I'll come back to fence. What I can do is I can select make current. So I'll click make current, select the line or layer which I want to be current. One click of the mouse and you'll see that our layer is now external walls. So again, there's select make current. We'll select the line or layer which we want to make current. And we've now changed our layer over. We can also match a layer. So for example, what I'll do is I will select these lines and change them over to external wall. And in the drawing process, if I accidentally draw the internal walls as external walls, I can select match layer. So what I'll do is I'll select match layer. I'll select the external walls. I'll select the lines which I want to change. Press enter. And then I'll select the layer which I want it to then become. So just to repeat that, I'll undo to bring back. So again, if I've accidentally drawn this internal wall using the external wall layer, I'll come to match layer, select the lines which I want to change, press enter, and then select the layer I want them to change to. And we'll see all the lines change over to the internal wall layer. So the next stage of creating our building project is we're now going to include some windows into the house. If you refer to the PDF, here we have the dimensions for that window. So we see our wall is 300 thick, that's our external wall. We have a 50mm frame and some glazing running through it. So at first we just want to draw our window outside of the house, and we're then going to copy and paste it into the new locations. But typically in a project you can just straight draw the windows directly into the external walls. So first thing we need to do is change our layer to windows. We'll then come to our line tool. We have a total length of 1800. We can offset that up by 300. We'll then draw our frame by using the snap reference, so hover over the endpoint, move to the right, 50 for our distance, and now we can come straight down connecting to the parallel point, and same for the opposite side. And lastly, we just draw the glass going from midpoint to midpoint. So coming back to the PDF, we see our window frame is green and our glass is grey. So all of our lines that we have just drawn are all on our Windows layer. So we want to keep that always. So if we ever wanted to recall only the window lines, we're able to utilize the power of the layers to do that. But not always do we want that line to be colored in green, but we do want it to remain on the Windows layer. So we have full control over that as well. So what we want to do is change our glass from green to grey. And to do so, we will select the line, the Properties panel here in the Home tab ribbon. And our first option there is our color. So with the drop down arrow, we have first by layer, secondly by block, which we'll cover later on in the course. When you assign by layer to a line, it takes on the properties of our layer, which we have created in our layer properties. So while keeping the glass on the Windows layer,
we have full use of the index colors to be able to change the color of that particular line. So it doesn't change all of the window lines, it only changes that particular line. And just below the black, we have our gray. So this is the color which I want to use. So we'll select that and we'll see only our selected line becomes gray. And if I highlight all of the lines, we'll see that it's still on the Windows layer. You'll also notice in the Properties panel, it no longer says by layer because this particular line is no longer on the by layer function. So if I select the green line, you'll see that it still remains on the by layer function, and select the gray. It'll just display the color which we have selected. So as well as being able to change the color, we can also change the line thickness. So we have by layer, which will revert back to what we've specified in our layer properties, or we can change the thickness within this drop-down menu. We can also do the type as well. So that any particular line types which we have loaded into the project can be displayed here. So we only have continuous and center at present, but we want to remain on by layer, which will refer back to our layer properties. So now we want to copy and place our window. So in the PDF, I'll display where exactly I want those windows to be placed. And the reason I wanted you to draw it off to the right-hand side, so we can continue to practice what we've previously learned from the Modify panel. So if I only use the Move tool and move the window by selecting the base point and attaching it into the external wall, we can of course just move one window, and then from that point we can copy it around to each point within the bay. Or from this point we can copy this particular window to each point. And what you must take note of is your base point. So this is where the understanding of the base point will come into practice. So for example, if I choose copy, select my window, enter to confirm. If I choose the midpoint of the window as my base point, when I come to the window opening, I have no snapping point, I have no reference point to accurately place this window. The only way would be to use the mid between 2 points or draw a line, which is additional work. So when I use my copy tool, I know that I want it to be placed within these 4 points. So I, in fact, have 4 base points which I can choose from. If I go to the top left-hand corner of the window, I must place it in the top left-hand corner of the opening. Same bottom right-hand corner of the window goes to the bottom right-hand corner of the opening. So it's where we place our base point is where we will place, is where we can then locate the placement point. So we can copy and paste the window into the lower side of the bay window, which is the same method as the upper side. Now the difference now is when we move on to the angled walls for the bay window, we have to now think a little bit more about where we want to put our base point. So we have to think about the placement of our base point, and the reason being is once it is placed, we then have to rotate that window. So we also have to be mindful ahead of our actions, where do we want our point of rotation? So I use my copy tool, select the window, I'll go for the bottom left-hand corner, and I'll place my window. So when I come to place my window using the bottom left-hand corner as my base point, I have to be mindful of how I'm going to then rotate that window into position. So where those 2 points meet will be my point of rotation. If I put it to this point, when I rotate it, my window won't be in the correct position. So coming down and attaching to this position, I know when I now come to use my rotate tool, that when I rotate this window, the 2 points of intersection will be my point of rotation. So I'll select my rotate tool, select the window, enter to confirm, and my base point is where they meet. Now we can see my window is able to rotate around that point, and when it gets into the correct position, all four corners meet. At this point, I'm actually able to use the polar tracking as the 60 degrees is turned on, which matches the angle of my bay window. But that's not always going to be the case. So how we accurately place our window is we will come up to the top position. When I reach my end point, everything is snapped together, click of the mouse, and I'm 100% confident that my window is connected at all four corners and at the correct angle. So we'll do the same for the other window. This time we can just move the window across. And coming this time to the bottom right-hand corner of the window. And then just being mindful about where I'm placing my window. So again, the placement of the window is important to understand for the rotation point for when we then want to rotate our window. And we can now use our rotate command as our center point. So now we can see my windows rotating around, and I'll then come back to the external wall. When I find a snapping point, I can either use the midpoint or I can use the end point and click to place. So the reason that on the right hand side I went up and on the left hand side I went down was simply because of the angle at which I was rotating the window around. So now we have all the windows drawn in the front of the house. Now that we have our windows drawn into the front of the building, we're now going to move on to creating the front door. So referring to the PDF, we have our door. So with this one, again, if you'd like to pause it and try yourself first, please do, and then we can work on it together. So first thing I'm going to do is draw my door frame. And I'll zoom into my door opening, and I'll also change to my door layer. So using my line tool, I'll connect the corner of the opening, which is the end point of my external wall, and my width is 50. I'll then come up to 50, inward by 20, up 50, and connect back to the wall opening. To save myself from drawing the frame on the opposite side, I'm going to use my mirror command. So I'll select mirror, select my lines, enter to confirm the selection, and now I'm being prompted to specify the first point of my mirror line, and I want that to be the midpoint between the opening. And I can get that by holding Shift, right click, mid between 2 points. I'll first specify the first point for the mid between 2 points and the second. And now it jumps to the center point and I can draw my mirror line. So just make sure it's at 90 degrees, click to place and select no or type N in the keyboard. Next we have our door with the door handle at 45 degrees. So to save yourself some complication, what we will do is we will draw this door at 0 degrees. The reason being is of course we can draw this rectangle at an angle as we had done in a previous video, but what becomes more complicated to draw is the doorknob, as you'll see on the left hand side here. So to be able to draw this intricate detail is quite difficult at an angle, so it's best to do it at 0 degrees and then rotate everything together to get our 45 degree angle. So for my door, I'll use my rectangle tool. I'll go for the top left hand corner of the frame to the lower right hand corner of that opening, and that's my door. I'll then zoom over to the right hand side, and we're now going to work on the door handle. We'll draw it once on one side and then mirror across to the other. What you will notice is our doorknob is a nice curved line, and how we achieve that is we draw the dashed grey line as a polyline, and then I can show you some additional tools that we can use with the polyline. We want to draw this as a polyline, so we got
across by 100, up 20, 20, 20, 60, 20, 20, 20. So PL for polyline, hover over the first point, move the cursor in the direction I want it to go, 100 units, and there my polyline will start at that point. We'll then go up 20, across 20, up 20, then to the left 60, down 20, to the right 20, and finally coming back and attaching to the door. So now we have our polyline, which is the joined line segments. And with the polyline, as we spoke about before, comes with a lot of additional features over using the line. So having the polyline highlighted, I'll right click with the mouse, come down, we have a section for polyline. So here we can edit the polyline. And the first thing we can do is close it. And what that means is, here is my first point and we worked around to our last point. And the polyline command will always remember where was your first and where was your last. So what we can do is we can choose the close command, and that will join the last point to the first point. And enter. So there we see our polyline is joined as a closed object. So this feature is very useful when drawing. For example, if I'm drawing a quick square, if I do 50, 50, 50, and down the bottom I have those additional commands as well. I can type C for close, enter, and it will close the polyline. And then you are 100% sure that that polyline is completely closed, which is very important, and that will become apparent later on in the videos. So again, I'll select my polyline, right click, come to my polyline, and we've already chosen the close. If we choose open, you'll see it will remove that last point. So it will open up what essentially was a closed loop. So it just removes that last segment. And then coming back to our polyline, we have join. So with the join, what I'll do is I'll draw one polyline and I'll draw a second polyline. So these two lines are polylines, but they're not joined together. If we select one of the polylines, right click, come to the polyline section, choose join, and if we choose the other polyline, press enter and enter to finish, we'll see now it is a joined polyline. So both polylines are now joined. If you then further wanted to make this two line segments into one complete segment, you can as well hover over the middle grip and we get three additional options. So here you could stretch it. I'll just Control Z or undo that option. We can also add additional vertex. Again, I'll just Control Z to undo that. And we can also remove that vertex. So those two singular polylines, which we then joined to be a joint polyline segment, is now one polyline segment. So it's another benefit of using a polyline over a line. But just note, you shouldn't draw everything as a polyline, which I'm sure you're questioning right now. If we use polyline for absolutely everything, our file size will be enormous. You can see all of the additional features which are attached to a polyline. If we were to draw every line as a polyline, our drawing would be unnecessarily big. So where it's needed, you'll use your polyline, and for everything else, just stick with the line. So again, coming back to the doorknob, I'll select it, right click, and to our polyline menu. So next we have reverse, and what that does, again coming back to my polyline, We started with this position, that was our first point, came around to our last point. If we use the reverse command, this will now be our start point and this will be our finish. Now the reason for this is if we choose a different line type, right now we're using continuous line type. If I was to change the line type to say gas or fence line, if the text wasn't running in the direction in which I wanted, we could use the reverse command. It would reverse the line type and we could see it clearer. And again, coming back to the polyline menu, we have width. So with the width, we're able to change the width of the line, which appears in our model space. So for example, I can change my width to 5. You'll see it increases in thickness. And if you come to the property section, you see there's my global width, which is 5. We'll just revert that back to 0, so we'll come back to the global width of the drawing. Keep in mind that for our line thicknesses, we will always use our layers and layer properties and adjust our line thicknesses there, so that in our model space, all of our lines appear the same width to help us model. Then when we go to print, that's where we'll see our thicknesses. So with the global width, and to be able to change the polyline's width, you'll do that on singular segment points. You can do that to highlight a small area, just so it's a bit clearer on your model, or even just for yourself to take note of certain areas of your drawing. Adding the global width for you just highlights that area more clearly. And again, coming back to the polyline menu, we have curve fit, spline fit, and decurve. Here is where we will apply the curve to our polyline. So first one is curve fit, and we'll see that we have kind of a mushroom effect. If I select the polyline, you'll see there are original points, and we have a curve between them. So what I'll do is Control Z to undo. And again, right click polyline menu. There we have spline fit. So here we have the spline fit showing our vertex and our lines curving in between each of those, which is creating the correct curve. And then lastly, we'll select our doorknob, come down to the polyline, and we can also decurve it, so we can bring it back to the original shape. And for our practical, we will reverse it back, and what we want to do is select our spline fit. I'll delete that upper polyline which we've drawn. And there we have our doorknob, and we just need to now mirror that across to the other side of the door. So MI for mirror, select the doorknob, select the midpoint, coming across 180 degrees, and enter to select no. So now we have our door drawn with our door frame, and we just need to rotate the door with the door knob. So RO for rotate, select the door, select the knob, enter to confirm, specify the base point. We now need to specify the point of rotation for our door. So again, we just need to be mindful about where we want the door to rotate. Is it here, here, or at the top? Just try to imagine yourself how that door will rotate. If you imagine our door hinges at this corner, here we put our base point, and if I move my cursor across 0 degrees, move up, we'll see our door rotating around that frame. So we just want to specify our rotation angle. We'll enter in 45 and enter. And we have created our front door. So I'm going to zoom out to show our floor plan. And I'm going to show you some additional features which we can use to help us to model. It's another one of our drawing aids. So down here in the status bar, we'll come down. When I hover over, it says isolate objects. There's 3 shapes. There's a square, circle, and triangle. What I want to do is just click that, and it will display isolate object and hide object. So the isolate object, what that will do is whatever lines we select become isolated, meaning that everything else is temporarily invisible, and it allows us just to focus on what we have selected. And where we have hide objects, whatever I will select will temporarily be hidden. So again, it just kind of frees up a bit of clear space if we're trying to focus on an area which has quite a lot of information. So I'll select isolate objects, and all I need to do is, say if I select this corner here, press enter. Now everything else has been removed from the screen and only this section remains. So now I have full focus on that corner, and whatever information I need to add in or draw a particular detail, everything else won't get in my way. So we'll come back down and select our tool, and we'll see at the top we have isolate additional objects, so we can add in further objects if we wish. So there I've just selected the glass and everything else has been hidden. So then coming back to bring everything back, we'll go down to what is called end object isolation. Once I select that, all information will return to the screen. And then to use the hide objects, we will select the object, press enter, and it will become hidden. So we'll select hide object, enter, and it will become hidden. Again, just freeing up some space. Right now you don't see the benefit of this because we don't have a lot of information on the screen, but as your project builds, you will have quite a lot of information in front of you, and if you're trying to work on one particular corner and the screen is very busy, this is a very helpful tool to free up that drawing space and you can focus on your work. So same method to bring everything back. We can just select end object isolation and all our information returns to the screen. So to kick off the next module, we're going to begin by looking at what are called blocks. So in AutoCAD, blocks are named groups of objects that act as a single 2D object. You can use them to create repeated content, such as drawing symbols, common components, and standard details. Blocks help you save time, maintain consistency, and reduce file size by reusing and sharing content, rather than redrawing it every time you need it. Now that we have a basics of how to draw, we're now going to look at different tools and features that can assist us when we're drawing and how we can speed up the process. As we have covered all of the basics on how to draw, our main focus now is just to hone in those skills, speed up our process, and be able to draft our models quicker. So I've given you the definition of what a block is. I'm sure you're still questioning what exactly it is. So what we'll do now is I'll show you where the block tools are. And of course, we're going to create a basic block. And from there, we're going to build on using all of the various different tools within a block. You'll truly understand how blocks operate and work. So back in our project, we're going to stick with the same drawing. In the Home tab, beside the Layer panel, we have a Block panel. And the first big tool we have there is Insert. So why we need an insert tool is we create blocks on a separate library. As we begin to use AutoCAD more frequently, you'll begin to create your own library of blocks. And you don't want all of those blocks to be in every single drawing, as it's going to slow it down. So what we do is we create a separate library, and when we want to recall that block, we then insert it from our library. Next we have create, which is where we're going to create our block next. And below that is how we can then edit our block. So what we're going to do now is we're going to create our first block, and the block which we're going to create will actually be our window. The reason we're going to focus on creating a window as our first block is, first thing, it's an easy object for us to redraw. The window itself is duplicated around the project multiple times, so we'll get a good understanding of how the blocks work. So we'll select Create Block. And when creating a block, it's important that we follow each heading and enter in the correct information. So from the start, the block will be created correctly. So the first part of the block creation, or definition of, as this window is called, is the name of the block. Now, one important practice in AutoCAD is not only just naming your files, but naming your blocks. Because at the beginning you may think, oh, I'll create one or two blocks, but as you progress you'll realize that you're creating quite a large catalog of blocks, and to recall that block you're going to find difficulty if you've not named it correctly. If you're currently working in an office already, perhaps they'll have a drawing and block naming practices already. And how I'm going to name my block, the first word will just describe what the block is. So we're going to create a window. And then after that, we're going to describe what type of window that is. So this particular window, I'm going to call type W1. So type capital W1. Then after that, I'm going to give it the dimensions. So this window is 1800 wide, so I'll type 1800 millimeters. So then in my catalog, if you can imagine, I'll have all of the windows will be joined together. Then I'll refer to what type it is and then the width of that type. After we've named, we then come down to the next panel, which is the base point panel. So as I said before, when we create a block, it goes into a block library, which then must be inserted into our drawing. So when the block is inserted into our drawing, we want to apply a base point to that. We can either apply the base point to X, Y, 0, 0. So on the drawing, all of our blocks will go to point 0, 0. We can also pick a point on the block. So when the block is inserted into the drawing, the insertion point is on the object. So it's easier then for me to place and move into position. So the example we were going to be using is the window in the front here. So when I select pick point, it's going to bring me into the drawing, and then I'm going to place my base point. So I'll click pick point. I'm going to zoom into the window. And for me personally, it's just my own personal preference. For everything I always create, I will always put my base point, if I can, to the bottom left-hand corner. For me, it just keeps a consistency, and I know that when I'm going to insert a block, I don't have to think, where have I put the base point? So I'm placing it on the bottom left. When I click the mouse, it'll bring me back into the block definition screen. So the base point is now complete. We move on to the objects panel. So the objects is referring to what will be our block. So what we need to do is we need to select our object. So we'll click here, select objects. That again will bring us back into the drawing. And I want to select all of the window lines. And once they are selected, I'll press Enter to confirm. And now you'll see here beside the name, we have a small preview of our block. Below that then we have three options. We have retain, convert to block, or delete. What those options are referring to is the lines which we have just selected in the drawing. So when we complete the block definition, do we want to retain the lines in the drawing as being lines and do not convert it into a block? So when we press OK, these particular lines will not become a block, but the block will be created and it will be in our library. Next, we have convert to block. So again, the lines we have selected, they will become a block when we press OK and complete the block definition. And then below that we have delete. So again, these lines which are selected will be deleted from the project, but our block will be created and it will be in the library. And then below that we have how many lines are selected. Next we have the behavior. So the annotative I'm going to skip for now. We will come back to this later on in the course, as we need to spend some time to explain what that is exactly. So scale uniformly means when scale uniformly is turned on, that means that, for an example, if we scale our object by 2, it means our object will scale on the X and Y axis, so it will enlarge by 2, but it will do it in a uniform manner. So the object will retain its shape, but it will just be enlarged twice. If we have the scale uniformly turned off, we have control of whether or not we want to scale it twice across the X-axis, but only one time on the Y-axis, meaning that it will stretch twice towards the X-axis and will not scale up to the Y-axis. We will do an example of this later on in the course, so that will become more apparent. And then below that is allow exploding. So this is referring back to our explode tool, which is in the modify panel. And as a block is a collection of joint lines. If we wanted to no longer be a block and to be singular lines again, we can explode it. So we'll always allow exploding, so we have that option. So when creating a block, these 4 headings are the main headings which we must pay attention to. And then below that we have our settings. So it's currently set to millimeters because that is my template settings, so I won't need to change this. But in the future, if you're creating a block which is required to be in meters, or transfer over to imperial, this is where we can do that. We also use blocks to create a lot of different products. If I wanted to draw a kitchen sink from a particular manufacturer, I will go to their website. On the website, they typically have the AutoCAD spec drawing, so I can recreate that sink, so I can include it in my floor plan. And then as I'll have many different products within the drawing, what I can do is I can attach a hyperlink, bring me back to that product list. So it's a good way to keep your blocks organized by including the hyperlink to the product you've just drawn. And then with that we have a description. So here again you can add in the manufacturer. The description of the block is purely for your use. You can add in information about the manufacturer, where you found that particular product, or as we're drawing a window, you can add a small description about the type, so it could be a single pane window and so on. So it's just a little bit of description about that particular block which you are creating. And to the bottom left we have open in block editor. I have it turned off currently, but if I tick that on, and when we close down the block definition, the block editor will open and we can then continue to edit the block. But for the purpose of this, I'm going to untick, so we will not have the block editor open when we complete this. But in the future, if this is how you wanted to continue your drawing, this is where you will do that. But of course, once we create our block, I will show you how we can go into our block editor. So all the information has been entered for our window block, and I'll press OK. So now what I want you to do is to click on the window, and you'll notice that all of the lines are joined together. And we have a grip down the bottom left-hand corner, which is our base point. And just to show that all of our lines are joined, and we have what we now know as a block, one click of the mouse on the base point, and I'm able to pick it up and move it with ease. So just for an example, to show the benefits of that, if I wanted to do the same with the window down below, I need to go to my move tool. I need to highlight all of the lines,
specify the base point myself, and then I can move the window. Using my block, I can just click on any of the lines, which will select my block. There's my base point. I can pick it up, put it into position. So spending a little bit of time at the beginning of the project creating your blocks will save you a lot of time during the process of creating your project. Now that we've created our block and that block has now gone into our library, I'll now show you how we can access that library. Back in the block panel, we have our insert. We'll click there. So as you can see, we only have our window within the block library. So at the top here, this is our quick view. So as we continue to create other blocks or insert more blocks, you'll see that this is where we'll be able to access them quite quickly. Then below that, we have blocks from library. When we select that, that will bring us to a destination on our common drive. One good tip is to create one particular drawing file where you will save all of your blocks. So you can have that easily accessed across your common drive. And it's a good place to organize all of your blocks is within one drawing. So we want to insert more windows. So first off, we'll delete the windows which we drew previously. So I've now removed my windows from the drawing. Before I bring the new window in from the library, there's one important thing which we must do is we need to change our layer. So we need to change our layer over to Windows. And you'll see that our window that we've previously created as a block, I have it on the doors layer. So even though all of those lines were drawn using the window layer, when we created the block, the doors layer was the active or current layer. So that is why it is displaying as a doors layer. We know that's not a problem because we can change that. So what I will do is I'll select the window, go to the drop-down menu and change it over to the Windows layer. So it's one thing to keep in mind when you're inserting a block from the library, just ensure you're on the correct layer first. If you've made the mistake and not done that, it's not a problem because you can then select the block and change the layer. So I now click on Insert, select my window, and there we have our base point. And insert our window. So now that we know how to insert using the panel, we can also insert the block using our hotkey. And the hotkey to insert is I. Enter. And that's going to open up our blocks palette. We'll just pull that into the center of the drawing. So you can see that our palette, we have the same bar as previous, so we understand how those functions work. And then over on the left, I have current drawing, recent, and libraries. So on the recent tab, there's our recent block, which is our window. And below that, we have insertion options. So we understand our insertion point. That was the bottom left-hand corner of the window. If we didn't want the block to be inserted from that point, we'll just turn that off, and then we can specify the X and Y coordinate for to then insert to. But we want to keep the insertion point for now. What you can also do is we can select a scale. So after insertion, we're able to alter the scale. And same again, after insertion, we can rotate the object straight away. And we can also repeat the placement. So when we place one window, straight away we can repeat that action and place another window. We can also use the explode tool. So when the window is placed,
it is straight away it's exploded and all of the lines are now singular segments. So I'm now going to look over on the tab. So we have current drawing. The current drawing tab is going to display all of the blocks which are inside this drawing. So our current drawing being the one which we have open, which is our AutoCAD course project 1. So any block which is in there which isn't being displayed in the most recent, we can find here in the current drawing. Down below then we have our libraries tab. Here we're able to specify a drawing file or folder. So every time we come to this tab, it'll go directly to that folder or file. So we again have quicker access to all of our blocks. So if we click on Open Block Library, this will bring us into our common drive where we can select our block library file, which we would create in the future. Obviously, we haven't created that yet. So I'll click Cancel. I'll select Recent, and I'll select my window. So when I try to bring my window into the drawing, it is telling me that our window type is already defined as a block in this drawing. Would you like to redefine this block reference? So if we choose Redefine Block, all instances of this block will be updated, but we haven't made any changes. Or we can choose Don't Redefine, so no changes will be made to the block or the drawing. So we'll click on Don't Redefine, and then we'll come into the drawing, and attached to the insertion point is our cursor. So I'll place my point where I want to rotate my window, and I'll now close down the block palette. So you can either press I, Enter to bring up that Insert Block Palette, or we can also click on Recent Blocks. That will also bring up the Blocks palette. And if you come to the View tab, the Palettes panel, as well we have our Blocks palette. So many different ways we can carry out the same function. Now, remaining thing to do is just to rotate our block on our base point, and same for the other side. Next, we're going to look at the windows at the rear of the building. So I'm going to use my copy command and copy the window up. And rotate it around. And you'll notice that the window is a different length. So what we need to do is edit this block so that we can increase the length to fit the space. So we can either go to Create and create new and then just redraw the window, or we can edit this and save it as a new block. You have two options. You can create and create a brand new window, drawing it in this location, or we can select the existing and go to Edit. So for this example, I'm going to go to Edit, and we're then going to save as a different window. So when we select Edit, we'll bring up the Edit Block Definition, and here you'll get a list of all the different blocks which you have created, and we currently only have one in the drawing, so we'll just press OK. We want to keep the original window type 1 as it is. So the first thing we need to do is to save this block as to create a new version of this block. So we'll come up to the ribbon at the front where we have Edit Block, Save Block, Test Block. Just below that we have Edit/Save. So hit the drop down arrow and we have Save Block As. So we're going to save block as. And we're now going to give the same format for the new window as we've done with the previous. And a quick way of doing that instead of typing it out again is just by clicking on the original type. That will give the same text, and then we can change the text. So I'm going to change it to W2, and the width of this window is 2,400 millimeters. So we have window type WT, 2,400 millimeters. And then press OK.
So now we're in the block editor and we have safely saved our file as a different one so we don't alter the original. Now I can show you various different things within the block editor. So first, over on the left we have our block palette. In here we have various different actions we can apply to a block. We will cover these in great detail in upcoming videos. And then referring back to our block editor tab, so we see our block editor tab highlighted in blue, and here's our ribbon for creating that block. So we now know that we have our edit block, save block, and save block as. We also have a geometric panel. So within the geometric panel, we have various different constraints we can apply to a block. And then we have our dimensional section where we can apply our various different constraints using our dimensions. Here we have our manage panel, our actions panel, and visibility. So in upcoming videos, we're going to be creating a more dynamic type of block where we're going to utilize all of these features. But for now, I want to keep it quite simple so we can ease you into the process. So just lastly, at the end of the ribbon, we have a big green tick. Once we have finished editing our block, we must use the green tick to finish the block editor. So what I'm going to do now over in the block editor, we need to expand out and stretch our window as it is currently 1800 wide. We need to make it 2400 wide. I want you to refer to the tabs at the top. You'll see we have our new block editor tab, which is highlighted in blue, but we still have access to all the previous tabs. So we can go back to our home tab, but you'll see we're still in our block editor. And the tool which I want to show you now is called stretch. So here in the Modify panel, bottom left, we have Stretch. So with this tool, we're able to stretch objects crossed by a selection window or a polygon. When we're using the tool, it's important to imagine we must have an anchoring point and then to stretch the opposite end. If I was to select the stretch tool and highlight the entire object, we're not stretching it from any particular point. We must specify a base point or an anchoring point for that object for us to stretch away from. So what we'll do is we'll select stretch, and then we need to select the object. And we will come to the right hand corner using my crossing window and enter. And it's now asking for my base point, or if you can imagine that as your anchor point. I'm going to come over to the left hand side and click. We can now see from that base point I'm able to stretch the right hand side away or closer back to the base point. So what I'm able to do now is I'm able to manually type in the distance we want to stretch our window. So we're going from 1800 to 2400, so our additional distance is 600. And when we're adding in the 600, just ensure that we're to the correct side of where we want to stretch. So if I'm over to the left-hand side, and if I was to then enter my distance, the window would shrink. So just ensure that you're going out to the right-hand side, so we'll stretch the window out to the right. And we'll then enter our 600, enter. So we've now stretched our window to a total distance of 2400, and the base point remains the same. So we'll click Close Block Editor, and we're getting a prompt, do we want to save the changes to the block? So the changes you have made may not have been saved. What would you like to do? So the reason for this, I'm going to cancel. The reason for this is back in the block editor tab, in the open save panel, we would need to select save block. But as you've seen, if we don't, and we select close block editor, we get this prompt. So even if you've accidentally skipped ahead, gone to close, you can still save it with this last prompt.
So yeah, we want to save our changes. So all we have done is we have created the new window. And you'll see here, this is our previous window, which is type W1. If we then come to our insert, you'll see we now have two window types. We have our window W1 and our window W2. So we'll select the W1 and delete, then go to insert, select W2. I'll then come down, select my base point and rotate it into position. So you see our previous W1s remain the same as we clicked Save As when we went to Block Editor, and we now have the second window W2. So we can then move on and create the W3, which is 1200, and they'll go in this position here. So you have an option now. You can either choose the W2 as the base or the W1 as the base. So I'll use the W2 and I'll go to Edit, select W2, I'll select Edit Block. Once I'm into the block editor, the first thing we must do is then go to Open Save, Save Block As, and again I'll choose my W2 just to bring up the text, and we can then change it to W3 and 1200. So window type W3, 1200 meters wide. And once we've done that, we'll come back to our Home tab. We can again use our stretch. So the hotkey for stretch is just S. I'm going to select the same corner, enter, specify my base point, which is the bottom left-hand corner. So I'll move my cursor in the direction and then enter in the distance, which I want to reduce it down by. So from 2400 to 1200, I'll reduce it down by 1200. And then we'll see my window's width, total width of 1200. And we're finished, so we'll come to Block Editor, Save Block, and close Block Editor. We'll then go to the Insert tab, and there we have our window type W3, and we can insert. We'll now look at another drawing tool which we can use. And the one we're going to look at now is called the Align tool. So I'm going to come over to the right hand side and I'm going to draw a rectangle. And then I can copy it another below. And the purpose of the Align tool is to select an object and align it to a new position. And the Align tool is in the Modify panel, in the drop-down arrow, and bottom left we have Align. So we'll select Align. So then we want to select the object which we want to align. So we'll select the lower right-hand rectangle, press Enter. And it's then asking to specify the first source point. So I want to align the top left-hand corner to the bottom right-hand corner. So click once and then come to the bottom right-hand corner of the upper rectangle. And there we see our path which the rectangle will take. So our bottom right-hand corner rectangle will align itself in this direction. So press Enter and we'll see that it jumps into position. So that is quite similar as well to the Move tool, I'm sure you're saying right now, but there are some differences with the Align tool. So for example, if I draw another rectangle and I have another rectangle below, which is a different size, I'm able to readjust the second rectangle, align it to the first rectangle, and I can actually align all points to meet. So to show you that, I'll select Align, select the object I want to align, enter. So I want my top left-hand corner to meet the bottom left-hand corner, and I want the top right-hand corner to meet the bottom right-hand corner. So now when I press enter, each corner will follow that path, and it will also alter its shape to ensure that each corner meets those corners. So press enter. So it's asking, do I want to scale the object based on alignment points? If I click no, it's not going to adjust the scale of the rectangle, so it will remain the same shape. So I'll choose yes, so it will alter its scale, change its shape, and align to the points. So now we've just realigned that object to match each of those endpoints of the rectangle. I'm just going to delete out the rectangles we drew for the line, and we're going to move on now and create another block. So I'm going to zoom down to our door. When we created the window block, when I select it, it's on our window layer. If I change it over to say the doors layer, the lines still remain green and grey, but it's on the doors layer. If I wanted to create a block and I wanted the lines of the block to take on the layers properties, what I need to do first is I need to convert all of those lines to layer 0. So to do that, we'll go to our door, we will select all of the lines, and we'll then convert that to layer 0. And then once our door has been set to layer 0, we can then go to the block panel, select create, and we'll name our block door 1200 mil. I'll then go to pick point, and for my pick point I'm going to go top left hand corner. Only reason is because the door is on that side, so I want my insertion point to be where the door is. I then come to select my object, and I'll select the door. I'll select the door lines. Once selected, press enter. So just double check everything. We have our door name, we have picked our point, selected the object, we allow it exploding, and we can then press OK. And you'll see the door is now green. And the reason our door is green is because our current layer is Windows. So our door has now taken on the layer properties of our current layer. We want to put our door back onto our door layer, so we'll select it. Go to our layer select, select door, and you'll see that the door not only takes on the layer door, it's also taken on the color change as well. So when we make our lines layer 0, everything about that block now takes on the properties of our layer. So what we'll do now is we'll just copy our front door and bring it up to the rear and place it for our back door. So we can copy the door by using the copy tool. But just like we're able to select the door block and pick it up and move it using the base point, we can also use the base point to copy the block. So I select the door, I'll click the mouse to enter into the move command, and once I'm in the move command, I then hold the control key. Once I hold the control key and click, you'll see I have created a copy of the original. We'll then place our door to the rear. Use the rotate command to rotate the door around. And then I want to use the mirror command to mirror the door to the other side. So another benefit of having all of those door lines joined together as a block, I was very quickly able to rotate and mirror the door into position. So instead of having to select each individual line, as it's a block, I'm able to execute those actions very quickly. So we just need to copy over our door to a fence now, and we need to make a reduction in the width of the frame. So again, we'll click on the base point, hold Control, and click on the edge of the fence to create a copy. So click on the base point, hold down Control, and next click of the mouse creates a copy. And then I'll rotate the door into position for our fence. So we're now going to edit the block. Previously we've been selecting Edit Block. A quicker way to enter into the block editor is to double tap the block. Once we double tap the block, it'll open up the block editor for that particular block. So press OK, brings us into the block editor. And first thing to do is to save block as. I'll select door 1200 as my base. And then I can type in 100 for my width and press enter. And now I can reduce the width down of the frame by 200 and trim. And once we've completed that, we'll go to Close Block Editor and save. So for the fence door, I'll just select and delete the original. We need to come back to our layer properties, change over to the doors layer, so when we insert the door into the drawing, it'll be on the correct layer. Come to the Insert tab, and there's our new fence door, and place.
Now we've created our basic footprint of our project. We're now going to populate the floor plan with various components. Like I said before, we can create a library file where we can save all of our different components. Example, a couch, bed, or typical kitchen. Within AutoCAD, there is a feature called Design Center. Autodesk have created a library which they have called the Design Center. So the Design Center is useful for mining data from all kinds of drawings. Whereas the Properties palette is concerned with object properties, the Design Center palette deals primarily with named objects. So our layers, line types, block definitions, textiles, and other organizational objects in your drawing. So to open up the Design Center, we can either type in DC for Design Center, which is the hotkey, or we can go to our View tab. In the Palettes section, second to last, we have our Design Center. So one click of the mouse will open up the Design Center palette. Again, just like the properties, we have our sidebar, auto hide, close, and settings. We can also pick it up, move it around, and if wanted, we could dock it as well. So whereas the Properties palette is concerned with object properties, the Design Center palette deals primarily with named objects. So that are our layers, line types, block definitions, textiles, and other organizational objects in your drawing. So essentially we're able to create a database of information which we can transfer from one drawing to another with ease. So we'll see at the top here we have 3 tabs. We have folders, open drawings, and history. So I'm first going to look at the open drawings tab, and we currently only have one drawing open. So this tab displays all content within the current open drawing. So all of our blocks will be displayed here. So when I open up the block section, here are the doors and windows which we have created. And other things which we have already created would be our layers. So there's our layer set that we created earlier on in the course. And the other sections we haven't covered yet, but to quickly show, we have our detail view styles, our dim styles, different layouts, line types, multi-leaders, section views, table styles, text styles, visual styles, and XREFs. These will all become more clear as we progress through the course. The Design Center is a good, resourceful palette, allowing us to access all of this information quite easily. And I'll show you the benefits of having the Design Center when we have multiple drawings open. So I'm going to come back to my Start tab at the top, and we'll just open up from my recent documents. We have there's our Properties palette drawing. So I'll open that just to have an example. So I now have 2 drawings open, which is our project file and our Properties palette file. So in the Properties palette file, if I open up blocks, we'll see as my project file is open, I have access to all of the blocks from that file. So what I can do, if I wanted to bring that door into this file, I can just drag it in and drop it into place. So it's a great connection between all of the drawings, and it's an ideal place to store our libraries. This just saves you time redrawing information, or if you know that in one particular drawing you have created a block, you can open up that file, use your Design Center to just pull it out and drop it into the new drawing. So I'm going to close down the Properties palette drawing, and I'm not going to save it, so I'll keep the original. Now we have our Histories tab. So anything that we put into the Design Center or pull out will be displayed here in the History tab. So we're now going to focus on the library which Autodesk have already created for us. So to access that, I'm in the Folders tab. Scroll down, we'll see we have Program Files open. We have your version of AutoCAD will be open. We then have a sample folder. And within the sample folder, because I'm using the English version, I have EN. So I'll expand that. And in there we have Design Center. So I'll expand that. So what I'll do is I'll expand the Design Center so we can see the names of all of the files. And here we have a collection of files within our Design Center. To show you an example of what has been created, we have Home Space Planner. So halfway down the list we have Home Space Planner. If I expand that, there we have all of the different headings like we had before. So our blocks, detail view, dim styles, layer, layouts, and so on. If we select the blocks heading, we have a group of blocks which have been created for us. So we have a bed, chairs, a copy machine, telephones, pianos, and various other different bits of furniture. Under the Home Space Planner, we also have House Designer. So we'll do the same, we'll expand it out, open up the blocks heading, and in there we have more sanitary ware and various other different bits of furniture. We also have landscaping. So we have various different trees and shrubbery. There's a hot tub and a car. And then under kitchens, we have all various different blocks to create our kitchen. So we have an oven, microwave, we have an actual kitchen layout, dishwashers, and various cabinets. So they are the basic blocks which I want you to focus on for now. The other drawings are a little bit more advanced, like we have pipe fittings, which are a bit too advanced for the level which we are going to create this plan. We also have HVAC files, electrical files, and various fasteners. So with these blocks, I'm back in the home space planner. With these blocks, what we can do is we can bring them into our drawing. And to bring them into the drawing, the first thing we do is come up to the Home tab at the top, and we need to just change over our layer. The reason being is when we pull the block out of the library and place it into our drawing, it will take on the layer which is currently set to current. So what we need to do is go to our layer select, go down to the furniture layer, make that our current layer. And then once we've done that, we'll come back to the home space planner. And the first block I want to pull in will be the bed-queen. So when we select the bed, we'll see we get a preview image, and below that as well as a short description. So to pull the block into the drawing, we click, hold and drag it. Once it's in the drawing, once you let go of the mouse, the block will be placed in the drawing. So I'm just going to auto hide this down so we can get a better view. And then zoom into the bed. So there's my bed. There's my insertion point. I can pick it up and move it around quite easily. And I'll bring back the design center. So for the next task, what I would like you to do is focusing just on these 4 files. We have home space planner, house designer, kitchens, and landscaping. So within those 4 files, I want you to populate this floor plan. To give you an example of what I have created, if you refer to the PDF, using everything within those files. So this is what I have created. What I want you to do is you can either copy what I've done, but you can also feel free to create your own version. So I want you to spend a couple of minutes populating the floor plan. So if you'd like to pause the video now and do so, and then after that, what I'll do is I will populate the drawing myself and you can watch how I've done it. First thing I'll do is delete out the bed. And then from the design center, I'm going to go back to my home space planner, open up the blocks. I'm going to bring in the blocks which I need. For the kitchen, I choose the kitchen layout, top right hand corner. So drag the whole kitchen layout from the library. So I brought everything that I need from the library into the drawing. So I'm going to auto hide and just reduce it down in size. So I have my clear space back, and same for the properties, just so I have a bit of a clearer space. So then matching the PDF, I'm going to first rotate the tree at the front, mirror it across to get the orientation correct, and then drag it into place. I'm going to move my stepping stones into the front door, copy the first one down, and then from here I'm going to use my mirror tool to mirror down, and then copy, paste. Same for the back garden, I'll move the tree into place. copy up one of the stepping stones. Mirror across. Copy this one up. Mirror this one. And then for the final one, I'll just copy across. Then working inside, I'll move the spiral staircase. And then rotate it around. Bring the dining table in. Then the work desk. Place the computer on the desk. I'll rotate that as well. And mirror so the mouse is on the other side. And then just move it into place. Bring the chair into place. And then rotate. Next is the entertainment unit. Then the coffee table. And the sofa. Then the lamps. Mirror across the table. Then bring the phone in. Place it on the desk. Next we have the table. So with a radius of 700, I then move my first chair into place. And then using my polar array, I'll array the table around the center point, and only 4 chairs. And then we have our chairs in the front. And mirror the second one across. Lastly is the kitchen. So for the kitchen, first I'll rotate it. And then using my explode tool, I'll explode it out, removing the hatching. and then rotate the other side around, mirror it, and move it into place. And then move the final piece into place. So there we have our finished floor plan. Now we have created our floor plan, we have populated it with the furniture. We're now going to move on to our next feature. First thing I want you to do is we're not going to be using the design center, so I want you to close that down and move over to the right hand side of our floor plan to give us a nice clear space, and change my layer to layer 0. What we're going to look at now is something called a hatch. A hatch will fill an enclosed area or selected object with a hatch pattern, a solid fill, or a gradient fill. We use hatching for various different things. One of the main reasons would be to identify certain material types or wall types, glazing as well. What I want you to do first is select our rectangle tool, and we'll just draw in 3 random rectangles. And once we have our rectangles drawn, we'll then come back to our layer select, and then select the hatch layer. So the hatch tool is in the draw panel and it's down the bottom right hand corner. So we'll select our hatch. Once we select our hatch, you'll see the tab at the top changes to hatch creation, and we now have a hatch ribbon. Our first panel there is our boundary panel. So what we need to do first is we need to tell AutoCAD what we want to apply our hatch to. So we have 2 different methods. We have a pick points and we have select. Now the reason I told you to draw a rectangle, we are confident that what we have drawn has no gaps, as when we use the rectangle tool it will create one closed loop. And when we place a hatch, it is extremely important that our boundary is closed. If the boundary isn't closed, the hatch will not be created. So first we have 2 ways in which we can place a hatch. We have pick points and select. If we use the pick points, all we do is we come inside our object, and you should get a quick preview of the hatch within the object. And I'll hover over the middle point as well. So you'll see for the pick points boundary selection, all we do is we place our cursor inside the object. You'll see also by the icon of the tool, the green cross would be our crosshair, which goes inside the object. So it's another tip on how to remember what that feature does. So to apply the hatch, we go inside the closed boundary, 1 click of the mouse, and press escape. So we've just placed our first hatch in the rectangle. We'll now come back to the draw panel, reopen the hatch tool, and this time we'll use the select command. So we'll choose select. And instead of picking the point inside that closed boundary, we have to select the object. And again, the object must be closed. So there we can hover over the rectangle. When it becomes highlighted, we'll click. And once we click, we'll see the hatch inside the rectangle, but you'll also notice that the hatch command is still active. The reason for this is we can continue on and select
additional objects. Once we have created that, we then press Enter to confirm. So using my line tool, I'm going to create another quick square or rectangle. And using my hatch tool, I'm going to now use the select command. So previously we had used the rectangle tool, which creates a closed object with a polyline. If we draw with a singular line, and to create the hatch, we just simply have to select the object. When it is drawn by line, we have to select all of the lines separately. So we have to go select each one of the lines like so. And you'll see that it creates the hatch within. I'll delete that. We can obviously do that a little bit faster by select and use the crossing window and enter. So then just for a quick recap, our pick points would come inside the object. This also works for objects drawn by line. We can also choose select object. So if the object is drawn by polyline, the object is closed, we just have to select one line, which would select the entire object. If it's drawn by line, we have to select all of the lines, either individually, or we can do a crossing selection. What I'll now do is I'll draw a rectangle which is not closed. So we'll see down the bottom here, these lines do not meet, so this object is not a closed boundary object. So when I go to my hatch, go to my pick points, hover inside, click to place, I will get a warning showing that a closed boundary cannot be determined. You'll see the two little red circles there, which are identifying the gaps in the boundary. So what you can do at this point is close it, press escape, and you'll see that two red circles remain. So now I can select that line, join the two together. Now when I come back to my hatch, I can use my pick points and I'm able to create my hatch. After we place our hatch, we're able to select it to come back afterwards and to make alterations. So our first rectangle was the pick command. So we placed our hatch by pick. So then when we select our hatch, we'll reopen our hatch editor and we have our hatch ribbon. And we can now move on to the second panel, which is our pattern. So within the pattern panel, we have various different patterns. Over to the right, we have two arrows which will go up and down by one row, or we can hit the arrow in the bottom right hand corner, which will open up our pattern viewing box. Here we're able to scroll down and we're able to see all of the different types of patterns which are currently included in the library. It is possible for you to also create your own hatch, and that is what this last hatch here is referring to as a user. If the particular hatch you want to use isn't there, you're able to create that yourself. But Autodesk have done a very good job in creating this library for us, as pretty much every pattern which we need has been created. So these patterns are something that you may use or you may not use. It depends on the particular field in which you're going to use AutoCAD for. Each one of these patterns is an agreed upon symbol for the construction industry. So for an example, here we have our concrete. We also have brick, brass, cork, clay, and various other shapes. So once applied to a drawing, once that drawing gets sent down to a building site, and when the construction team look over the drawings, when they see these particular symbols, they will understand what that symbol is for. To be able to change the patterns once placed, once it's highlighted, we can then just open up the palette and select a different pattern, and we'll see that the hatch takes on that pattern. You may also just get a white blob on the screen. There is a very good reason for this, and I'll explain that in the next panel. So then moving on to the next panel, which is our properties panel. To start at the top, we have pattern. So where we have pattern, we hit the drop down arrow. The options we have are solid, gradient, pattern, and user defined. So this is referring to the pattern panel which we have on the left hand side. And if we change over to solid, the only option we'll have there is solid in the pattern panel. Change over to gradient. You'll see then all our options change. And we can access all of the gradient patterns. So with a gradient, what you have are two colors within one hatch. And that allows us to create a 3D style effect to certain parts of our drawing. And then we'll come back to pattern, and there we have full access to all the patterns again. And then the last one is user defined. So this here is where we're able to create our own hatch. Below that then we have our layer and color palette. As we know, good practice is always to have the layer as the ruling factor. We'll always choose our layer as the overpowering factor. So if you wanted to change the particular layer color, you could then just go back to your layer properties and change the color there. But if we keep it on by layer, we also have the option to then change that color, but remaining on the same layer. And we just come down to our color index below. Next one down is our background color. So at the forefront, we'll have our nice hatch, and then to the background, we can change the color if we wish. Next over, we have the hatch transparency, 0 being no transparency at all, and we can increase the transparency of the hatch up to 90. So just coming back to the drawing, I'll give you an example of the hatch transparency at 0. There's our hatch at 0. So then if I change my hatch transparency to say 70, you can see how much lighter and transparent our hatch has become. And I'll revert that back to 0. Next we have angle, so currently at 0. If I give that a 45-degree angle, we're just changing the hatch angle itself. And next is the important one, which is our hatch scale. So currently it's set to 1, and our hatch is being displayed at the correct scale which we want to display. But this doesn't ring true for every hatch. Like we spoke about before, when these were created by Autodesk, they were created all at a particular scale, as they didn't know the final scale which you want to create them at, which would be impossible as there are so many different scale types. So everything has been created at a scale of 1. And for us to increase or decrease the size, it's just hit and miss, just increase and decrease the increments by 5, 10, 20 until you find the desired size. So an example will be, come back to the start, we have solid angle. I'll change my hatch back to angle. And we can see the hatch is quite small. So if I increase that up to 20, we'll see we've scaled up the hatch and it's becoming more clear. And all you'll simply do is just continue to increase or decrease the scale of the hatch until it gives the desired effect which you want to be displayed on your drawing. So you can see the difference from the hatch on the right, which is also an angle, and on the left, it's an increase scale of 50. Next over is the origin panel. We have set origin. And in the center, we have a blue circle, which is our origin point. If we weren't happy with the placement of the hatch, we can see on the left, we have small line, and on the right, that's the beginning of the hatch. we can reset the origin. So we'll select Set Origin, come back into the drawing, and with one click of the mouse, you'll see the hatch will change position. And you just continue to set the origin point until you're happy with how the hatch is being displayed. You can also hover over the circle, and you can also change the origin point a little more accurately. So the origin point then becomes attached to your cursor. By using the preview, you can center the hatch as best as you can to get the desired effect. Also, you have the angle and scale, which we've already covered, and stretch will just pick up the hatch and move its position. Control Z to pull it back. And then coming back into the hatch editor, we have associative. So we already understand what associative is when we were referring to arrays. Now, associative with the hatch is referring back to the boundary. So if associative is turned on, I'll come back into the drawing, double escape. If I select my boundary and change the shape, you'll see the hatch changes with the boundary. The reason is because the associative is turned on. So if I come back into my hatch, turn associative off, double escape, when I select the rectangle and change the shape, you'll see that the hatch no longer retreats back as it's not attached to the boundary. Now that the hatch is outside of our original boundary, it's no longer attached to the rectangle and we've changed the shape, you'll see that associative is grayed out, so we can't make any further changes. What I can do is I'm able to change the shape of my hatch. You'll see I've got the blue grips on every corner, and in the middle I've got my stretch bar. So I can stretch it back, attach it back to the rectangle. We can also grab the blue grips and pull it inside and alter the shape. But once we turn associative off, alter the shape from the original boundary, we no longer have access to that feature. Annotative is something I will cover later on in the course, as we'll focus on the annotative of all objects which we've covered previously. Lastly, we have match properties. So we have our hatch selected. If we wanted to match the properties of a different hatch, we will select match properties, select the other hatch, and you'll see that the original takes on all of the properties of the other hatch. So I will Control Z to bring it back. So when we placed our hatches, the first hatch we placed was using the pick points. And the second we chose the select command. So when we used the select command, we chose both rectangles, and you'll see that the hatches are actually joined together. So this has a lot of benefits in itself. So if you're on a large drawing, you have many different areas which have the same hatch. By doing it all at once, we're able to make changes to all of those hatches at the same time. So for example, we can increase the scale up to 50, and both rectangles will change at the same time because it is the same hatch. So being able to choose multiple options, you're able to do that in both the pick points and the select command. Next, I want you to open up the Hatch Island file. So in the Hatch Island file, you'll see we have three shapes, all the same. And I'm just going to demonstrate to you the different ways in which we can hatch these images. So go to my Hatch tool. So first thing I'm going to do is use my Select command. And I'm going to select the outer lines first. Press Enter. And you'll notice that I've hatched the entire object. So everything inside that object has been completely ignored, and everything inside the rectangle has been hatched. So I'm then going to go back into my hatch tool. If I use the pick points command and come inside the first object, I'll select my first point, enter. The hatch has only been placed between the outer line and the first inner line. So then if I wanted to do every second point of that image, so I could do that quite easily by just selecting the points which I want to hatch only. Like so. So I had to do that by turning the hatch on and then off, on and off, on and off to create it all individually. Because if I go back to my hatch command, use my pick points, and try to do it all within the same set, it won't allow me. So what I need to do is go back into my hatch command. If I come down to the options setting, and what we're going to focus on right now is the outer island detection. So with that, I want you to delete the other hatches. So now that our previous hatchings have been deleted, we can then go back to our hatch command. And in the options section, we have normal island detection, we have outer island detection, and ignore island detection or no island detection. So we're going to go through all of these options. And the first one we're going to choose is normal island detection. So we'll select normal island detection. I'll choose my select boundary objects, and I'm going to use my crossing window to select all of those objects together and press enter. So what we're able to do is create a hatch which essentially hatched the outer section, ignored the next section, then hatched the next section, and then ignored the following, and then hatched the next. And we'll then go back to our hatch and we'll change over to our outer island detection. And we'll choose all of the objects again. And you'll see that we've only hatched the outer section. And then finally we'll do the last one, which is ignore island detection. And that will ignore everything in the middle and just hatch everything within the object. So depending on what you're trying to create at the time, you have these particular options to help you hatch. Because as you begin to hatch objects more regularly, you'll come across these issues where you want to hatch certain parts of an object but not others, but you also want to have the hatch of that object as one object. So here are the different options which you can do to achieve that. So what I'm going to do is just quickly change back to layer 0, and I'll draw two quick rectangles, and then go back to my hatch, and we'll choose our hatch again and use our select command. So before we selected two objects together within the same hatch action, and what that will do is we'll have two different objects. We'll have two objects but with the same hatch. So there may come a time within your project where you no longer want those objects to be within the same hatch. And what you're able to do is you're able to break up that hatch, so you'll have two separate hatches. And to do that, you'll come back to your options section, and here we have separate hatches. Once we activate that command, you'll see that now both our hatches, which were joint hatches, are now singular hatches. And we're now finished with this drawing, so you can close it down and don't save it. I'm going to delete off those hatches which we've just created. And we're now going to apply hatching to our drawing. First thing we're going to focus on is the garden area. And you'll notice down at our entrance to the garden, we have a gap which needs to be addressed. All we need to do is, using our line tool, we just draw a line right across the door, which will then close in, creating the boundary for our hatching. And same for the back door. Once we've created that, we can then go to our hatch tool. And the hatch which we want to apply here is the grass. So I'll scroll down until I see the grass hatch, which I'll select. And I'm going to use my pick points tool. Come into the garden, hover the cursor in the location, click to place, and just wait for the hatch to generate. Once it does, you'll notice that the scaling is off. So at this point, we then come back to the hatch ribbon in the properties panel. We can then increase our hatching up by 5, 10, 15. So I think a scale of 10 looks about right. Once complete, then go to close hatch creation, press escape, and there we've placed our first hatch. Next, we're going to place a hatch within the external wall. And we'll come back to our hatch command. I'm going to scroll up to the top, and for this one, I'm going to choose the ANS137. If you don't have this particular hatch, just choose something which is similar. So I'm going to select it. And what I'm going to do is I'm going to apply the hatch all at once. So all of the hatch will be joined together. So then I'm just going to work my way around the drawing. And you'll see that I have to go twice in each point because of the grid line. So what we can do is we can press escape, delete what we've drawn, come back to my layer selection, and I'm going to just turn off the grid lines. This will just speed up the process and save us a little bit of time. So now we go back to our hatch, choose the same hatch, and then we're going to work our way around. So just placing the hatch within the external wall. And if you're having any issues where there's no hatch boundary, just refer to your warning. Look to see where you're getting those 2 red circles and then fix the issue. If you're not able to complete everything in one go, for whatever reason, you can do each point step by step. So I want to increase the scale of my hatching because I find it a little bit too dense for what I want to show. So I'm going to increase that up to 20. We'll try 30. So I think 40 looks just about right to what I want it to be displayed. So I press enter to complete everything. And there we have hatching within our walls. Last hatch we're going to apply will be a concrete hatch to the concrete columns. Come back to our hatch. We go to AR-conc. And again, we'll apply to all of the columns at once so they're all joined together. Enter to finish. So if I zoom in, it looks fairly solid because of my scaling. So if I select the hatch, so there I've set my scale to 1. If the hatch has frozen and you're still seeing a solid block, just change the hatch and then bring it back to concrete and it will refresh. What we'll do is we'll also put in a hatch for the internal walls. And for this one, we'll just come up to the second ANS 131 and apply it to the internal partitions. And then come back and adjust the scale. There I have set the scale to 40. And also one trick I want to show you, if you come back to one of the concrete columns, if you want to make that scale smaller again, as we're set it to 1, what you can do is you can bring it down to decimal points. So 0.5. I can go 0.05. If you've reached scale 1 and you're still not at the desired scale, just bring it back down to a decimal point. So I want you to move over to the right hand side again, and we will change over to layer 0. And I want you to draw 3 rectangles again. And we'll then change our layer back to hatch. Once we have that drawn, we'll go to our hatch command. And instead of applying a pattern, this time we're going to be applying a gradient. So I'll show you the various different types of gradients and the effect which they can achieve. The first one will use the GR linear. So I'll just click to place like we've done before, enter to finish. So then when I reselect it, we'll see that the ribbon is the same as before. The only difference now is in our property section. Instead of being pattern, our hatch type is gradient. Underneath that, we have our color 1 and color 2. So color 1 is blue, which we see on the left, and color 2 is yellow, which we see on the right. We still have the option to add a hatch transparency, and we can also add an angle. So our different gradient patterns will achieve a different effect. The first is our GR linear. Second, we have a GR cylinder, and then inverted cylinder, sphere, hemisphere, curved, inverted sphere, inverted hemisphere, inverted curve. So keeping it with the GR linear, if we wanted to alter the effect, we can come to the angle, and we can change the angle of the gradient, and you'll see that the effect will change. So yellow is pushing more up to the top right, and blue is pulling more down to the bottom left. So changing over to the GR cylinder. So by having the gradient of the blue mix into the yellow and having the yellow more prominent in the front gives off the effect of a cylinder. So we would then pick and choose the gradient which would apply best to what we wanted to use it for. Some things about the gradient. When applying them, if we apply the gradient to one of the objects, the effect will take place in that particular object. If we apply down to the same gradient, if I apply to both objects at the same time so that the hatching is joined as one, you'll see that the gradient will spill between the two objects. So this is something to be mindful when placing the gradient on what particular effect do you want to achieve. So I'll change over to the GR curved. When we select the gradient, you'll notice a blue circle in the center. What that is our origin point. So I'll come back to the first gradient and I'll change it back to the GR linear. So we can control the origin point to alter the gradient. So first thing I'll do is turn off centered. So each side of the gradient is no longer being centered on the blue dot. If I click it once, what I'm able to do is pick it up and place it in a different location. But what I want to do is I want to change the origin. So what I need to do is click the blue circle, and I click the Control key once, which changes the function of the blue circle from stretch to changing the angle. So you see, as I move my mouse around the object, we're able to change the desired effect of the gradient. And when we apply the same technique to our right-hand gradient, you see we're able to add more yellow or blue to a particular corner, again changing the effect of the gradient. Now, one good example of where we could use this would be in our windows. So what I will do is create a quick rectangle, and I'll just copy and place. I'll do 4 by 3 rows. So we could imagine this is the elevation of our building. Very crude drawing of where the placement of the windows would be. And if I was to then come to my hatch to create the gradient, first thing I'm going to do is I'm going to do the GR hemisphere, and I'll do each window singularly so you can see the difference within the effect. So I'll do 1. So I need to place each gradient singularly. And then I'll copy up the last row. So when we place the gradient on each window individually, it'll apply the same pattern across the board. But in a real world scenario, if we had a reflection on a window, we wouldn't see this reflection from the sun on each individual window. We'd see it all as one piece. So what I will do is I'll now just select all of those and delete them. And now that we have it clear, I'm going to go back into my hatch. Select the GR hemisphere and do all windows together. So you can see the difference in the effect by doing all windows as one and having the hatch joined together. We can change the angle of our gradient by, again, just selecting the blue circle and hitting the Control key. So we can position the sun's appearance in a different corner of our windows. Next, I want you to open up the file Hatch House. So in there, you'll see on the right hand side is a completed elevation of our house. And what I'd like you to do is to replicate what I have drawn on the right over on the left. So you're going to use various different hatching types, and you're also going to be changing the color of the hatch, but keeping it on the hatch layer. So if you'd like to pause the video now and try that yourself. Okay, so first thing I'm going to do is work on the bottom. Here we have our earth. So I'll come to my hatch, find the earth hatch, place it. First I'll change the color 1 to by layer, and we'll change our background color to the 198, 178, 169. And you'll see that we also need to adjust our scale. So I'll come up and I'll change it to 5, 10, you can see it's getting bigger, 20, 40, 50. So 50 looks like it is correct, judging between the two. So I'll stick with 50. Next we'll do the solid ground just above. Again, coming back to the hatch. Change our hatch over to solid. And our line 1 is the 95, 73, 63. And click to place. Next I'm going to look at the rendering on the outside of the building. Come to our hatch. For this one I'll apply the concrete hatch. And there's going to be no background color for this one. And we'll just keep it on the bi-layer color. So I'll hatch each section of the bay window. And the scaling looks to be correct. I'll then pull over to the right and we have our brick pattern. So I'll come back to my hatch. And I'll change over to the ARB816C. And click to place. So the scaling looks correct and it's on the bi-layer, which is what we want. Press enter. Next we'll work on the gradients. So first thing we'll do is the window in the front. So we'll go to gradient. We'll use the GR hemisphere. Click to place and enter. Next we'll work on these 4 tall windows. And they are all sharing the same hatch. So we'll do all 4 windows at once. And the pattern is the same. And next we'll do the bay window. And then we'll do the bay windows to the side. And we'll have to change the angle of each one of those. So here I just placed one hatch. I can then go back and match the properties. And now to change the angle, select the blue, hit the control key, and then I want the blue in one corner. So we'll give that an angle of 315. And same on the other side. Lastly, we'll just do the main window, which is all one hatch. So there we've created all of the hatching. So one issue you might have is your hatch may be sitting above the lines and it might not be as crisp as you want it to be. So to demonstrate that, what I'll do is I will first bring my hatch to the front so you can see what I mean by this. So I come to my options, I'll select bring to front, and you'll see that my hatching is sitting over the window lines. and it doesn't look as crisp anymore. So this can happen when you place a hatch as well. So what we want to do is we want to push the hatch back so the lines sit above it. So we'll go to our options, hit our drop down menu and send to back. Now you see our lines are at the top again and our hatch has been pushed back. So I want you to close down this drawing, and again, don't save it, so it will go back to the original file, so in the future you can reuse it. And once back in the project file, we can delete our practice hatching. So we're going to continue on building up our project, and the next thing we need to do is we need to be able to annotate our drawing. And we can do that by placing text to identify certain rooms or places within our drawing. So before we place text in the drawing, we must first create a text style. And before we begin anything, we're going to as well change our layer from hatch to text. So go to our layer select and select our text. At the beginning of the course, I'm going to only stick to the Home tab and show you all of the quick panels here where all of our annotation features are. As we progress, I'll pull you into the upper tabs where, for example, in the Annotate tab, we have more features which we can use to create annotation. But first I'm going to stick with the Home tab so you can get familiar with the features attached to it. And within the Home tab, having all of our drawing methods, modification tools, annotation and layers all within one ribbon allows us to create a drawing very quickly. So we're going to look at our text. Here is our tool to place our text. But the first thing we must do is to create a text style. The reason being, if I just go to place some text now, you'll see it's very small and we can't read it on our drawing. As I said before, all of our defaults are essentially set to a scale of 1, which isn't legible at our current scale. So I'm going to quickly delete that out. So to create our text style, we'll come to the Annotation panel. And at the bottom there we have a little drop-down arrow, so one click of the mouse will open that up. And our first one there is our text style. To the right of that is where we would then select our styles once we create them. So to open up the text style manager, we'll click the symbol. So the text style itself controls the appearance of the text. So we can control the font, the line spacing, justification, and color. So in the dialog box here, at the top, it'll tell us the current style, which is standard. So there we have it selected in blue. Underneath that, we have our style window. So all of our different styles which we will create. And by default, you'll only have two. You'll have annotative and standard. The annotative is something we'll cover later on in the course. So for now, we'll stick with the standard. Down below, we have it'll be like a filter. So when we have all styles, it'll list all of the styles that are created within the drawing. But we can change that to styles in use. So if we have, for example, 20 various styles which were created, but we're only using 3, those active styles within the drawing, if we choose to filter styles in use, they will only be displayed. So you'll only need to do this if you have quite a number of styles within the drawing and you just wanted to find the ones which were currently in use. Below that we have a preview box which will display the style. So we're currently being shown the standard style. Moving over to the right we have our font. So under font name, we'll hit the arrow to open up the selector. And here we have all of your basic fonts, which you'll be more than familiar with from other programs. Arial is the most commonly used font in AutoCAD and generally in construction, as it is the clearest font to read on a sheet. You have various different types of Arial then, like Arial Black and Arial Narrow. So beside the font name is a TT symbol, which stands for True Type Font. So by having the symbol beside the font name, we're now confident that that is the true type font, which is Arial. If we scroll down, we have a txt.shx. So these are the original fonts for AutoCAD, and they are known as shape files. So the .shx is a shape or font file, and these are the original fonts which were created for AutoCAD. To give you an example of how they appear, when we have a true type font, if we look at our Arial in the preview box, if I change it over to the TXT, we'll see the difference in the font type. The original alphabet was drawn manually, so the lines will appear very primitive, straight lined, and before true type fonts were introduced, this is all that we had access to. So I'll just revert it back to the Arial. The remaining features are very similar to other software. So we have our font style. We can have it in bold, bold italic, italic, and regular. So we'll see bold will thicken out the lines. Bold italics will have a thicker line and a slant. Just italics on their own will just apply that slant to the text, and regular will be the regular font type. Next, coming down to the next section, we have the size of our text. So this is something that is very important to pay attention to in AutoCAD, because we essentially have an infinite amount of space within our drawing. Once we go to annotate our project, we can print our floor plans at various different scale types. The reason for this is we can have an A0 size sheet, so we can have the floor plan as big as we can onto that sheet. We don't want our text to scale up that big as well, so it will be too big on our sheet. We can adjust its scaling so the text remains the same height, regardless of what size the floor plan will be. So if we wanted to print our floor plan on an A4 sheet, we would want our text height to reflect that scale. So the first thing is the annotative. Again, we will cover this later on in the course. We'll just keep it to the basics for now. What we'll focus on next is the height. So with our height, what we have to be mindful of in AutoCAD is how we want our text height to appear on our sheet of paper. So your typical construction standards will be 2.5 millimeters high as a minimum. For some unique text, you could reduce that down as far as 2 millimeters, but I'd advise you not to go any lower than that, as the text will be too small to read on the sheet. So when we're printing our floor plan, we want to assign it the correct scale so we can fit it onto our sheet of paper. And with that, we must then multiply that scale to our text height so it'll appear the correct size on our floor plan. So for example, on our sheet that we're going to print, we want it to be 2.5 millimeters high, but the scale of our floor plan, we want it to be scale 1 to 100. So what we do is we multiply our scale by our height, so that gives us 250 millimeters. So in our model space, we will apply a text height of 250 millimeters. And when it appears on our scaled sheet of paper at scale of 1 to 100, the text appears at 2.5 millimeters when printed. So this is where we would change our height. What we can also do is we can put our text upside down. We can flip it backwards. And we also have a width factor. So it's currently set to 1. So if I increase that out to 3, you'll see that the text widens by a factor of 3. By 2, I can also bring it down to 0.5, which will decrease the width. So we'll just revert that back to 1. I can also add an angle to the text, so say 30 degrees, 60. I'll bring it back to 0. So within AutoCAD, what we want to do, like we did with our layers, is we'll keep one text as our default text style. So then when we go to create a new one, we'll use that as our base. So like with the layers, we used our layer 0 as our base. Within text style, we'll use our standard. So we'll just make sure that our standard text shows Arial as the font name, the font style is regular, height is 0, the width is 1, and the oblique angle is 0. And if you've made any changes, just click on apply to ensure that that remains as our default. And what we're going to do is we're going to create our own. So over on the right, we have 3 options here. We have set current, new, and delete. So once we're finished with our text style and we want to use that text style, we must set current. So we must set that new text style to be the current text style. Below that we have new, which we will select in a few moments, which will create our new text style. And below that is delete, which will obviously delete one which we've created. So we'll select our standard, come over to the right and select new. We're then being prompted to create a name style. So this again is something to be mindful of. If you're already working for a company, I'm sure that they have CAD standards and they will instruct you on how to name text styles. The reason you want to have a common standards is you're going to have many different types of text styles and you want to be able to find the correct one quickly, and you want them all to maintain the same standards. If another person was going to use your drawing, they're able to navigate it easily and understand exactly what type of text style that is. And what I'm going to do is keep it very basic for this particular time, but this is something that you need to find out if you are currently working for a company. So how I'm going to name my text style is I'm going to use the font name followed by the scale that I want to set. So the font name that I want to use will be Arial. So we'll start off my name with Arial. And I want my text scale to be set to 1 is to 100. So I'll type in 1 is to 100 and press OK. So the font name will keep it to 100. I want the style to be regular and I'm going to change my height. So like we spoke before, my final text height on my sheet of paper will be 2.5 millimeters. And in my model space, I want to scale that at 1 is to 100. So we'll multiply 100 by 2.5 to give us 250 millimeters. We'll press apply. And finally, we just want to make that our current text style. So we'll select Arial 1 to 100 and set current. Once we've done that, we'll click on close and we're back in the drawing. Now that we've created our text style, we can now look at placing our text. So back in the annotation panel, we have the capital A, which is our text tool. And if I hit the drop down arrow, you'll see that we have two different types of text. We have single line text and multi-line text. So for the single line text, we use that for short, simple notes and labels. And the single line command also is very basic within its properties. So we'll place our first single line of text to demonstrate this tool. So one click of the mouse, I'll move over just to the right hand side of the floor plan. And we're being asked to specify the start point of the text. So one click of the mouse. I'm then being asked for the rotation angle of the text. So we can either specify that with the mouse, so one click of the mouse we can specify that. We can also manually type in the angle, but we want to keep it at 0, so I will just press enter at 0 degrees. And we can then begin writing our text. So I'll type in sample text. To then complete the text function, we'll hit the enter key. And we'll do that again. So we'll go single line, click to start, enter at 0 degrees. I'll then type sample text. So with the single line text, if we wanted to quickly create an additional line of text when we are currently in the active text, we'll just click on the mouse, we'll continue on, and we can type more text. So you have full function of using your window keys. So if I turn on my caps lock, I can create a caps text and we'll complete. So when we select the text, you will see that in the bottom left hand corner we have our insertion point, and with that we can click it once, it'll attach to our cursor, and we can move it around and place it to a new location. You can also hold the control key to copy the text. If you've noticed that you have misspelt some text, how we can alter that is we'll double tap the text. That'll bring us back into the text editor where we can make changes, and then just either click outside of the text or enter. So we'll come back again to select our single line text. And what we're able to do when we create our single line of text, if we press the enter key, our text will come down a line and we can write a second line of text. And again, pressing enter, bring me down to write a third line of text and double enter to finish. If we come back, we'll notice that each one of the lines of text are singular. So they are single lines of text, which is the name of the command. So again, the purpose of the single line text will be for short, simple notes and labels that will only require a single line of text. So a use for that would be just labeling a living room, kitchen, bathroom, just something quick, short, and simple. So this is a very basic form of placing our text. If we wanted to include paragraphs of information and also be able to manipulate the text further, what we'll use is the multi-line text. So come over to the right hand side, change over to the multi-line text. As we have the capabilities to create a large amount of text, instead of just placing our initial part of text, we need to create a text window. So just give yourself a bit of space with this. It doesn't matter if you need to add in more text than the size of the window you've created, because we can increase that size afterwards. But just to get started, give yourself a good sized window to get started. So first thing you'll notice is at the top, we now have a text editor tab showing a new ribbon. So you can see first off, we're able to change our text styles, which we've just created. There's our Arial 1 to 100. So at this point here, we have access to all of the styles which we would create in the future, and we can change it at this point. Some basic information that I'll just stick with for now. Later on, we will go over all of the information further on in the ribbon, but for now, I'll just stick with the formatting panel. So what we're able to do is we're able to make that text bold, italic, underline. We can add a strike through. We can add superscript, subscript. We can change the case from upper to lower. We're able to change our font. We can change our color, and we can change our layer. So we have a lot more features available to us when we use the multi-line text. So when we want to write our text, when we press the Enter key, we will just continue on writing our text. And when we complete, we'll just go outside of the text window, one click of the mouse. And now the difference between our single line text, which I have on the left, where each piece of text is singular, when we have our multi-line, it is all joined together in our text window. So as I said before, once you create that window, it's just to begin with. If you had further text to include in the window, you'll just use the grips to extend it down to the left, to the right, to narrow or widen that text window. So if you reduce the window down, you'll see that the text will jump to fit within the window. And then to access it, you'll just double click. It'll bring you back to your text ribbon, and you could continue working with it. You can edit. So what I'd like you to do is to create the labels for each one of the rooms. So at this point, I'll give you the option if you can choose either the single line text or the multi-line text, but we want to place text to label the kitchen, garden, living space, and dining room. So I'd like you to try that, please. Okay, so we'll label our rooms. So the hotkey for single line text is text. And then click to place. I'm going to have my caps on so the text is nice and big, and I'll name my kitchen. Double enter to complete. And then what I'll do is I'll click on the blue square, hold Control, bring my text over to the right, and one click, bring it down to the bottom, one click, and I want to copy the lower text across so everything is kept in line. So it's just a quicker way of creating our text at once. So we have our kitchen, garden, could be living space, could be living room, that's up to you. And we have our dining room. And you could then move your text around if you're not happy with its location. Lastly, I'm going to select our sample text and delete it.
Next on the list for the annotation will be our dimensions. So dimensioning a plan is a very important step in the construction process. So we need to identify all of the widths and lengths and locations of all of our components which we have just drawn in our project. And to do that, we use our dimensions. So just like our text, we first need to create a dimension style. So what we'll do first is change over our layer from text to dimensions. And we'll then go to the annotation drop-down arrow and we will select our dimension style. So this will open up our dimension style manager, very similar to our text style manager. It'll show the current dimension style which is active, shows a list of all of our styles. We have the option of how we want to list them. We have our preview in the center, and we have set the current, create new, modify an existing, override an existing dimension style, and compare dimension styles. We also have a description box to describe that particular style. So we have the annotative, which again we'll cover later on in the course. And we have ISO 25 and standard. So what we'll do is we'll change over to our standard. And we want to keep our standard as it is. So what we're going to do is we're going to create a new dimension style. Then I'll take you through all of the different steps on how we can modify that style to create a style which we can work with. So we'll click on standard, click on new. So that will open up our create new dimension style dialog box. And the first thing is to name the new style. And again, refer to your company's standards, but for this course we will call my dimension style dim, DIM 1-100. And then below that we have start with. What dimension style do we want to be our base? And we want the standard to be our base. Annotative is something we'll cover later on. And what do we want to use our dimension style for? We have all dimensions, but we also have a series of particular dimensions which we'll cover later on. We'll then go and continue. And now we're able to modify our dimension style to create our very own. So I'll take you through all of the different tabs and all of the different settings which we can change. So our first tab is the Lines tab. So what the Lines tab is referring to, if you come to the preview box, we'll see the lines which are protruding out from the object in the center. So we have full control over how we want them to appear. First we have our dimensions line, which is referring to this line in the center. So it's running the full dimension length of our object. First option we have is the color, and we want our layers to control everything. So I'll go by layer, and we'll see our dimension line changes from white to red. And we have an option to change the line type as well. So we have all of our different line types which we were using before. We could then change that here. But it will be easiest if you allow the layer to control that as well. And same for the line weight. We can apply a particular weight to that line. But for this we will choose the by layer, so the layer will have complete control over the line weight as well. Next we have extend beyond ticks. That is referring to the additional line which will extend past this extension line. So if we wanted to have an additional line to go past that, this is where we then determine that. Our baseline spacing is referring to a feature which we'll cover later on in the course. But what we'll do is we'll change that to 1. This will become more apparent as we use this feature later on in this course. Next, we can suppress the dim line. We can suppress the first dim line or the second. So if I turn dim line 1 off, you'll see I'm able to suppress dim line 1 and dim line 2.
And then moving down, we have our extension lines. So these white lines here, they are our extension lines. So same as before, we have full control over the color, line type, and line weight. We want the layer to control all of that. So we see now all of our lines are red. And we can suppress extension line 1 and suppress extension line 2. Next, we have extend beyond dim lines. So from our dimension line, how much do we want the extension line to extend past that dimension line? It's currently set to 0.18. I want to up that to 1. This will all be made more clear as we fine-tune the rest of the options. And then we have offset from origin. So the origin is where it will attach to our object. And for this, I want that to also be 1. So the preview of what we're trying to create will begin to look a little unusual. But as we continue to change all of these settings, it'll become more clear what we are creating. Next, we have a fixed length extension line. So that extension line, we can apply a fixed length to that, which is what I want to do, which will be 1. If we didn't have a fixed length, when we apply our dimension line, when we move the dimension line away, that line will continue to increase until we place our dimension. Okay, so we'll move on now to the Symbols and Arrows tab. So looking into the preview, we currently have the arrows. And within this tab, this is where we're able to change those symbols. So the first one is the arrowheads section. And if we click on first, we have all of the different types of arrowheads which we can choose. And at the bottom, we have either none or a user arrow. So if there's one particular type of arrowhead which you want to create, you can create that, save it, and load it into this section. But generally, all different types of arrowheads have been covered here. The one which I want to choose today will be the architectural tick. And you'll see that the second one will automatically change to the architectural tick. But if you wish, you could have 2 different types of arrowheads. So if you wanted, you could have the architectural tick as well as a dot. Just change that back to architectural tick. Next is our leader, which is referring to essentially which will point to a particular piece of information. We'll cover more of this later on. So we'll leave that a closed field. And then we have the size of the arrowhead. I want to up that to 1. So the reason that our preview is becoming a little unusual is our scaling is off. So that's why it is looking rather strange right now. Next we'll come down to center mark. We have none, mark, or line. That is referring to the center point of the circle. So it's currently showing that is a mark. We can change that to none. And we can have just a line. So we'll leave that on mark. Dimension break is referring to a feature which we'll cover later on in the course. And we'll just leave that at 3.75. We then have arc length symbol. We have the options of changing to preceding dimension text, above dimension text, or none. The arc length is something, again, we'll cover later on in the course, so you'll see that in action. And we have the radius jog dimension. So when we are applying a radius dimension to an object with a radius, for example, here in the preview, we can see it is attaching to the radius of this curve. And we have the jog angle coming out at 45 degrees, and then coming into our text. And there we can change the linear jog dimension, so we also could change the height factor of that text. We'll now move on to the text tab. So first panel is our text appearance. Here we can change our text styles. So we have our annotative, the Arial 1 to 100, which we created earlier, and our standard. So if I choose my Arial 1 to 100, we'll see that my text is now huge and that the dimensions have gone very small. I know that they've gone very small is because I can no longer see my extension, nor can I see my architectural tick. It just appears to be a line. The reason for this, if we come back to our text style, at the end we have this gray square with 3 dots. If we click that, it'll open up our text style manager. So what we are doing is we are applying a text height of 250, and we are applying that to an overall scale of 1. So our text height is essentially too big for what we're trying to create. So what we need to do is we need to create an additional text style, and we will set it to 0. And when we set the text height to 0, we can control the new text height in this dimension style manager. So we'll create a new text style by selecting that gray square with 3 dots. We'll select standard, and we'll then create a new text style. This one we'll call Verdana 1:1, and press OK. The reason I'm choosing Verdana is just so we can choose a different font name, no particular reason, just so we can come in and alter this font name. We'll choose Verdana. And so the important thing here is to keep the height at 0, 0. Press apply, select our Verdana. So we'll press apply and close. So now our text style, which is Arial 1:100, you can see here, if I come down to our text height, it is set to 250. It's also grayed out, meaning that I cannot change the text height. So what we need to do is open our text style selector, come down to the Verdana, and now our text height, we have the option to change it. So for the text height of our dimension, I'm going to reduce our text height down to 2 millimeters. The reason I want it to be 2 is because we're trying to fit in a lot of information into a small area, and 2 is the lowest that we want to have on a sheet of paper. So I'll type 2, enter. Our preview is starting to make a little bit more sense. So how do we want to control our text appearance? So with our text color, we want our layer to control that. And underneath that we have fill colors. So do we want a backing color to that? I'll show you an option. I'll just add yellow so we can see we can add a fill color or backing color to our text. I'll keep it at none just to keep it clear. And we can also draw a frame around the text if we wanted. Next we'll come down to text placement. So how do we want our text to appear on the screen? So all vertically placed dimensions, how do we want our text to appear? So we have centered, and if you watch the preview, when I choose above, it'll go above the dimension line. We can go outside of the dimension line. We can go below. So the JIS is referring to the Japanese Industrial Standard. So if you don't have to comply with the JIS, we can just choose either above or below. That's up to you. But for this text style, I will choose above. So where we have horizontally placed dimensions, again, we have those options. Do we want it to be centered? Do we want it to be at extension line 1? At extension line 2? Over extension line 1 or over extension line 2. So I'll keep it centered. How do we want our text to be viewed? So we have our view direction from left to right. We also have right to left. And we can apply an offset from the dim line. So how far do we want our text to sit above the dimension line? We can increase that up to 1 unit. And we then come over to the right where we have text alignment. Do we want our text to always be horizontal? Do we want it to be aligned with the dimension line? Or do we want to go for the ISO standard? So the ISO is referring to the International Organization for Standardization. And again, if you don't have to comply with that, it's not necessary. So
For this particular text style, we're going to go with aligned with dimension line, and we'll then move on to the fit tab. So first is our fit options. So the purpose of the fit tab is when the dimensions are in a particular area where there isn't enough space for both the text, the arrows, or the extension line, how do you want the dimension to act? So we can have either text or arrows will best fit, or we can have the arrows will be priority, or our text will be priority, both text and arrows, or always keep distance from extension line. I want to keep either text or arrows for the best fit. And we can also suppress arrows if they don't fit inside the extension line. I'll turn that off. So for our text placement, so when the text is not in the default position, where do we want it to be placed? So as currently you see at the top here, we have beside the dimension line, we have over the dimension line with a leader, or over dimension line without a leader. So for this style, I want to go beside the dimension line. And then over to the right, we have scale for dimension features. So annotative, we'll cover that later on. And we'll come down to the use overall scale of what. So our final scaling on our drawing sheet that we're aiming for and we're creating all of our text and dimension styles for will be a scale of 1 to 100. So our overall scale here will be 100. So now that we've set our scale here at 100, when we have our text height here of 2, when it appears in our drawing, the text height will actually be 200 in our drawing. Then last in the fit tab, we have a fine tuning section. So we have place text manually. So when we place a dimension, there are 3 steps. You choose the first point, second point, and then place the dimension. If we have place text manually, the 4th action will be placing the text. This option will really slow you down because when you're dimensioning a project, having to place the text every single time will be an extremely long process. But if for any particular reason you want it, you can create an additional dimension style and use that feature. That's not a problem. But we will leave that off. And you can also draw the dimension line between the extension lines. Again, to do that for every single dimension will just be a very long and tedious process. Next, coming over, we have our primary units. First is our linear dimension. So our unit. We have scientific, decimal, engineering, architectural, fractional, and Windows desktop. I'm working in a metric environment, and within that we'll use the decimal system, which works best for construction. So in my environment, creating construction plans, we will use the decimal system. But if you're using AutoCAD for a different field, you have this option. So you can choose scientific. We have engineering, architectural, which is more of a imperial version, so it's showing feet and inches. And with that you have fractional. So we'll continue on with our unit format as decimal. And then next we have our precision. How many zeros after the decimal do we want? This is up to the standards which will be set by either your company or that particular job. But typically in my working environment, we set our precision to 0 because we work in millimeters and we work up to tolerances of 10 millimeters. If I have a distance of 10.5, 0.5 of a millimeter is obsolete. As my total tolerance is 10 millimeters, there's absolutely no point for me to ever go beyond 0.0 of a millimeter. So I'm going to choose a precision of 0. If we did choose 1 point after the decimal, we can also choose what type of separator do we want. Do you want a period, comma, or space? That's irrelevant as I'm choosing a precision of 0. So next we have round off. So when it's set to 0, we have 1129. What we can do is we can actually round that up to create either 1130, or we can round it up to 5. So as I said before, just in my experience working in construction, I would round everything up to 5 millimeters. Everything is designed with a 10 mil tolerance. So rounding everything off to 5 just really tidies up your drawing and makes it clear. And it also makes it clearer for the construction worker on site. We can also add prefixes or suffix to our dimensions, meaning that we can add something before the dimension or after. So for example, if I put R, we can have R in front of all of the dimensions. And if we wanted, we can have, say, mm for millimeters after every single dimension. Next is the measurement scale. So this applies primarily to legacy drawings, which is something we don't cover. Next, the zero suppression is referring to feet and inches, the imperial version. Again, it's not something that I cover in this course. And next are the angular dimensions. So we can change our format. We have decimal degrees, minutes, seconds, gradients, and radians. You also have the option of your precision. And that's as far as we're going to go with the dimension styles, as the remaining two aren't relevant. So to finish off creating the dimension style, we'll press OK. There we have our dimension style created in the dimension style manager. We'll set that to current and close. So now we've got our dimension style created. What I want you to do is to save this file. So we'll come up to our save command, and I want you to now open up the file dimensions. Okay, now that we have our dimensions file open, we'll come to our layer select, change over to dimensions, and in the annotation panel, we'll hit the drop down arrow. There we have our dimension style. We'll come over to the selector, and there's our dim 1 to 100. So the reason it is in this file is just because I've created it for you, so that's why it is there. And what I'm going to do now is I'm going to take you through all of the different types of dimensions. So in the annotation panel, first thing we have there is a big giant dimensions tool with the star or sun. So this one I'm going to leave to the end, and you'll see why at the end. So over on the top right, we have what is linear, and then a drop down arrow. So there are all of the different types of dimension styles which we can use. And the first one I'm going to show you is the linear dimension. So when we have our linear dimension active, we'll notice on our dynamic input, what it's telling us to do first is to select the point which we want to dimension. So the first point I want to attach to is the beginning of that line. I'm looking for the end point, which is our green square, one click of the mouse. And I'm then looking for the second point, which is the end of the line. Again, looking for the green square and second click of the mouse. So we've just placed an accurate dimension across the length of that line. And I know that because both points were attached to the endpoints, which is the green squares. And I then just have to place my dimension. So you see the third action is to place the dimension. And I do that by finding the point at which I want it to be roughly placed. One click of the mouse will place that dimension. So I'll zoom in for better clarity. So that is our dimension. When I select it, you see we have all of these different blue grips. So the first one is our first point which we placed, and there's our second point. Our next grip is on our dimension. So one click of the mouse and we can move the dimension if we're not happy with its placement. Same on the other side. Does the same action. And then in the middle we have the blue grip on the text. So one click of the mouse and we can move the dimension with the text.
What we're also able to do is we can still change the dimension if we're not happy with it by using the grips. And they must be the grips which are attached to the object. So one click of the mouse and I can pick it up and I can relocate it. For example, I'll go to the midpoint of this line. So now it's showing the dimension of the end point to the midpoint, which is half the line at 2500. And I can, again, one click of the mouse, pull it back to the start to relocate our dimension. But you'll see that our text has stayed over on the right-hand side and isn't coming back to its original position. So how we're able to change the position of our text is we'll hover over the blue grip and it will bring up an additional menu. So we'll go through each one of those points. First one is stretch. So hover over the blue grip, come down to the menu, click stretch, and you'll see I'm able to move the text along the line of the dimension. I could find the midpoint and place it back to where it was. We'll then move on to the next one. So hover over the blue grip again, and we have move with dim line. So one click of the mouse. And it's essentially the same as the stretch. So the text is moving with the dimension line. And then hover over again, pulling up the menu. We can only move the text if we wish. So move text only will only move the text. And then we have move with leader. So you'll see this line will appear at the bottom of the text and will shoot back to the original position. So this is called a leader. It essentially just points down to a particular bit of information. So we're able to use that as our new point of information. So these are very helpful if we have a lot of dimensions which are tightly compact, and we use this so we can clearly note where that dimension is. We have moved the dimension above the dimension line. And we have it center it vertically, so it's now centered within the dimension. And lastly, we have reset text position. So it will bring it back to its original position. So that's our linear dimension. So the linear dimension will only be across the x-axis or the y-axis. And what that means is when I again choose my linear dimension, if I wanted to get the dimension of the line from this point to the end point, like so, it's going to remain on the x-axis or the y-axis. So it's not going to give me the actual length of that line. It's going to give me the distance from the bottom to the top, or from the position of the start point to where it would come down across the x-axis. So the linear dimension is only on the vertical or horizontal axis. And we're able to change that just by moving the cursor in the direction we want it to appear. So I'll move over to the next one. And we'll change over to aligned. So the aligned dimension will be parallel to any line at any angle. So to get the length of this line, we'll use the aligned dimension. So we go from one endpoint to the next, and you'll see that the dimension line remains parallel to the line. So again, using the aligned dimension, place it on the angled line, the dimension one, we can place it parallel to that line. We could use the aligned dimension on the horizontal lines, because this dimension will just simply run parallel to that line. You can see if I want to place this dimension, I'd want that dimension to run in the same line as this dimension here on the left hand side. So for example, if I place my dimension there, it looks a little bit untidy as they're not on the same line. So when placing dimensions, what we can do is on our third step when placing the dimension is just snap it back to the other dimension, and they are now aligned directly. Next we have angular, so we'll just measure the angle between the two selected objects. So we'll just choose both lines and then place our angled dimension. So choose our angular dimension, choose the top line, choose the bottom line. So we could either show the angle on the inside, or we can also choose the angle on the outside. So show it inside or to the bottom or top. So just by moving the cursor, so just move the cursor until we have our desired angle. And we'll move over to the next. Next we have the arc length. So we'll choose arc length, select our curve, and for this one we just have to place the dimension. We'll either go on the outside or we can place it on the inside. So we'll just click to place. And you'll see we have the arc length symbol and its length. Next we have radius. So with the radius, we just have to select the arc or circle and then place the radius. So we'll find our position to place it. We can either go inside the circle or outside the circle. So we'll go inside. And next down we have diameter. So same again, choose the arc or circle and select the position. So we'll know the difference between the two is we have R2000 showing the radius 2000, or we have the diameter symbol and then the total diameter of 4000. Okay, so we'll close this drawing down and don't save it, so that it will be fresh for you to come back and retry in the future. Okay, so now we're back with our floor plan. So what we're going to do is we're going to apply our dimensions to our floor plan. What I'll do is I'll get you started over here on the left-hand side. And then what I'd like you to do is to pause the video, refer to the PDF, and continue yourself. So I'm going to start at the top left-hand corner. So I'm going to zoom in to my column. And first I want to place a linear dimension on the outer side of that column. So I'll select linear, select my first point at the top left-hand corner, and come down to my second point on the bottom left-hand corner. And then the third action is to place my dimension. So once we've placed the first dimension, I'll then press the Enter key to re-engage the dimension tool. I'll then start my second dimension at the point where my previous dimension ended. So click on the top left-hand corner of our external wall, coming down to the bottom left-hand corner, and again selecting the end point. So this will give a dimension length of that wall. So the third action is to come back and just align it with the previous dimension. So we'll snap back to that, selecting the end point of that line. So we can see our dimension is now running in a straight line. And I'll just continue down, pressing Enter, attaching to endpoint, and then finally snapping back to the previous dimension. Enter to re-engage, endpoint to endpoint, and snapping back to the previous dimension. So you see we're creating a nice dimension run showing the length of each of the components. So we have our length of the column, the length of this external wall, the length of the next column, and then the external wall. So I'll enter to re-engage, select my column, snapping back to the previous dimension. And then lastly, I have just a little section here which I'm going to dimension. Snapping back to the previous. You'll see that some are overlapping. I'll come back in a few moments to revise these and to tidy it up.
So see now that our lines have changed from being running on the Y or X axis, or horizontal and vertical axis. We're now looking for the aligned dimension to run on the outside of the bay window. So we'll change over to the aligned dimension, and we'll go from the corner of the wall to the opening of the window, and click to place, enter to re-engage, and then the opening of the window. And then finally to the edge of the bay window. So now that I have created that, you see I need to do a little bit of tidying up. So I'll come back to the top. And so how I adjust my dimension, I'll select it first. And we can remember from the previous video all of what each one of these grips does. So the ones attached to our component, we can adjust and change the desired dimension. We want to know the total length, so we'll keep it as is. Then the next dimensions, we're able to change the position of that dimension. And then to alter the text position, we have the blue grip over the text. So when I hover over that, I get my additional options. So you have two options you can use here. You could either use the move text only, so we could just place the text above the dimension line. Or if you prefer, you can also add a leader just to pull the dimension out. And we then know that it's referring back to this dimension using that leader point. So I'm going to use the move text only and just place the text just above the dimension. And move down to the next and do the same. And here I've got two dimensions overlapping each other. So to select the text, I'll come to the dimension I want to change first, which is the column. So I'll select the dimension run instead. Once that's highlighted, then I can come back and there's my blue grip. Hover over, move text only. And then finally for this small section here, I'll use the move with leader. And for this dimension run here, my text is on the inner side of the dimension or above the dimension. What I want to do is to push my text below the dimension line. So I'll select my dimension, hover over the blue grip, and I'll go move text only and just bring the text down below the dimension line. And I'll do the same for the 1800. Okay, so I've got you started on one side of the building. So looking back on the PDF, I want you to continue around the building, matching what I have drawn. So if you'd like to pause the video now, and then afterwards I'll continue on and apply these myself. Okay, so we'll get started. We'll continue working our way around the building. So I'll add my angle and then another run of dimensions. So to create this 60-degree angle here, I need to select angular. I'll select the horizontal line in the front and the angled line. So if I come on the left-hand side, I get the inner angle. I want that outer angle. So move my cursor out to the right-hand side and click to place. Then move up and change back to linear. So we place our linear. Just pressing enter to re-engage the dimension tool. Then move up to the fence. Then up to the top, we have two different types of dimensions. We have our arc length and our radius. And then just changing back to linear, I can get my width of the fence first, and then from the edge of the fence all the way back to the column, and then connecting back to the previous dimension. And then we got the width of the column, the length of the wall, and the width of the column. Then working internally, we'll go the inner side of the walls. When placing your dimension, just be sure that you're connecting to the correct snap, as other snaps will try to interfere. Then moving on to the internal walls. And we'll leave it at that. We'll then work our way, we'll go back around and we'll just alter where we have overlapping issues. So there's our 200. Because it's quite a dense location, I'm going to use my leader. Pull it away. Press escape to cancel that. Then select the next one. Again using my leader. And escape to deselect. We'll then move this text above the dimension. And then working our way into the inner dimensions, just putting the text above the dimension again. And as we have two dimensions which are running quite close, for the second one I'll use the leader. And same, I'll use the leader here. So we'll now move on to our next annotation feature, which is called a leader. A leader just essentially connects annotation to a feature. So if we're trying to point out some information on the drawing, simply by placing text beside it isn't necessarily always as clear as we want it to be. So for example, here we have our radius of this curve, and attached to that is a leader pointing directly to it. So that's what we're going to move on to and create next. But just as we've been using our text style and dimension, we first must create a leader style. So the leader will remain on the dimensions layer. And it's the same process like we have done before. We'll go to the annotation drop-down arrow. And the third one down is our leader. So when we select it, it will open up our leader style manager, or what is called a multi-leader. Again, we have the annotative and standard styles. The dialog box is very similar to our text and dimension style manager. So we have a preview, a list of styles, set current, new, modify, and delete. And we'll always start off with the standard as our base. And what we'll do is we'll now select new. And we will name this one. The leader style will just be 1 to 100. And we're starting off with a standard. Press continue. So here you have a good example of what a leader is. It's just basically an arrow with a line pointing back to the text. So here's a good example of what the leader is. We have our text with a line coming down to an arrow to show what we are trying to annotate. So we have three different tabs. Our first is the leader format. So that is referring to the format of this leader here. The first section here is the general, so our type. We have straight, so our line is straight. We can change it to a spline, so it has a curve to it. Or we could have none. But then essentially what we've created is just a piece of text. So we'll keep it at straight. And we want our colors to be controlled by our layers. So we can come back to our layer manager afterwards and change the color there, which will change all of our leaders and dimensions at once. So we'll use our by layer. Next we have our line type. So the same applies to that. We can have a particular type of line for this if we wanted, but we want our layer to control that. Same for the thickness. We want our by layer to control that. Next down we have our arrowhead. So just like our dimension styles, we have the same symbols here. So we can choose any one of these to be our arrowhead. Again, this can be overruled by your Office standards, but for our example, we're just going to stick with the closed field. And then next we have the size, so it's at 4. So the arrowhead size is 4, which is 4 mil on our sheet of paper. So right now our example is showing a text height of 4, and our arrow size is also 4. And our final text height, which we want to display, will be 2.5. So I'm going to reduce my arrow size down to 2. So it will be 2 millimeters on our sheet of paper when printed. So you'll see when I change my size to 2, our arrow size has reduced down to 2 mil in comparison to our text, which is currently set to 4 mil. Next we come down to leader break, showing our break size of 3.75. This is part of a feature which we'll cover later on in the course, which we can then refer back to this so we can understand this section a bit more. Next, we'll go over to our leader structure. So the structure of the leader, we currently have a maximum of 2 leader points. So what that is referring to is when we place our leader, we have 2 actions. We click to place where we want our arrow, and the second click will be the point for our, which is called our landing. So again, when we place our leader, we have 2 actions. Our first click will be the arrowhead, and our second click will be the landing. So if we wanted to have additional lines, here we would add in a third line. So then when we would place our leader, it would require 3 clicks. So first click for the arrowhead, second click for an additional line, and then third click
for a landing. We're going to keep it back at 2. What we can also do is we can fix the angle of our line. So when we place our leader, again, our first click is the arrow, second is the landing, we have control over the angle of that line. So we can draw it relatively straight, we can add in small 10-degree angle, we can go full 90 degrees, that's up to us. If we wanted to keep continuity with all of our leaders, what we can do is we can restrict this angle to a particular degree. So first for the example, I'll keep it at 0. I'll demonstrate this once we come out of it, and then we'll go back and we can change our angle. Next, we have the landing settings, which is referring to this horizontal line by our text. That's our landing. So first we have automatically include. So do we always want one there or not? If we switch it off, we will no longer have a landing attached to it. What we can also do is we can set the landing distance. So it's currently set to 8. So if I bring that up to say 15, we can increase the landing distance. For this example, I'm going to bring it down to 4. And next is our scale. Again, the annotative is something we'll cover later on in the course, but for now we'll keep it basic and we'll specify our scale at 100. So this meaning when we bring our leader into our drawing, in our model space, everything will be multiplied by 100. So where we put our size of our arrowhead is 2 mil. So in the model space, it'll be 200 mil. We'll then go on to the next tab, which is our content. First one there is the multi-leader type. So we have mtext, which stands for the multi-text. So referring back to when we placed our text, we had 2 options. We had the single text and we had multi-text. So there's our mtext, which is shown now as our default text. And when we have the mtext heading, we have the following options. We have our text options or default text. So our default text is set to default text, which has been displayed in the preview. If you wanted, you could change that default text. You can see here I'm being prompted to type in something else, so I can just type in sample text. And then once I've typed in my text, I can go to close text editor and it's now displaying sample text. If you wanted, for your preview box, you could type in something different, but it's best just to leave it at default text. Next, we have our text style. So there we have our Arial 1 to 100, which we created previously, our standard annotative, and also the Verdana 1 to 1. So if we choose the Arial 1 to 100, as we know from our dimensions, the text height is locked in at 250. So with our text height here locked in at 250, and our scale at 1 to 100, our text height would actually then become 25,000. So it would be way too big for what we want to create in our model space. So that's why we created the Verdana 1 to 1. So when we bring our text back to Verdana 1 to 1, we then have the option of changing the text height ourselves. So we'll bring that down to 2.5, and our preview is becoming what we want to achieve. So coming back up, we have our text angle. So we can keep it horizontal as we insert it, or we can also change it to always right reading. We'll keep it horizontal. We have our text color. So we have our leader on our dimensions layer, which is showing as red. So if we wished, we could have our text as a different color, or we can keep the whole thing by layer and just control everything by the layer. And we can have it always justified to the left. And as well, we can add a frame around the text. So now just coming back to the leader type, if I change over to block. So just as we've done before where we created a window block, we can also create a leader block and then load it into this library as well. We're also given a small library from Autodesk as well. So we have our source block, we have a detail callout. So the detail callout will display the view number and the sheet number. We have another one for our tag number. So we just have different types of blocks which we can change the information on the inside. This particular type of block, we will create one of these later on ourselves, and I'll show you how we can alter this text quite easily using what is called a dynamic block. We'll cover that later on. Then we have how it's attached. So how is our leader attached to our block?
We have center extends or at the insertion point. So where our block is then inserted out of the library. And our color, so how we want to color it, or do we want the layer to control all of that? And as well, we have our own scale. We also have none, which essentially then will just leave us with a leader and no information. And we'll just revert back to mtext and we'll keep all of the information which we have entered in previously. And lastly, we have leader connection. So how do we want our leader to connect to that text? We have, first is the horizontal attachment. So with the horizontal attachment, we'll come down to the information. So when our leader is horizontal, i.e. there's our landing coming across it horizontally attached to our text, how do we want the leader and landing to attach to the text? So first we have our left attachment. We want the landing to be in the middle of the top line. We can also go top of the line. You'll see it will adjust in the preview. We can go bottom of the line. We can underline the top line, middle of text, middle of bottom line, the bottom of bottom line, and underline all text. So I find it best just to be at the middle of the text. And same again goes for the right attachment. So when we have the leader on the right hand side, how do we want that attached? How do we want it to attach to the text? Again, I'll go to middle of text. And then we have a landing gap. So the gap between the landing and the text. So if I increase that to 5, you'll see the distance increases between the landing and the text. But I find 2 is just about the right distance between a landing and text. And if we want, we could also just extend the leader directly to the text. We'll then change over to the vertical attachment. So if you wanted your leader to be attached vertically, you can also do that. And we have the various different options. So for the top attachment, so if the leader is at the top of the text, we have it, do we want it to be centered? Or we can have an overline and centered, and same for the bottom, we can apply an underline and center it. And again, we have our landing gap. But for the style I want to create a horizontal attachment. So then to complete our actions, we'll just press OK. And we've then created our 1 to 100 leader. It's highlighted in blue, so it's set to current. Just to confirm that, I'll just set current as well and close it down. So there's our leader at the top. Just to confirm that our leader is currently active, hit the drop down arrow for the annotative, and there's our leader and 1 to 100. So I'll just select leader and I can zoom into my fence. I'll attach there to the midpoint. So one click of the mouse. And when I press the leader, you'll notice that my leader is coming across at 0 degrees. So that's a mistake on my point. Reason being is I come back to the leader style manager. I'll select modify to modify the leader. Come to the leader structure, and I forgot to turn off the first segment angle. So when it appears in the drawing, it's coming in at 0 degrees. So we'll turn that off, press OK, come back to the drawing, and I'll select leader. I'll go to the midpoint. Now just one click to place my arrow, and now I have full freedom to apply my own angle for the leader. Second click will place the landing. And do I want to override the default text which was placed earlier? Yes, I do. And here we'll type in fence, and you'll notice my text editor is displaying the M text. So the multi-text options are being displayed at the top. So I have full range of being able to modify that piece of text. Once complete, click close editor. There's my fence text. So we'll go back now to our annotation drop down arrow. And we'll open up our leader style manager. And with the 1 to 100, we'll go back to modify. And when we have our first segment angle, I will change that to now 45 degrees. So when we place our leader, the first segment will always be at 45 degrees. We'll then come to our content and our default text. When we're placing our leader, we don't want to have any default text to appear because we're going to enter in our own.
So I'll choose the three dots to open up the editor. We'll delete it and press close text editor, and that will go back to default text. We'll then press OK and close. So now when I select my leader again, so you see when I go hover over my fence, so the leader is looking for a snapping point to attach to, but if I wanted to attach to the fence at this point here where there's no snapping point, so what I need to do is to turn off my object snap, and now I can place my leader freely on the fence. And when I move my cursor away, you'll see that the angle is fixed at 45 degrees. So I can go 0, 45, and 90. So once it's placed at 45 degrees, one click of the mouse to place my landing, then it will go into my text. Again, I'm just going to type in fence for the example. If I had a second row of information, press enter and I can type fence again. And then to complete, I'll either go to the text editor, the close text editor, or just click outside of the leader, and there's my text with my leader. So I'll go place another leader just below. And to keep continuity with my leaders, because you could have many leaders on your floor plans, and you don't want them all to be different shapes and sizes and not aligned. You want to keep continuity. So the best thing to do is to apply that angle for the line so it looks very nice. Having the leaders parallel looks very clean, but you also want your landings to appear at the same distance. So to do that, you'll just come up to the landing. But to do that, we'll have to turn our object snap back on. So hover over the start of the landing and move away. And once you leave a snap reference point on the leader, you can then move your cursor down to meet yours. When they're aligned, one click of the mouse, and now our leaders are in line with each other. And now our leaders' landings are also in line with each other. And we can type in our information. So when I move my crosshair, you can see that our landings are directly above each other. So we're now going to move forward from the annotation. At this point of the course, what I've done is I have given you the basics of all of the various different parts of AutoCAD. So the basic ways in which we can draw, modify, annotate, apply layers, create a block, and the properties of what we have drawn. So at this point, what I'm going to do is I'm going to show you how to create a layout so we can finally print what we've created. So we'll move on to what are called layouts. So what we have been doing throughout the whole course, we've been creating our drawing in the model space. And what we want to be able to do is to transfer what we have created onto a sheet of paper at the correct scale, so it can be legible when handed over to the client. So down in the bottom corner we have model, which is we're in a model space currently. And next we have layout 1 and layout 2. These are what are called our paper space. So we'll select layout 1. So essentially a layout is a page that allows you to set up a plot or printout of your drawing on various paper sizes and scales. So in the background you'll see a big white rectangle. That is actually our sheet, which we're going to be printing onto. And typically on our layout, what we're going to see is we'll see what is called a viewport, which is this rectangle in the middle. If you don't have that on your screen right now, or it will look different to what I have, don't worry. I'll explain what that is in more detail. And if you don't have it, we're going to create a brand new one in a few moments. So our layout will have our sheet of paper. It'll have our viewport, and it will also have what we call a title block. A title block essentially just titles our drawing, so it gives us the name, drawing number, date, revision, who drew it, all that kind of information. As well, it will have your company's information, your company's crest, contact information, and so on.
So the sheets of paper in the background, we can change that to any size we typically want. My experience on within construction, you're typically going to print on an A0 right down to an A4 sheet of paper. So down at the bottom we have our Layout 1 tab, and to the right of that we have Layout 2. So we'll always have 2 by default, and if we wanted to create an additional layout, to the right of that there's a small plus symbol. We'll select that and we'll create a Layout 3. Now within AutoCAD we have many different ways in which we can carry out the same action. So I'll go back to Layout 1. Up the top in our tabs we see now that we're on the Layout tab at the bottom. We have a Layout tab at the top. So if we select the Layout tab at the top, it'll open up our Layout ribbon. So first thing we have is our Layout panel, and in here we're able to create a new layout. So if we select New Layout, I'll be prompted on my dynamic input to give it a name. As we have Layout 1, 2, and 3, it's offering a name of Layout 4. At this point, if you had been naming your layouts, for example, floor plans, elevations, sections, at this point you could name that before it's created, just to save you a little extra step. But we're going to continue with the name Layout 4, so I'll press Enter. If you have Layout 5, 6, 7, don't worry. This is all just for explanation, so don't worry if your names are not the same as mine. So back up to the new section, we have New Layout, and we have From Template. So what we're able to do is we're able to create templates of our layouts. And the reason we'll do that is because we're going to create a title block. We're going to put in our own viewports, our own information, and to save us creating that again and again, we can save that as a template file and then bring it into the project through this way. So another way in which we can create a new layout is we'll come down to the Layout tab at the bottom, and if I right click, at the top there we have New Layout. So there I've just created Layout 5. We can also type in layout into the command line and we can create new. So whichever way you find the quickest and easiest, just stick to that. There's no right or wrong, it's just personal preference. You may find that the right click new is quicker than to come to the Layout tab and select new from here. So the next thing we do when we have our layout is we need to change the settings. We need to change and set up our page. So we do that in the Layout panel. We have Page Setup. So we'll select the Page Setup and we see our Page Setup Manager. So we're on Layout 1 and you see in our Page Setup Manager our current layout is Layout 1. We have all the different layouts listed below and some additional information about the layout. So we have our device name, which will be the name of your printer, and below that we have our plotter name, so that will describe the type of printer. Is it an A1? Is it an A0? Then we have our plot size, so it's telling me that this current sheet of paper is 210 by 297 in landscape mode. So if you're not aware, that particular dimension is an A4 dimension. Next we have where. So what this is describing is where is your printer. So in an office scenario, you could have 2 different printing rooms. You can jot down in the description the location of that printer. And then lastly, we have description. When we create our page setups, we can add in a description about what we have put into that particular setup. Okay, so we have Layout 1. So we'll select Layout 1 as our default, and we will now create new. So we'll create a new setup. So we have new page setup and we'll give it a name. So setup 1, it works for me. If you want to give it a particular name, this is where you will enter that information. And things to be mindful of in that setup will be your printer location, for example. If you had it in printer room 1 or printer room 2, you could set that up here. And what do we want to start off with? So we'll start off with layer 1 as our default settings, which we will then work on to change. The reason we have this here is if we create a setup 1
and we wanted to create something similar, this is where we could select that setup 1 to then create a duplicate of that with some minor alterations. So we'll press OK. Now we're into page setup of layout 1. There's page setup, our name, setup 1, showing that it is a DWG. And we then move on to the printer plotter. So we have the name. So currently you're not going to be connected to a printer. If you are, perfect. But if not, I doubt that we all have A1 plotters sitting at home. So the best thing to do is to choose DWG to PDF. This allows us to print the page, but we create a PDF of the page. So we don't get a physical copy, we get a digital copy. So I'll choose DWG to PDF. And next we'll come down to paper size. So we have all the various different paper size standards. We have ISO, ARC, and ANSI. So ISO is the metric standard for paper, ANSI is the imperial, ARC is the American architectural, and some of them have full bleed, so that will print from one end of the paper to the other without borders. And the expand the printed area will be larger than the standard. So I'll be using the ISO metric to continue with this. If you're using imperial, please do use the ANSI to continue on. And the size of the paper that I'll be using will be an A3 size. So I need to look for the ISO full bleed A3. What we are referring to when we have full bleed, when we have expand, or nothing else beside that. What we are referring to is the dotted line on our sheet. So this dotted line is our printable area. So anything that is outside of that dotted line will not be printed, and everything inside that line will be printed. So that is the standard printable area. If you choose the expand, this printable area will move out by a certain dimension. And if we go full bleed, that dotted line will go right to the edge of the sheet of paper. So the reason that we have this is most modern printers can handle a full bleed, but if you have an outdated printer that can't handle printing to the edge, it's best to use the printable area. So this means that you're going to get all of your drawing onto the sheet and you're not going to lose any information off to the sides. This is something you're going to have to determine yourself when you're in your office and you can test out your printer. So the sheet of paper that I'm going to be choosing is the ISO full bleed A3. And when I come to the ISO full bleed A3, you'll notice that I have two. They are both the same dimensions, but flipped. So we have 420 by 297 and 297 by 420. Essentially what we've got there is a portrait and landscape scenario. So the 420 by 297 is landscape, and the 297 by 420 is portrait. So I want to choose a landscape, so 420 by 297. So we have what to plot. We have display, extents, layout, and window. So with the display, this will plot all objects displayed in the drawing area. So everything that is displayed in the drawing area will be printed. Next we have the extent, so this plots all objects in the drawing, so absolutely everything that is in the drawing. Next we have layout, so this prints all objects in the printable area of the paper. So like we spoke about before, that's the dotted line on our sheet. And lastly we have window, so the window plots objects in the area you define. So if I choose window, I can then create a window on the sheet, and then only that will be printed. So I'll just do a quick preview to test this just to show you. And so only what I drew a window around is being displayed. Don't worry about the previews and everything. I'll cover that with you in a few moments. That was just to give you a quick demonstration. So what we want to do is we want to revert back and choose layout. So we want to utilize that printable area, and we're going to choose
layout for what to print. Next thing over to the right hand side is the plot scale. So the plot scale is very important. Everything that we have drawn accurately. And when we print it, we want the person who is then going to read our drawings to know that what is on that sheet is to scale and is accurate. So this scale is referring to our sheet of paper. So it's going to print our sheet of paper at a scale of 1 to 1. Next, over on the left hand side, we have plot offset. So what this is referring to is if our object on the sheet of paper prints and it's slightly off axis, it's not in the correct location for where we've placed it, we can then adjust our object using the plot offset. So we're able to shift our object to the left, to the right, if it hasn't been printed correctly. For most modern printers, this isn't necessary anymore. We'll now move up to the top right hand corner. We have plot style table, pen assignments. So what this is referring to is our color scheme. So if we hit the drop down arrow, we have various different types of color styles which have been created for us. So the color dependent plot style table, the CTB, they use an object's color to determine the characteristics such as the line weight. So for example, every red object in a drawing is plotted the same way. While you can edit the plot style in the color dependent plot style table, you cannot add or delete plot styles. There are 256 plot styles in a color dependent plot style table, one for each color. So we'll select AutoCAD.ctb, and what that does is it will allow us to now access the edit function. So we'll click on edit. So when we select edit, we'll open up the plot style table editor. And at the top we have 3 tabs. We have general, which is just giving us the general information about the AutoCAD.ctb. So in there, if we wanted, we could add in a description. And below is just the file information. So the number of styles is 255, the location of that on our computer. And we can also apply a global scale factor to our line types. We'll cover the global scale later on. And at the top we have just 2 ways of viewing the information. We have a table view and a form view. Personal preference for me, I prefer the form view over the table view. But again, that's down to you at the end of the day which one you prefer. So if we remember back to our color index, we have all the same colors are listed here. So our red was color 1, yellow color 2, green color 3. And in here we can then determine what will happen when color 1, which is red, gets printed, what we want to happen to that color. So the color determines the plot color of objects that use the selected drawing color. For example, to plot a red line in red, set the color property for color style 1 to use object color. To plot a red line black, set the color property for style color 1 to black. Next we have dither. So dither approximates a color by making dot patterns with one of the device's supported colors. So dithering is typically used if the plot device does not support the color you want to plot. For example, to send a color to plot to a monochrome device where each color is distinguished in a different shade of gray, enable the dithering setting so that the plot device creates dot patterns for each color. Grayscale plots objects using the selected AutoCAD color as a shade of gray instead of a color. For example, yellow is plotted as a light gray, blue is plotted as a dark gray. We then have pen number. This setting is used for pen plotters only, and it determines the pen number used to plot objects of a selected drawing color.
When plotting to a pen plotter, all other plot style table properties are ignored. A virtual pen. So the virtual pen determines the virtual pen number used to plot objects of the selected drawing color. Screening. So screening determines the color intensity of objects that use the selected drawing color when plotted. If you specify 0, the color is reduced to white. If you specify 100, the color is displayed at full intensity. Our line type. This determines the plotted line type of objects that use the selected drawing color. The default is to use object line type, which plots objects using the object's own line type. If you select a line type, that line type will override the line type specified in the drawing for the selected drawing color. The adaptive. So this adjusts the size of the line type pattern so that line objects contain complete patterns. This affects only line types set in the plot style table. And then finally, line weight. This determines the plotted line weight of objects that use the selected drawing color. Line weight set in the plot style table override object line weight set in a drawing. The line weights listed in plot style tables can be displayed in either millimeters or inches. Additionally, custom line weight values can be added. These settings are controlled using the Edit Line Type button. So for now, I want you to cancel that, and we'll come back to our page setup. And our first thing there is shaded viewport options. So here we have the quality of the drawing. So this section at this point, if you have a modern printer, is pretty much obsolete. When we had the old printers and ink and everything was very expensive, this was very important. Instead of printing out an A0 just to use as a test print to see if everything is correct, which would cost quite a lot of money, you could reduce the quality of the drawing down by adjusting it here to the draft option. And then once complete, you could then up it to the maximum or presentation if necessary, but generally normal is more than enough. So after the quality, we'll come down to the drawing orientation. So we're able to then flip it from landscape to portrait if necessary. And we also have the option to plot it upside down. Lastly, over in the bottom left-hand corner, we have preview. So after making all of our changes, we can select preview. And we'll get a quick print preview of what we're about to send to the printer. And up in the top left-hand corner, these are our actions within the preview menu. So we have pan. So we can pan the drawing. We have zoom. We have a zoom window. And we have zoom original and the X to close back and come back to our page setup. So we'll just press OK. And it will bring us back to our page setup manager. So we have setup 1, set to current, and close. So you see in the background, our page has increased in size. It was originally an A4. We've now doubled that up to an A3. And you can see that by my viewport looks smaller on the sheet. If you don't have a viewport on your sheet, don't worry, as it is not necessary right now. Another way to access the page setup is we can right-click on Layout, and there we have our Page Setup Manager. We can also come to the menu button. We can go to Print, and there's our page setup. As well, there's our plot and our plot preview. So we're now going to be looking at what are called viewports. A viewport creates a framed area which displays a view from the model space into our layout, which we then apply a scale to that.
So why do we need viewports? We use viewports as a portal to view from our paper space back into our model space. So let me demonstrate why. We'll go back to our model space. And what I'll do is I'll copy out our lamp and pull it over to the left-hand side. And I'm going to change over my layer to dimensions. And I'm going to give a linear dimension across the diameter. So in our model space scaling, you can see it down the bottom right hand corner, a scale of 1 to 1. So the current diameter of this lamp is 356 millimeters. What I'll do is I'm going to copy this into our paper space, so you can see just how big this will be on our sheet of paper if we left it at a scale of 1 to 1. So I'm going to highlight the lamp and the dimension, and using my Windows keys, which is Control C, I'm going to copy it. Come back to my layout and Control V, and I'll paste it over my sheet of paper. So if we wanted to try and print our lamp at a scale of 1 to 1, you can see it's much larger than our sheet of paper. What I'll do is I'll just apply dimensions to our A3 sheet. So we can see our A3 sheet is 420 by 297. So again, if I come back to my model space and using my rectangle command, 420, 297, there's my A3 sheet of paper. So I'm going to move this into my floor plan. And we want to fit this entire floor plan onto this A3 sheet of paper here. So what we need to do is we need to scale our floor plan down in order for us to fit it onto our sheet of paper. So I'll delete this and come back to the lamp. And then I'll go back to my layout tab. And I'm going to delete the dimensions. And I'm just going to move the lamp and the dimension over to the right hand side. And I'm going to give you an example of how we can use that viewport to scale it down. This is just an example. In a few moments I'm going to show you how we can do that together. So I'm just going to expand out my viewport. Turn off my grid so it's easier to see. I'm going to find my lamp. And there's my lamp with the dimension. What I'm going to do is just apply a scale of 1 to 5. So here on the right hand side we have the lamp at a scale of 1 to 1 with 356 millimeters. And on the left what we've done is we've utilized our viewport to scale that lamp down by 5 so we can fit it onto our A3 sheet of paper. So the lamp remains the same size, the dimension remains the same size as well, but when you scale an object, what you must do is you must add a piece of text on the sheet of paper to denote what your scale is. So the person who then reads the drawing knows exactly what scale that is, and they can then scale it back up to the correct size. So I'll just quickly add a piece of text. So this is a very brief demonstration on why we need a viewport. What we're going to do now is we're going to dive into this much further so you can have a better, clearer understanding of what we're doing. So in front of you on my layout, you see we have this rectangle. This here is our viewport. So if you don't have this on your drawing, don't worry, because we're going to delete this from our layout. And I'm going to show you how we can create a layout together. We have our sheet of paper in front of us, which is our layout. And what we now need is to be able to place our floor plan onto this sheet. And we do that by using viewports. So the first thing we need to do is change over our layer. So we'll come back to the Home tab, go to the Dimensions, go to the Layer Select, and change over to Viewport. So when we created our viewport layer, there was one important thing that we did. I'll open up our layer properties. When we created our viewport layer, we turned it off for printing. What that means is when we go to place our viewport, we'll have this big rectangle on our sheet, but the fact that we turned our viewport layer off means that that rectangle will not be printed. So now come back to my Layout tab. In the Layout Viewports panel, we have Rectangular. So we'll select Rectangular and we'll draw our rectangular viewport, nice and big, all within inside the sheet. And you'll see that we get an image of our model space. So everything that we have drawn in our model space is now being displayed in that viewport. So this viewport is an active view. What that means is if I bring my cursor inside the viewport and double click, you'll notice that the viewport line has gone from a thin line to a thick line. You'll also notice, which is very similar to our model space, we have our controls at the top left, we have our controls on the top right, we have our view controls, and the bottom left we have our UCS. The reason being is we are now inside the model space. So we've placed basically a portal from our sheet back into the model space. So we're now in the model space. So if I drag, I can pan, I can zoom, and this is how we're able to place what we have drawn in our model space onto our sheet of paper.
So as this is a portal back into our model space, what we're able to do is we're able to make changes to our model space through our viewport. So for example, if I was to just draw a quick line in my active viewport going back into my model space, if I come outside of my viewport by double clicking, go into my model space. So here we have the lines which I've just drawn through an active viewport back into my model space. So if I come back to my layout, double tap inside the viewport, I'll select those lines and delete them. Come back out of my viewport, back into my model space, you'll see they're now deleted. So I'll come back to my layout and I'll find my floor plan.
What I'll do is I'll just roughly place my floor plan in the location I want it to be. And then to deactivate my viewport, I'll come outside the viewport. So I'm back into my layout and double click. And you'll see that the nice thick lines has gone back to being a thin line. And then if I zoom, you'll see I'm now zooming my sheet. I'm not zooming inside the viewport. So the viewport is deactivated. Now with AutoCAD, we want to be very accurate with what we're doing, and scaling is very important. So when we created our text, dimensions, and leaders, we set all of our scales at 1 to 100. So when we scale our floor plan at 1 to 100, for every 100 millimeters of our floor plan, it is displayed as 1 millimeter on our sheet. So it's 100 times smaller, and we can fit it onto our sheet. So what we need to do is we need to apply that scale to the viewport, because all we have done is we have roughly placed our floor plan in the center of our sheet, but it has no scale attached to it. So to change our scale, we have a couple of different ways in which we can do it. The first way which we can change our scale, what I'll do first is I'll just copy this over to the side so you can see the difference when we make the changes. Okay, so the first thing I'm going to do is select the viewport. And in the middle we have two grips. We have the square grip, which just allows us to pick the viewport up and reposition it. And to the right of that we have a triangular grip. With one click we get a list of scales, and we want to rescale this drawing at 1 to 100. So when I click that, the viewport will apply a 1 to 100 scale, and you'll see the drawing will get smaller. So our floor plan has gotten smaller. We know that it's accurate at 1 to 100, but you'll also notice the viewport itself shrunk as well. So if you only wanted to change the scale of the floor plan and not make any changes to the viewport, what you do is you'll double click inside the viewport. So I'll apply that to the viewport on the right. So double click inside the viewport. So it's now activated. Then I'll come down to the bottom right hand corner and there is my scale. So hit the drop down arrow and there's my full list of scales and I'll choose 1 to 100. And this time you notice that only the floor plan has rescaled itself while the viewport has maintained its shape. So now when I select the viewport, you come down to the bottom, you'll see there's my scale 1 to 100. And if I select the viewport on the left, you'll also see my scale is 1 to 100. Now you'll come across many different types of scales. For example, a typical floor plan will be 1 to 50, 1 to 100, and 1 to 200, depending on the size of your project. You'll have an elevation at 1 to 50 or 1 to 100, again, depending on the size of your project. For site plans, your site plans could be at a scale of 1 to 500 or 1 to 1000. And for particular land registry drawings or some government site drawings will require you to be at a scale of 1 to 1250. So to create those different scales, what we need to do is select a viewport, come down to our scale, hit the little drop down arrow, and we can then select custom. This will open up the edit drawing scales dialog box, and in here we create the bespoke scale. So what I'll do is I'll click on add and we'll name it. It will be 1 to 200. So we'll keep the same format as the originals. So then we have our paper unit and our drawing unit. So our paper unit will be 1, our drawing unit will be 200. Press OK. And it will just be thrown in at the top of the list. So we need to just move it down into its correct location, just below 1 to 100. Press OK. So now when I select my viewport, you'll see it is now included in my list. So there's a third way in which we can adjust the scale. If I double tap inside the viewport, type in Z, enter. I then type in the scale at which I want my floor plan to be. For this example, I'll do 1 to 50. So I'll type in 1/50 XP and enter. So that will rescale my floor plan at a scale of 1 to 50. So that was Z, enter, 1/100 XP, enter. So this is all depending on how you want to achieve your scale. The easiest would be to just simply select the viewport and adjust the scale in the status bar here. I'm going to delete out the viewport on the right and just recenter my drawing. So when we created our text and our dimensions and leaders, we specified that we wanted our height at 2.5. So now that we've correctly assigned our scale, I will zoom in, do a little dimension. And there we can see our printed text height will be 2.5 millimeters. And in the model, that same text height is 250 mil. So another way in which we can activate and deactivate our viewport is down here where it says paper. So to make our viewports active, if we click paper, we'll see the viewport becomes active and it now says model. And then to revert it back, we'll click model and it's now showing paper. The reason I'm showing you this is it may happen in the future where you zoom in to the sheet, you accidentally double click, which activates your viewport. So I'm now in my viewport. And if I try to zoom out, I'm not able to come back into the layout space because I'm currently in an active viewport. So I don't have the option of double clicking outside of the viewport. I'm kind of stuck inside the viewport. So to deactivate the viewport,
click on model, bring me back to the paper space, and now I can zoom out and I'm back to my sheet. And then I just want to bring my floor plan back into the center. So when I want to do that, if I just select the viewport and change my scale, the viewport will zoom in and scale the center of the viewport. So our drawing is down here. If I click on 1 to 100, it'll zoom up, but it's not showing my floor plan because the floor plan is further down in the model space. So I'm going to Control Z to undo. So a good tip is to activate the viewport, zoom into your floor plan, get it in the position at which you want it to be placed, and then change your scale. Now we know our plan is where we want it to be and it's at the correct scale. And then I'll double click outside. What we want to do is we want to be able to lock our viewport so we don't accidentally activate it and go inside the viewport. So with the viewport, what we can do now is use our grip to reduce it down in size so we only see our floor plan. So we're only displaying the information that we want to see. Because we want to add in other bits of information on our sheet. And now once we've done that, we then want to lock it so we don't accidentally go inside and adjust the scale. So I'll go back to my layout tab, and in the layout viewports we have a lock. So we'll select lock, select the viewport and press enter. So now our viewport is locked. So if I double click, I activate the viewport, but if I try to zoom in, the scale of the drawing doesn't change, but I still have access to change the model within the viewport. So locking your viewports is very important and very good practice within AutoCAD. If we want to unlock our viewport to change the scale, it's the same process. You'll come back, change to unlock, select the viewport and enter. And now you can zoom back and adjust the scale. So we'll just apply a lock to our viewport and enter. So I want you to save this file and then I want you to open the file attached to the resources called Viewport Freeze. So here I have 4 viewports and they're all referring back to one drawing in the model space. So if I open up the model space, you'll see there I have just one drawing. So back in the layout. So if I activate one of the layouts and I draw a line, you'll see that it will take place in all 4 viewports because we have 4 views, but all referring back to the same drawing. Now the purpose of this is to show you that we're able to freeze and turn off certain layers. And the benefits of this is if we have one floor plan, what we can do is we can place all of the information on that floor plan. So all of the text, the dimensions, furniture, some details. And this means that your model drawing will have a lot of information on it. It will look very busy and untidy. But when you go to your viewports, you can turn off a lot of information. So if you just wanted to show the dimensions, you can turn off all of the furniture, all of the details, all of the text, and you'll only display the dimensions around the floor plan. Again, you can have another floor plan which will only show the furniture, so there's no text, there's no dimensions. So it's just various different ways in which we can utilize the features in AutoCAD. To save us drawing the same plan multiple times, we just draw it one time, and then using our viewports, we can turn certain information on and off. So what I'm going to do is I'm going to leave the top left-hand viewport as is, so we can have that as our reference. I'm then going to come over to the top right and I'm going to freeze the furniture. So if we double click to activate the viewport, we're then going to go to our layer select. And here we have our different options. So we have turn our layer on off. We have freeze or thaw in all viewports. We have freeze or thaw in current viewport. And we have lock and unlock a layer. So what we want to use is the freeze or thaw in current viewport. So when I select that option, you'll see that all of our furniture is now frozen, but only in that current viewport. So we'll double click to come out of that viewport and then come down to the bottom left. Double tap to enter and we'll go back to our layer select. And I want you to freeze the hatch layer. So we'll see all of our hatching has been frozen. And in the bottom right, we can freeze our door and window layer. So our top left-hand corner viewport contains all of the information, and you'll see we have 3 additional viewports which display varying degrees of that information. So this is a great use of the freeze in current viewport. To bring the furniture back, you would just open up the viewport, come back and thaw in the current viewport. And we're just going to close down the drawing, and my advice is not to save it, so we can come back to it in the future and it will be back to the original.
Now that everything within our project has been created, we are now going to do the final setup for printing. First thing is we'll come back to our model tab. And I'm just going to erase these additional fence leaders. And to remove the double fence text, so it just reads fence. Once we've done that, we'll come back to our Layout 1 tab. And currently we don't have a title block on our sheet. So in the expert level course, we will create a title block from scratch. But for now, what I want you to do is to import a title block which I've created for you so we can place it on our sheet. So we'll go to our open folder. And within there we have our introduction day 3 title block, and we'll open that. So what we have here is an example of the title block which we'll create in the expert level course. And how we transfer this title block from this drawing into our project is we'll simply select it and we'll use our window keys to copy it into the Windows clipboard and then paste it into our project. So we'll select Ctrl+C for copy. It's now in our clipboard. We'll come back to our other project and then Ctrl+V to paste it. And then I'll just click it into place, make sure that it's relatively centered on our page. If not, we can zoom into the edges. We'll select it. Using the nudge feature where we hold Control, use the arrow keys, we can nudge it into position. Just making sure there's an equal distance around the title block on the sheet. So double click my scroll wheel to get that centered on our screen, and then going to move the viewport just so it's better centered on our sheet. And coming down to the bottom right hand corner, this here is where we'll enter in our information. So our first section is our drawing name, then we have our project name, and then additional information. This particular block has been set up using attributes. Attributes within a block is something we'll cover in the expert level. And how we edit the attributes of a block is we simply double click the text. It'll bring up our attribute editor, and this is where we're able to enter in our text. So down the bottom there's our drawing title. So we'll title it as a ground floor plan. The project title is AutoCAD course. We have drawn by with my initials. We'll add in today's date. I'm going to leave that 111. So if you would like to add in today's date there. Then we have our drawing number. Typically our drawing numbers are noted as the number of the drawing and then the project number. So here we have 100 for the drawing number and 100 for the drawing project. This again all falls down to your CAD standards within your office. So this is something you'll need to double check with your CAD manager. And lastly, we have the revision. So the revision notes the stage of the current drawing. An example would be T would mean it's out for tender, C it's out for construction, and then it's typically followed by a number. So if it's C1, it means that it's currently out for construction and it's on its first revision. If we were to then make changes to this particular drawing, it would then become C2, so it's the second revision. This again all falls back to your current office standards, so it's something you need to talk with your CAD manager about. So we'll press OK and we've set up our title block. So before we go for print, we just want to double check our page settings to make sure they're correct. So we'll come down to our layout tab at the bottom, right click, page setup manager. We created our layout 1, so we'll click on modify. And for this example, we will leave it on DWG to PDF, meaning that when we go to print it, it'll create a PDF. Once we've created a PDF, you can then open the PDF and print it from there. So our page size is correct. We have an A3. Our plot area is set to layout, which is correct. We have no offset. Our scale is set to 1:1. Our plot style table is set to acad.ctb. So when we have acad.ctb, it's going to print everything in color. So if we come down to the bottom left, we'll press preview. We'll get a quick preview of what will actually be printed. So typically when we're creating floor plans or any kind of construction drawing, we generally don't print in color. If you're doing some architectural sketches and designs, then you can print in color, but generally within construction we print in black and white or grayscale. So I'm going to press escape to come out of the print preview. We'll go to our plot style table and I'll come down to grayscale. So when we set it to grayscale and press preview, you'll see our drawing is now all grayed out. Different levels of gray depending on the thickness of our line. So as it stands now, I'm very happy with how this looks. So I'll press escape. And I'll come back into my options. So we have shaded viewport options, quality normal. I'm happy with that. And our drawing orientation is set to landscape. So everything is set correctly. So we'll press OK and close. So we're now at the stage to print. So we have a few options of how we can print our sheet. We can come down to the layout tab at the bottom, right click and choose plot. We can also come to the application menu in the top left, click that, and we can select print here. So there's our plot, which is our print. We also have plot preview, so we can preview our print before we plot it. We also have the option in the quick access panel at the top, so drop down menu. We have plot preview and plot, so I have them both turned on. So here's our plot preview and here is my print. You can also type in PLO, which will be the hotkey to print our drawing. So I'm going to go down to the layout tab at the bottom, right click and select plot. When we open up our plot dialog box, you'll notice that it looks exactly the same as our page setup. So everything that we specified before and saved it as our page setup is currently being displayed. So everything is correct. We now just click on OK. And it's now looking for a place to save the PDF. So for now, I'm going to go to my desktop. And the file name for the PDF is being generated automatically as AutoCAD Course Project 1. layout 1. So the layout 1 is referring to our layout tab in the bottom left. So I'm quite happy with the file name for now, so I'll press save. And our PDF has been generated. If at this point you wanted to then print your drawing, you can do it from within the PDF. You can go to your file and print. And what I'll do is I'll just click the X to close that down. And back in the drawing, you'll notice in the bottom right hand corner, we have an information bubble. So it's currently telling me that no errors or warnings were found. So that means that the print job was successful. If you had any type of errors, they would be displayed here. Examples would be miscommunication to the printer, so the full print won't be displayed. Other errors would be that there's no paper in your printer, or you're running low on ink. And we can click the X to close that down. And now we've successfully printed our project.